Start. So, good afternoon, बच्चों. Am I audible? Am I audible? What are you guys saying? Hello, hello, hello to everyone. So, how are you all? Am I audible? Just tell me. Hello. Good afternoon, good afternoon. Good afternoon, Olivia. So, how are you all? Fine? Scared? Nervous? Because we are in the end game now, right? IIT and next exam are just like, very close. So, what is happening? Are Manish. So, how is Hindi audience on English channel? So basically this is on English channel, so the language will be English only, right? So in today's lecture we are going to cover full complete organic, and we are going to do MAHA revision of that. Basically the point is the best way to do revision is through questions, right? So it's not like I will just do questions. I will explain some theory, then I will give you some questions, and then I will give you some time to do the questions, and then I will explain the question, right? See, I can also explain the question beforehand, but the point is if I will give you time to do the questions and you will do them yourself, so that will be much better for you. Your revision will be much better. Okay, so the point is this session will be going on till this whole organic will not be done. I won't be covering biomolecules, I will tell beforehand. So I am not covering biomolecules in organic. Biomolecules you can revise on yourself. We'll cover the whole organic other than biomolecules like GOC, stereochemistry, structural isomerism, IUPAC, your reaction mechanism, reagents, carbonyls, all that stuff we will see, and we will see the questions as well. Okay, so are you excited? Speak louder. Is my voice not audible? So are you guys excited? Let's continue. Let's start. See, I will give breaks after every 1.5 hours or after every 2 hours. I will give 5 to 10 minutes break, because just teaching continuously you won't be able to understand also properly. I won't be able to teach properly as well. So we'll take breaks. We'll take short breaks, 5 to 10 minutes breaks after every 1.5 hours. So after every 1.5 hours, you get up from your seat, go listen to music, have some snacks, come back after 10 minutes, and then we'll start again. Okay, so that is how we are going to continue today's session, and this session will go on. My limit is till 10 p.m., 10:30 p.m. My limit is that. So I am looking to complete that till that. I'm looking to complete the session till 10 p.m. or 10:30 p.m. So those who are serious, those who are really serious, will sit and watch and will do the revision of the complete organic, right? And I can guarantee you, if you will take this lecture, after that you will go back and you will revise these notes which I am giving you, and then you will do your organic DPP. Your organic will be solid. Okay, you will easily be able to do 4 out of 6 questions in IIT after this revision if you are weak in organic. That's what I can say. And if you are moderate, if you are strong in organic, then obviously you can score 6 out of 6 questions in organic in IIT as well. Okay, so let's start. Start and end fast. ना end fast तो नहीं होगा. Okay. Almost 10 hours. Okay, so let's start, right? So give me a thumbs up. Everyone just give me a thumbs up emoji so that we can start. And just tell me if my voice is fine. Just give me a thumbs up and tell me if my voice is fine. We are going to start. We have wasted our 5 minutes for the introduction. We will not waste any further time. Just give me a thumbs up so that we can start. Start. Let's start. Okay. So we'll start with IUPAC nomenclature. Obviously, to name the organic compounds, we'll see first. Okay, so see, the things I have written before, so we'll do the questions. So I will just explain some things. Okay, I will also understand chemistry today, you will also understand chemistry. Okay, we both will understand, we both will do some questions. Okay, so in IUPAC nomenclature, the basic rule that you have to follow is this: secondary prefix, primary prefix, word root, primary suffix, secondary suffix. Now what is this? So see, secondary prefix contains all the substituents. Okay, all the substituents that are in your organic molecule will be contained in secondary prefix. Okay, then primary prefix is your cyclo. So basically, if your molecule is cyclic molecule, then you will add cyclo before the main name of the chain. The primary chain is word root. So the name of primary chain, PCC, primary carbon chain that you will select, will be word root. Then if your primary carbon chain has a double bond or triple bond, then in the primary suffix you will add -ene and -ine. So -ene, -ine, whatever. Okay. So if it is double bond, -ene, if it is triple bond, -ine. Then secondary suffix is the most important thing. So here you will add your primary functional group, P, F, G. So you will have to identify primary functional group and then you will add your primary functional group, add the secondary suffix. So this is the rule. Then the point is, if this is the rule, the main thing here is how to select the primary carbon chain, P, C, C. So how will you select this primary carbon chain? So here are some rules. Okay, so these are the rules. So you don't have to see all of these. I will tell you which you have to see, which can be asked, because there is a limit of an exam. Okay, so basically, remember this rule. Okay, okay. So for primary carbon chain, you will see number of multiple bonds, the maximum number of multiple bonds, whatever multiple bonds are there, double or triple, whatever. First of all, you will see maximum number of multiple bonds. So if the chain has 3 multiple bonds and another chain has 4 multiple bonds, so the chain with 4 multiple bonds will be your primary carbon chain. Okay, if your number of multiple bonds are same, you will see number of carbon atoms. Okay, so after this rule fails, you will see which chain contains maximum number of carbon atoms. After that, you will see if the number of carbon atoms are also same, then you will see number of alkenes. Okay, and if the number of alkenes are also same, then you will see number of substituents. So this is the only rule that you have to follow. Okay, and we'll see this how to do that. Okay, and if this is the thing, how to do numbering? If you first select the primary carbon chain, then you will number according to the lowest locant rule. Lowest locant rule means you can number the chain from both the sides, either from this side, from this side. The first substituent that you will encounter, listen to me carefully, the first substituent that you will encounter in your chain from either sides should have the lowest possible number. If from both the sides first substituent has the same number, then check the second substituent. From the side which from where the second substituent has the lowest number, then you will do the numbering from that side. Okay, so this is the lowest locant rule. Okay, and there are some functional groups whose carbon atoms are numbered 1, like your acid. This is acid, right? This is acid group, its carbon is numbered 1. This is ester group, its carbon is numbered 1. This is your acyl halide. Okay, again its carbon is numbered 1. This is your amide. Okay, and this is your aldehyde, and this is your cyanide. So all of these functional groups, the carbon in these functional groups will take number 1. Okay, is it fine? Is it fine? You will get the notes. Okay, so that is what you have to do. So do this first question. The first question is in front of you. I am giving you some time. I am giving you 30 minutes of time. You have to find the correct IUPAC nomenclature of the following compounds. Do this. Then I will explain. See, first you have to identify the primary carbon chain. So primary carbon chain will contain the primary functional group here. So primary functional group is your aldehyde here. See, aldehyde group, right? So this chain that will contain aldehyde will be primary chain. So 1 aldehyde carbon, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. If you take any other chain, it will not be that much larger. So this is your primary carbon chain. On 3 you have oxo. This is ketone group. So in substituent it is named as oxo. And this is nitro. This is 7 also. Okay, 7, sorry. Okay, so this is nitro. So now tell me what is the answer. Now tell me what is the answer. You have identified the substituents. Then name the substituents first. What is the answer? On 4 there is a methyl there. On 6 there is a nitro there. On 3rd there is an oxo. Is there something? 6 nitro, 3rd oxo, 4th methyl, then hept, 7 membered hept, and 4 ene and ul. Right? And obviously you will write alphabetically. So alphabetically M comes first, then N comes, then O. Right? So that is how you will write. So what is the right answer? Tell me. अरे D कहाँ से? D नहीं है भाई. So the right answer will be C. Okay. Okay. Is this fine? Is there any doubt in this? Tell me. What are you saying in the comments? Right? Okay. Chal. So basically this is now benzenoid compounds. So basically this is all you need to know, right? You need to know the functional groups, you need to know the primary functional group, and then you need to know the PCC. Then after that you need to know the nomenclature of the benzenoid group. Okay, benzene contains some functional group or benzene contains some substituents. That nomenclature is asked a lot. Okay, so you can see these things. Okay, so see here 2 rules should be followed for primary functional group or primary carbon chain. So if benzene contains pure alkane, okay, pure alkane, then your primary carbon chain will be benzene. Okay, and if benzene contains anything else other than pure alkane, anything else, not pure alkane, anything else, then your benzene is a substituent and your anything else that is attached to it is your primary carbon chain. So benzene will be substituent. So as substituent, benzene is known as phenyl, right? So basically there are some common names that you should know. So this is benzene plus OH, phenol, benzene plus NH2, aniline, benzoic acid, benzene plus COH, benzene plus acyl chloride group, COCl group, right? So benzoyl chloride, benzene plus COCH3, acetophenone, benzene plus CN, benzonitrile, benzene plus CH3, toluene, benzene plus OCH3, anisole. So these are the common names. If these names are asked, you have to write these names. Okay, then see the primary functional group, whatever is the primary functional group. If it is acid, primary functional group, you will say benzoic acid. If it is aldehyde, you will say benzaldehyde. If it is obviously ketone, acetophenone, phenol, aniline, anisole, toluene, right? So you have to identify in this order. So if COH is present and any other group is also present, so COH will have the maximum priority. So the benzene will be called as benzoic acid, not benzaldehyde, because COH has a higher priority. Okay, so see, right? So here, if your X is on 2nd carbon, so primary functional group is attached on the 1st carbon, this is 1st carbon. Okay, so your X is attached on 2nd carbon, this is ortho. Okay, if primary functional group is on 1st carbon, your X is on 3rd carbon, so this is meta. If your primary functional group is at 1st, your X is at 4th, so this is para. Okay, so for example, this compound is known as 1,2-dibromobenzene. 1,2-dibromobenzene. Okay, or you can say ortho-dibromobenzene. So this is how you can name benzenoid compounds as well. Now do this, do this. Do this. So basically again, you have to find the correct structure of gamma. Gamma, okay. So the primary functional group that is attached, okay. So the carbon attached to the primary functional group is your alpha. Then carbon attached to that alpha is your beta. Carbon attached to that beta is your gamma. Okay, so that is how you need to know. So add gamma, you have to add methyl, okay, and cyclohexane carbaldehyde. So cyclohexane carbaldehyde is obviously this cyclohexane Carbaldehyde. Is this or it is this? Tell me. What will it be? Is it this or this? Tell me. Which will it be? Above 1 or below 1? Carbaldehyde. What is it? What is it? Tell me, tell me. Fast, fast, fast. Tell me the answer. So basically, this is the answer. This is not carbaldehyde. Basically, COH group added to cyclohexane is carbaldehyde. So basically, cyclohexane carbaldehyde is this on the gamma position. See, this is alpha, this is beta, this is gamma. On the gamma, there is a methyl. See, gamma methyl cyclohexane carbaldehyde. A is your answer. Okay. अरे B कौन बोल रहा है गरीबों? हट. B कहाँ से आया? IUPAC name of the following compound. Do this. So basically there is NO2, there is NH2, there is CHO, there is OH. You have to identify the primary functional group first of all. So primary functional group will be CHO. So according to CHO, so this will be benzaldehyde according to CHO. See these rules again. Benzaldehyde, right? So according to CHO, this should be benzaldehyde. If this is benzaldehyde, then this will be first. Let me decrease the. Okay. Then this will be first. This will be second. This will be third, fourth. Wait. First, second, third, fourth, fifth, sixth. Right? So this is the numbering. If you do the opposite numbering, so this will be first only, this will be second, this will be third. So from moving this side, the first substituent is at second position. From moving that side, the first substituent is at third position. So obviously I told you, lowest locant rule. The first substituent that you will encounter should have the lowest possible number. So first substituent that we are encountering here is having the lowest possible number. So 2 nitro, 6 amino, and this is CH2OH group, right? So basically hydroxymethyl group, hydroxymethyl CH2OH, hydroxymethyl, right? So see the answer. Benzaldehyde will be the primary compound, then 2 nitro and 6 amino. So 6 amino will be written, not 6, 5 amino will be written first of all, then your hydroxymethyl will be written, then nitrobenzaldehyde will be written. See, why? Alphabetically we are going. A comes first, then H comes, then N comes. So 5 amino, 4 hydroxymethyl, 2 nitrobenzaldehyde. Is it fine? Tell me. अरे इसमें भी सी बढ़िया. चलो. You will get these notes in the our SciAstra app, okay, in the free material or in the MAHA revision material. I am not sure. You can ask the support team once. Okay. Do the IUPAC nomenclature of this. So this is again a compound. So find the primary functional group first. Again, I can see primary functional group is this. So this is acid group. Okay. And this is 5-membered cyclic ring. So cyclopentane ring. Okay. So cyclopentane carboxylic acid will be the nomenclature, right? And from 1, 2, 3, 4, 5. So if you are going from here, the first substituent Br will be encountered from third number. Here the first substituent is at second number. So what will you do? This is 2 methyl, 4 bromo. So bromo will come first because it is alphabetically superior. So 4 bromo, 2 methyl, cyclopentane carboxylic acid. D. Right? Is this fine? Yeah, D. जिसने भी D बोला, good. Right? So last year only they have asked the nomenclature in next exam. Okay. So now match the following. So basically here compounds are given: spido compound, aromatic compound, non-planar heterocyclic compound, bicyclo compound, and here compounds are given. Okay. You have to match the following and give the correct answer. बताओ. बताओ. See, I will tell you one thing. So, what is a spiral compound? तभी मैं कहूँ, एक सेकेंड, ठीक है. No worries, ठीक है. So, what is a spiral compound? So, spiral compound is two rings shared by one single atom. See, so this is one single atom in the center with which two rings are shared. Okay, so this is spiral compound. What is bicyclo compound? So two rings will be shared by two atoms. So these two atoms are sharing these two rings. You can see these two atoms are sharing these two rings, and that atom, that one single atom is sharing two rings. Here two atoms are sharing two rings. So basically this is bicyclo, this is spiro. So basically B is your bicyclo, C is your spiro, right? And obviously non-planar heterocyclic compound. So non-planar will be this. Why? And this is aromatic. Why this is non-planar? Because planar molecule, for planar molecule check, generally it's not a necessity, but generally for planar or planarity, all atoms sp2 hybridized. If all atoms are sp2 hybridized, so you can in general say that it is planar. Okay, sp2 hybridized. Okay, so here this carbon, these are not sp2 hybridized, these are sp3 hybridized, and this is obviously aromatic because this follows Huckel rule. We'll see aromaticity as well. So basically this is the correct answer. Whatever answer matches, that's the correct answer. Okay, chale. Okay, so structure of compound whose IUPAC name is 3-ethyl 2-hydroxy 4-methyl hex 3 5-inoic acid. Do this. I'm giving you 30 seconds, 30 complete seconds to do this. ठीक है. So see, if such type of questions come, always start from the backwards. Okay, so see, you can see what is there, hex 3 5-ine oic acid. So hex 1 2 3 4 5 1 2 3 4 5 6. So first from hexane, then from hexane at 3 you have to find ene. Okay, at 5 you have to find ine. Okay, and this is oic acid. So basically this will be like this, right? So parent structure you have formed. So parent structure, after forming the parent structure, find the substituents. So 3-ethyl 2-hydroxyl 4-methyl. So 3-ethyl 1 2 2-hydroxyl 2 OH 4-methyl. So is there any structure like that? So basically on 2 OH, on 3 wait. Okay, so basically you can say 1 2 3 4 5 6. So 1 2 3 9, ठीक है, 1 2 3 4 5 6. So see here 1 2 3 4 5 6. So 5-ine 3-ene 3-ethyl 4-methyl and 2-hydroxy. So A will be your answer, right? अरे कर लिया, गरीब तो नहीं हूँ मतलब. ठीक है. So let's move. So IUPAC is this much only. It rarely asks in IIT and NIS. So I would suggest you to I am giving you these rules. Okay, I am giving you these rules. So go back and read these rules that I have given. Okay, then do some more question practice. Okay, after that your IUPAC will be very good. Okay, the point is they don't ask that much, but last year they asked, so I couldn't leave it. Okay, okay, chalo. Let's move ahead. Okay, now come to structural isomerism. So what is a structural isomerism? What is isomerism? Can anybody tell me? Can anybody tell me what is structural isomerism? Let me see. What are you guys saying? What is structural isomerism? Nobody is telling. Okay, I will tell. So basically isomerism is when your molecular formula is same. Isomerism or isomers means same molecular formula, spatial arrangement. Array, that is stereoisomerism. I asked structural, right? So same molecular formula, different structures, right? Now this different structure can be regarding different things, like this difference in the structure can be regarding change in atomic connectivities, like atoms which are connected, like for example carbon was connected to hydrogen, now it is not connected to hydrogen, right? So atomic connectivities change sometimes. So due to this, the atomic or the molecular structure changes, or the molecular structure can also change due to change in 3D arrangement of the groups. So that change in 3D arrangement is stereoisomerism, but change in atomic connectivities is structural isomerism. Why? Because atomic connectivities change, their structure, their carbon skeleton or their parent skeleton, it totally changes. Okay, so there are two things: atomic connectivity changes or 3D arrangement changes. Okay, if your atomic connectivity changes, this is structural isomerism. If your 3D arrangement changes, this is stereo isomerism. Okay, so obviously now we are seeing structural isomerism. Basically the atomic connectivities will change. So the first one is chain isomer. So chain isomer is, see here the points are written, different number of carbon atoms in principal carbon chain PCC or substituents. Okay, so basically different types of PCC or substituents. So either the PCC, primary carbon chain, will change or your substituent will change. For example, see this. This is your N-butane, 1, 2, 3, 4. N-butane, normal butane. So one of the CH3 group will attach to this. So this is isopropane. So in this case, the molecular formula is same but structure is different. Why? Because atomic connectivity is changed. See, this carbon was first attached to only 2 carbons. Now this carbon is attached to 3 carbons. So atomic connectivity is changing. So this is structural isomerism. Structure is changing due to change in atomic connectivities, and this is chain isomerism example, because primary carbon chain was first 4 carbon chain, now it is 3 carbon chain. So primary carbon chain is also changing, substituent is also changing. So this is chain isomer. Now positional isomer. So positional isomer, obviously from the name you can imagine change in position of functional group or any substituent in a particular compound. So point is position of functional group or a substituent or your alkyne, that will change, but primary carbon chain will not change. So primary carbon chain will remain same. Okay, see here, this is 1, 2, 3, 4. So this is but1ene, right? But1ene, but this is but2ene, 1, 2, 3, 4. So position of double bond alkene changes, but primary carbon chain is of 4 carbon length only. Okay, with a double bond, right? So primary carbon chain stays the same, but your double bond position changes. So that is positional isomer. Now metamers. Okay, so metamers is generally shown in the compounds where functional group is present, which is divalent. Divalent means one functional group is attached to more than one carbon, basically 2 carbons. Here divalent functional group is involved. So functional group attached to two carbon atoms. Okay, like ether. See, ether. Oxygen will be attached to two carbons, right? So this is divalent. The point is, because it is attached to two carbon chains, so these two carbon chains that are attached to the divalent functional group, they will change. So that is metamerism. See, here the carbon chains attached to the both sides are two membered, 1 2 1 2, but here this is only one carbon and here three membered chain is attached, right? So on the both sides the chains attached to the divalent group changes. So this is metamerism. Okay, okay. Then next three are ring chain isomers. So ring chain isomers, basically these are possibly saying that one double bond equivalence can be realized as one ring or one double bond. So basically if any molecule has one double bond equivalence, so you must have studied what one double bond equivalence is. So it can be one ring or one double bond, one alkene. So in the compounds, in both these compounds where this is realized as one ring and where this is realized as one alkene, both will be structural isomers because the molecular formula will be same, but double bond equivalence is just realized in different ways. So the structure will be different. So two double bond equivalence can be like two double bonds, right? Or two rings or one triple bond. One triple bond can also be two double bond equivalence, or one ring, one double bond, whatever it can be. So these are the things which can be said as ring chain isomerism. For example, if you want to say that, let's suppose N-butane or cyclobutane. So this is one double bond equivalence is realized as double bond. Here it is realized as cyclic molecule, one ring. So both of these will have same molecular formula, but they will have different structures. So these are ring chain. Here there is a ring, here there is a normal chain, ring chain isomer. Okay. Then your functional isomer. Functional isomer is basically change of functional group. So change of functional group, but even after changing the functional group, your molecular formula stays the same. So what types of functional groups are these? So alcohols and ethers will have the same molecular formula. Aldehyde and ketone will have the same molecular formula. Carboxylic acid and ester, then 1 degree, 2 degree, 3 degree amines. They will have different functional groups but same molecular formula. And obviously then there is a tautomers. Tautomers are basically what? Interchange of hydrogen and pi bond. Interchange of hydrogen and pi bond through the molecule. So here there is an example, see, CH3 C double bond O CH2H. So this is 1-3 shift. One is oxygen, second is carbon, third is this carbon. So this hydrogen attached on the third carbon will go to the first position. So from third position it is shifting to first position. So this is 1-3 shift. So basically oxygen takes this hydrogen. Okay. So this bond goes here, this bond opens up. So basically this is enol form, this is keto form. So generally your keto form is more stable. Enol form is not that much stable, but in some cases keto form is also less stable than enol form. We'll see that. Okay, is this understood? Arey Parth bhaiya is rich, you know. I am a garib insan. Okay, do this question. अरे भाई माइक अब I think it's fine यार. थोड़ा maybe increase the volume of your screens, phones or laptops maybe, if you are feeling like that. Do this question. So basically here you will have to match with the following. So these are isomeric pairs and you have to find which of the structural isomers are these. So basically again, so if they won't give you IUPAC nomenclature, they will give you IUPAC nomenclature in this. You can't make the compounds if you don't know the nomenclature. See, so indirect way of asking IUPAC nomenclature. So that is why IUPAC is very important, so don't miss that. Okay, so propanamine and methyl ethanamine. So propanamine is this 1, 2, 3 amine, and methyl ethanamine 1, 2, NH. So N-methyl ethanamine. So basically this is 1 degree amine. This is 2 degree amine. Okay, so because this is a change in functional group, so this is functional isomer. Okay, hexane 2 on hexane. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So hexane 2 on. So this is hexane 2 on. Then hexane 3 on. 1, 2, 3, 4, 5, 6. So basically this is on second position, this is on third position, the molecular formula is same, functional group is same, positions are changed. So this is positional isomer. Okay, ethane amide. Ethane CH3 CO NH2. Ethane amide and then hydroxyethane amine. Hydroxyethane amine. So basically this is saying that ethane imine, not amine. So this is OH double bond NH. So C double bond N is your imine group. Imine. And this is hydroxy. So hydroxyethane imine. So basically this is shift of hydrogen with the shift of pi bond. So this is tautomer. Right? Tautomers. Then orthonitrophenol. Phenol per orthonitro. So this is orthonitrophenol and paranitrophenol. So para nitrophenol. So now this is also change in position. So if something like that happens, if two things can collide, okay, so point is two isomeric pairs can be more than two isomers. Like basically if this, for example this amine is your basically functional isomer, right, and it can be metamer as well. So if this is positional isomer, so this can be positional isomer only. So is there any other thing positional? What we have done, hexane 2 on and hexane 3 on. So hexane 2 on and hexane 3 on. See, so basically this is divalent group. So obviously position is changed, position of functional group is changed, but this can also be metamer, na? See, the rings on both the sides of the divalent groups are different. So this can also be metamer. So you can say that this is also metamer. This will also be positional. I am not saying this is not positional, but the question is made such that you have to answer that. So this is a good question. Okay. So this is your metamers and then this is your positional isomer. Fine. Right? So have you understood what you have to do? So two pairs can be more than one type of isomers. It's not like it will be only one isomer. Okay. 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 Done? Chalo. Let's move to then stereoisomers. So structural isomer is not also asked that much. You just need to know what these are. So if basic question is asked, you don't leave that question in the exam. That's why I did that. So now let's move to stereoisomers. So stereoisomers is again change in molecular formula. Not change in molecular formula, change in structure, but the molecular formula is same. But why that structure has changed? So change in structure due to change in 3D arrangement. So that is stereoisomerism. Okay, so for that you need to know some things, that chiral carbon is an asymmetric carbon, whatever this is. These two are same things. So in the question if chiral carbon comes, asymmetric carbon comes, it's one and the same thing. So the carbon with 4 different bonds. So if this is carbon A, B, D, E. So this carbon has 4 different bonds. So this carbon will be your chiral carbon, asymmetric carbon. So 4 different groups attached to it. Okay. Then acyclic compounds with 1 chiral carbon. Acyclic compound with 1 chiral carbon. Any acyclic compound will always be optically active. Always. Okay. So for example, anything. So you can say this is CH3, H, OH, F. So 4 different groups are attached. Acyclic compound. So this acyclic compounds contains this chiral carbon. So this will be optically active or not? Optically active means it will rotate light or plane polarized light, PPL. Okay, so why this will rotate plane polarized light? Because this is asymmetric. It does not contain any symmetry element. Okay, so obviously this will be polarized, or this will be rotating the plane polarized light, and you can find R and S configuration according to CIP rule, right? You can give the configurations. If this will be clockwise, so that will be R. If it will be anti-clockwise, that will be S, and then different configurations have different rules. We will see the rules in the questions itself. Okay, then acyclic compounds with 2 or more chiral carbon. Now one chiral carbon will be optically active, but with 2 or more chiral carbon and cyclic compounds and cis and trans, like geometrical isomers, cis and trans isomers, don't check via your RNS configuration or via asymmetricity or something. Check the optical activity via COS and POS. Okay, because even after having 2 asymmetric carbons, it can still be inactive because it can contain POS, and such compounds can be called as what? Meso compounds. So meso compounds are the compounds which contain asymmetric carbons, more than one asymmetric carbons, but even after that it will contain POS because those asymmetric carbons are same type of carbons. Okay, so those are mirror images of each other. Okay, for example, if you want to see CH3, OH, F, OH, F. So basically both of these carbons are asymmetric. This is also asymmetric, this is also asymmetric, but you can pass a plane which will cut this molecule. So obviously this will be optically inactive, right? When is bath break? When your girlfriend tells you, okay, चलो, अबे नहा के क्या कर लेगा भाई, पढ़ ले, ठीक. So basically now total stereoisomers, they can ask total stereoisomers like one chiral center with 2 chiral centers, so you have to find total stereoisomers. Okay, so such type of questions sometimes come. So if your compound contains one chiral center like this, CH, CH2, CH3, CH3, OH, then how many? I will not give you any formula. When I give you formula to students, they will be stuck. Okay, because then you have to remember the formulas. Okay, so apply your mind. I will also apply my mind. Okay, so obviously if there is one chiral carbon, it can be R, it can be S. So total 2 different stereoisomers should be present, right? Now here this is also pi bond is also stereo, basically chiral if it can show geometrical isomer. So if this can show geometrical cis trans isomer, okay, cis trans. So basically this will also be counted for number of stereoisomers, because cis and trans are also stereoisomers. No, you have to find the total number of stereoisomers. So obviously this will be cis and trans. So again 2. Done with 2 chiral centers, like 2 carbons. So obviously, so and these 2 are symmetric. See, same type of carbon atoms, CH, OH, CH3, same type. And I just told you, like in same type of carbons, you have to eliminate the meso compound, because meso compound will be optically inactive, but stereoisomer, you can say that. किसका doubt है? अरे COS is center of symmetry, POS is plane of symmetry. Plane of symmetry is a plane which will cut your molecule in half, like this plane. So this plane is cutting the molecule in upper half and lower half. So it cuts the molecule in 2 symmetric halves. So that is plane of symmetry. Okay, so that you have to see. Okay, for seeing if the molecule is optically active, it will not contain any plane of symmetry. Okay, if it is not active, it will contain plane of symmetry. We'll see the questions, don't worry. Okay, so here these are symmetric carbons. Okay, so this can be R, this can be R, this can be S, this can be S, this can be R, this can be S, but this S and R. So always remember, if there are two asymmetric carbons and both are same type of carbons, like these carbons, the molecule is symmetric. So this RNS, both the carbons will have opposite configuration, then this will be meso. So if this will be meso, its mirror image will superimpose. So this will not be formed. So only three stereoisomers will be formed. Okay, Here it is asymmetric. Now how it is asymmetric? Because here CH, CH3, here CH, C2H5. So the carbons are not same type. Okay, so these won't be mirror image. These won't be mirror image. If this is R, this is H, I can pass a plane which will be mirror image, which will cut the molecule into halves. But this won't cut the molecule into halves. It can't, because there is C2H5 here. Okay, if you are able to understand what I am trying to say. Okay, so basically here you don't have to take care of meso compound. So R, R, S, S, R, S, S, R. So here 4 different stereoisomers will be present. Okay, fine, fine. Then, so again now two chiral centers are present. So basically here cis and trans isomerism can happen. Here RNS isomerism can happen. So first cis R, cis S, trans R, trans S. So 4 different stereoisomers are present, right? So here two centers are present where cis and trans can be formed. So cis, trans, cis, trans. Okay, and will there be a trans cis? Tell me, will there be a trans cis in this? Because this is symmetric molecule. See, CH double bond CH, CH3, CH double bond CH, CH3. Okay, ठीक है. So if let's form this cis trans. So this cis trans will be C double bond C, H, CH3, then CH. So basically this is like cis. This is like cis. So cis. Okay. Then let's see this. C, H, C, H, CH3. So this is like trans. Okay. So if you will make this trans and this cis, it will be same only. You can make this trans, C double bond C, H, CH3, C, H double bond C, H and CH3. So don't you think this molecule is this only? See, this molecule is this only and this molecule is this only. So it is just rotated, nothing else. So cis and trans won't be present here as well. Okay, so only cis trans is present. Its trans cis is the same thing. Okay, so 3 isomers will be present, but here this is asymmetric. See, CH3 and C2H5. So here 4 will be present. Cis, trans, cis, trans. Okay, so here 4 different stereoisomers will be present. Okay, then last, this is the limit that it can ask. It won't ask beyond this. Okay, so basically here there are 3 chiral centers. So one is carbon, one is double bond, one is this carbon, and this is symmetric again. See, same carbon, beech mein double bond. Okay, so if this is cis, this is R, this is again cis, this is RS, this is RS, or SS, let's suppose, SS. Then this is cis, RS. But then again SR will be meso. SR, see, if this is R, this is S, and this is cis. So there will be a meso. A plane of symmetry will be there. Okay, you can do this homework. Okay, you can do this homework. So basically 3 of cis form and trans. Let's see. Trans. So S or R, then trans, S, then trans, R, S. So then here also there will be a plane of symmetry. So 3 of cis, 3 of R, or 3 of trans, so basically 6 stereoisomers will be there, but there is asymmetricity. These 2 carbon centers are not same. So obviously then R and S and S and R S and R. So basically 2 more isomers will be added. So here there will be 8. So add all of these. Instead of except these, add 2 more. What will be there? S trans, R trans, S cis, R cis, right? So here 8 will be there. So you can do this. So this is the only limit. If it will ask like this. Okay, tell me. Tell me. Fine. Fine. So let's move to GOC. Or let's do some questions. Let's do some questions for stereochemistry. Wait. Okay. Do this. Which of the following represents 2R 3S 2,3-dibromopentane? Do this question. So basically at 2 you have to find R configuration, as 3 you have to find S configuration, and it will be 2,3-dibromopentane. So 2,3-dibromopentane, basically it will be pentane. So 5 membered, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? 5. Then at 2 there will be bromo, and at 3 there will also be bromo, and both will be R and S. Sorry. So if you are making this, let's suppose you are making this Br, you are making this H. So you want to give first priority to this. At Kahan-Ingold Prelog rule, CIP rule, the molecule with more atomic mass is given higher priority. So bromine will be given higher priority. Then after that, this whole group will be given next highest priority, second. Then this group, CH3 group, third, and fourth. So if fourth is at dash position, okay, so this configuration will be reversed. Okay, so whatever configuration will be there, it will be reversed. Or you can do whatever you can do at this position as well as this position. So basically at dash position it is not reversed, but at dash position it will be reserved configuration, but at wedge position, which position where this Br is there, if this fourth priority comes at wedge position, the configuration will be reversed. So you can do whichever way, but the general way is this. So you have to reverse the configuration if this happens. So basically 1, 2, 3. So this is what? Clockwise. So this will be R. Okay. So if this is R and you take this again as Br, H. So 1 and then okay 2, 3 and 4. So 1, 2, 3. This is also clockwise. So basically this will also be R, but then you have to revert this. But if you will revert this, then H will come at the wedge position. Then if you will find this 1, 2, 3, so this will again be clockwise. So this will be R, but H is at wedge position, so this will be reversed. So this will be S. Okay, so this will be your right answer, I think. A. Is this fine? Yeah, A. Good. चलो. अच्छा मैंने GOC के बाद कर दिया क्या? वेट. ओके, ठीक है. चलो. तो देखो, do this. So which among the following is E isomer? Okay, so always remember E is like, always remember like this: it trans. speak 2-3 times, it trans. So E is equivalent to trans, it trans. So Z will be cis. So they are asking about trans type of alkene. Okay, so it trans. So do this. Find the trans type of alkene among this. Okay. Find the trans type of alkene. See, so trans type, E type of alkene will be, if the first priority is there, the first priority should be here. Second priority is here, second priority should be here. That is type of E type of alkene or trans type of alkene. So you can check the priority. Here the priority will be, first will be this, because oxygen is more. Then here the priority, carbon is attached to Br, carbon is attached to F. So first priority is this. So obviously this is your E. So then here this is alkene. So this one, so they have mentioned the arrow. They have not taken that one or this one. They have mentioned the arrow. So if you are mentioning this as first, okay, or Br, so this will be first only, okay, and here which will be first? This will be first, okay. So this is not E, this is Z, like Z type of alkene. So this is Z, this is E. Here double bond, so Cl first, okay, and here CH3, okay. So this carbon is attached to one CH3, one CH3. So this carbon is attached to 3 carbons, but this carbon is attached to 2 hydrogens and 1 carbon, okay. So obviously first priority will be this, so Z, not, right. So here, see, so this is deuterium. Deuterium will be, deuterium has higher mass than hydrogen. So I told you the compound or the group with higher mass is given higher priority. So this is first, and here this is obviously first, because here the carbon is attached to 3 different carbons. So double, by 2 carbons via double bond and by 1 carbon via single bond, okay. And but here, wait, here the carbon is also attached to 2 different carbons, okay. So 3, so 1 hydrogen, okay. So next carbon we'll see. So next carbon is attached to, so next this carbon is also attached to 3 different carbons. So obviously this will be first, don't worry. So if the first carbon is same, check the second carbon. If second carbon is the same, check the third carbon. That's like that you have to do. So 1 and 4th, C will be the answer, right? 1 and 4th, ha Olivia, right. So this is your answer. Let's do some more questions. Again, do this. EZ configuration of alkenes from left to right. From left to right in the given compound. So from left, so my left is this, left to right, you have to give EZ configuration. So this is an alkene, this is an alkene, this is an alkene. So find the configuration. Again. So this is first, this is first, right? So this will be E trans. So here COOH will be first, and here 1, 2, 1, 2. So on second a group is attached. So 1, 2. So this is first. So this is also E. So EE, C, right? Tell me. Arey, you are not giving answers, guys. Give answers. I am doing questions for you only, na? Give answers. Is this C or A or what? Someone is saying A. E and Z. This is Z. COH is first priority. Here this is first priority, na? Arey. Here first carbon and first carbon are the same. Second carbon has 2 hydrogen, but here second carbon has 1 hydrogen, and rest others are carbon. So here this second carbon will be given more priority, na? So this will be first. So here that is first. So this is E, and here C and Cn. So C and Cn are same groups. So obviously this will be given first priority and this will be second priority. This is first, this is second. So this is first because C has three bonds with nitrogen, right? right? So E and E, na? E and E. Chalo. Optical activity. Okay. Chalo. Those who are asking about plane of symmetry, now find the optical activity. Like the compound which will have plane of symmetry, the compound is optically active if it lacks POS. Okay, so compound should not contain any POS. Find the answer. Which of the compound will possess a plane of symmetry? Will possess a plane that will cut the compound in half. Find out. Find out. Let me drink some water. So basically almost 1 hour is done. So we'll just take 2-3 more questions and we'll end the CO chemistry, and then we'll start with GOC. So here, see, so this is a compound. So in this compound, what is happening? See, so hydrogen, fluorine and fluorine. Okay, so basically there can be a plane that will pass from here. There can be a plane which will pass from here. If this is planar, if this is all planar, then a plane can pass from here. So this possesses a plane of symmetry, right? So this plane wait, this plane cuts the molecule in half. Okay, so this is there. Then you can find the plane of symmetry in this as well, right? So same plane can be moved here, right? So you can cut in half. Then you can find in here. If you are doing here, then there is a bromine there and there is a hydrogen here. So this plane is not possible. So any other kind of plane is possible. Diagonal plane? No. Diagonal plane? No. But this also will not have any plane because this is upwards, this is downwards. So you can form a chair configuration. So when cyclohexane is given, find through chair configuration as well. Okay, so this is above the plane, so this is below the plane. So one is above the plane on that carbon, one is below the plane on this carbon. So here there is no Br in front of this carbon, so obviously this also does not contain a plane of symmetry. So 1 and 2 I think is the answer. D is the answer, or what? 3 and 4 which does not possess. Acha, does not possess. ठीक है. Third and fourth does not possess. Now this is a silly mistake that we do. Does not possess. Okay, keep a track of this as well. Does not. Okay, 3 and 4. B. चलो. अरे. Okay. So they are asking molecule that exists as meso structure. So obviously meso contains a plane of symmetry. So they are asking about plane of symmetry only. Simple. Find the answer. So meso compound contains plane of symmetry. So they are asking which compound contains a plane of symmetry. Find the answer. So I can see this compound. So you can pass a plane from here which will cut this compound, but this compound is not there because here it is above the plane. This CH3 group, this CH3 group is below the plane, so they won't be mirroring each other. So this is not containing a plane of symmetry. This contains a plane of symmetry. What about this? So can you pass a plane from here? Diagonal plane, like this. So you are cutting the molecule like this. So obviously these two CH3 will mirror each other, right? You can imagine. So this also contains a plane of symmetry. So P and Q, right? Right? B, right. Chalo. Okay. Okay, so you should also know the relationship, stereoisomer, diastereomer, whatever it is. So I will give you one question regarding that as well. See, so basically you have to find the relationship between these two molecules. So this is a molecule, this is a molecule, find the relationship. So stereoisomer or enantiomer, sorry, enantiomers are mirror images, non-superimposable mirror images, right? Non-superimposable mirror images. So non-superimposable mirror images. So to find this non-superimposable mirror image, the point is the asymmetric carbon that is present, it will be R. So in that mirror image, non-superimposable mirror image, it will be S. So R will go to S, S will go to R, and obviously molecule should lack any POS. So if it is having a POS, obviously it is a meso compound, right? So it will not contain any enantiomer, so that will be homomer, right? So you can see, and here, okay, so there are some rules. There are some rules as well. Okay, so if see these rules, if two groups exchange positions, so this means exchange of R and S. So if two groups are exchanging position, R at that carbon will be changed to S. But if three groups are changing position, if three groups change position, so R will remain R, S will remain S. Okay, you can check that. You can check that. So here H and Cl, so H and Cl have not changed the position. Here H and Cl, but H and Cl have changed the position. So H and Cl, this Cl has now been shifted to this position, and this H has now been shifted to this position. Okay, so above configuration will be same, whatever it is, whatever you can assume. If this is R, this is R. If this is R, this will be S. You can check that as well. You can do the priority, you can find the priority, you can find R and S, it will be opposite. So if both the groups, both the asymmetric groups, if this was R, this would have been S, and this would have been S, then this would have been your basically enantiomer, but one is R and one is S. So obviously proper criteria is not matched, so this will be diastereomer, right? Right? Is that fine? Geometrical isomers? Geometrical isomers? Geometrical isomers is about double bond or a ring. So geometrical isomer is like this, about ring, right? These can be geometrical isomers, HF and FH, or this about double bond. That can be geometrical isomer. There is no ring here. This is diastereomer. Okay? Okay? Chalo. So one last concept of this, and we'll end with the stereochemistry, and that concept has been asked in the PYQ. So be cautious here. Let me just see. Alright. It has not been given optical activity. I will just tell you the concept. I don't think there is a question in this. The point is, we all know that there are R and S configurations. So R configuration will rotate the plane polarized light by some angle. Let's suppose let's suppose it rotates by minus 40 degree. So S will rotate by equal magnitude, but the sign will be opposite. Okay. So rotation of plane polarized light by R is equals to minus times of S. So magnitude of by R is equals to minus times the magnitude of S. So these two enantiomers, these are non-superimposable mirror images. So these non-superimposable mirror images will rotate the plane polarized light. They will rotate by same magnitude, but in opposite directions. So what happens is, see, let's suppose there is a solution, and in this solution there is R enantiomer as well and S enantiomer as well. So R plus S. Okay, so R enantiomer as well and S enantiomer as well. So basically, if R and S are 50-50%, so 50% R, 50% S. So 50% of the solution will rotate the plane polarized light in some direction and 50% will rotate in another opposite direction, and they both will rotate equally in opposite direction. So solution will be optically inactive. Okay. Okay, this is known as 100% racemization. But if this is not 50-50, let's suppose R is 40% and S is 60%. 40% R, 60% S. So obviously the 40% solution will rotate in the direction of R by that magnitude, and 60% of the solution will rotate in the direction of S by that magnitude. Okay, so overall rotation will be in S direction. Whichever direction S is rotating, it will be in that direction. And how much will be racemization? Only 40% will be racemization. Racemization means cancelling out of the optical activity. So 40% R will cancel out the 40% S optical activity. So 40% solution of R will rotate in some direction. So 40% solution of S will also rotate by equal amount in opposite direction. So their optical activities will cancel out. So the optical activity, so this will be 40% racemization. It's simple, na? So if 40% is racemizing, 40% R is racemizing with 40% S, so total 20% of S is giving optical activity. 20% S is giving optical activity. So solution is optically active because of this 20% extra S, right? Rest 40% was cancelled out by 40% R. So this is known as enantiomeric excess. And how to find this enantiomeric excess? The formula is EE theta S, or theta of the solution, divided by theta of pure enantiomer. So this theta is of pure enantiomer, which is in excess. So if S is in excess, then this will be theta of S. So excess enantiomer. So it will be given, right? And this above theta is theta of the whole solution, and total multiplied by 100. So that will be percentage enantiomeric excess. So physically you can understand this as, if this whole solution would have been this pure enantiomer S, then it would have some particular optical rotation. But right now this whole solution is not pure S. There is some R as well. So some R will cancel out that equal amount of S. So this amount of S, whichever is present, so this optical activity of the solution is because of that extra S that is present. So you divide this by this, you will get what amount of extra S is present or what amount of extra R is present. Okay, so that is enantiomeric excess. So they have asked this in the previous year NEST questions as well. They will ask the enantiomeric excess, they will ask this, they will ask this, whatever they can ask, they will give the values. So this is physical chemistry plus organic chemistry. So please take care of that. Okay. Okay. Fine. Shall we move on? Shall we move on to GOC? Shall we move on to GOC? बताओ, समझ में आया ये? सब कुछ समझ में आया? स्टीरियो, स्ट्रक्चरल, IUPAC. I have given questions as well. Okay. So I think I have done the revision from my side. Now your revision is left. So now let's move on to GOC because how much time is done? जय हिंद, जय हिंद भाई, जय हिंद. ब्रेक अभी नहीं मिलेगा, गरीबी मत दिखाओ. ब्रेक पूरे साल ब्रेक लिया है तुमने. ब्रेक रुक जाओ, GOC के बाद मिलेगा ब्रेक. अरे what do you guys have to do? You guys have to listen, eat snacks and listen. I am speaking, I am barking like a dog. So why are you taking any problem? After GOC I will give break, don't worry. Okay. Question on formula. यार question on formula I don't have यार, मैं क्या बोलूँ. Question I don't have on the formula. You can find this question yaar in the books as well. I don't have right now. I don't have the question regarding this formula, but you can see the NEST PYQ. You can see the NEST PYQ. There is a question. Okay. चलो. चलें. चलो. So GOC General Organic Chemistry. पहले तो इसको delete करते हैं यार. Okay. So we'll start with the question directly. So correct stability order of the resonance structures of the given compounds. So this is the question. So basically this kind of question comes where different resonance structures are given and you have to range or arrange them in the correct increasing order of stability or decreasing order of stability or something like that. So here, see, so what are resonance structures? So basically there are various molecules which cannot be represented by one single Lewis structure. So there are different Lewis structures responsible for that one molecule. So what is happening, for example, for example, let's say benzene. So this benzene cannot be represented by just this Lewis structure. Why? Because these bonds are in resonance. These bonds are in resonance. So because of this resonance, these bonds can change their position. Right? So this is another Lewis structure, this is another Lewis structure. So obviously one single molecule, one single compound cannot be represented here by either this or either this. So basically the compound is represented as the resonance hybrid of these two resonance structures. These two structures, Lewis structures, which are representing the molecule are the resonance structures of that molecule, and the whole molecule benzene is represented as resonance hybrid of these two structures. So it will be represented as this. So this circle means these double bonds, these three bonds are rotating in this molecule between these 6 carbons. So that is resonance hybrid. Resonance hybrid. Okay. So basically that is resonance structure. So what will be the condition for resonance structures? So only electrons, which means pi bonds and lone pairs. So pi bonds and lone pairs. So only they will move. In resonance structures are formed because of the movement of pi bonds and lone pair. Nothing else. Don't move atoms. Atoms never move in resonance structures. So atoms never move. See. Okay, so if 2 or more structures are given and they have asked which is the resonance structure, and in some structure atoms have moved, atoms have changed their position, then it is not a resonance structure. It can be structural isomer, but it will not be resonance. Okay, and the net charge of the molecule remains the same in all the resonance structures. Net charge. So if the molecule, if this benzene would have contained plus charge, so in both the two resonance forms of benzene, it will contain plus charge. Net charge will be retained. Okay, so these things you have to take care while seeing the resonance structures. Okay, batao. Okay, so now how to calculate stability? So see, first you will see octet rule. The molecule in which maximum atoms with complete octet are there. The resonance form in which maximum atoms will complete octet are there will be more stable. For example, CH2OH positive, right? And CH2 positive OH. So this lone pair goes here, movement of lone pair, and this resonance form is made. So in this form, carbon octet is not complete. But in this form, carbon octet is complete and oxygen octet is complete. So this form will be more stable, where octets of the atoms, here one octet was incomplete, here no octet is incomplete. So this form will be more stable. Okay, resonance form. Okay, then you have to see number of covalent bonds. Generally these two rules coincide. The molecule with maximum atoms whose octet are complete will generally have more number of covalent bonds. But if there is a scenario where two resonance forms are given and the octet is completed for equal number of atoms, and in some molecule more covalent bonds are there, so more covalent bonds will have more stability, because more bonds are formed, so more energy will be released, so more stable, right? Then neutral versus charge. If number of covalent bonds are also same, then see if the molecule is charged or neutral. If the molecule is neutral, resonance form is neutral, it will be more stable. If it is charged, if both the resonance forms are charged, then see placement of charge. Placement of charge means negative charge on more electronegative atom. Okay, so electronegativity is oxygen, I don't know if this is visible, oxygen, nitrogen and chlorine. So this is electronegativity order, and positive charge on less electronegative atom. So less electronegative means more electropositive atom. So carbon is more electropositive than nitrogen, than oxygen. And then if placement of charges is also same, then you will see distance between the charges. So opposite charges attract each other, so they should be close to each other, and like charges are further from each other, so they should be far from each other. Okay, so these are the rules that you have to follow to check the stability of resonance structures of same molecule. Okay, but if you have to check resonance structures of different molecules, see different molecules, so then what you will see? First, more linear conjugation. See, these two are different molecules, different, not same molecules. So these are resonance structures of different molecules, but in this resonance structure there is more linear conjugation. See, negative charge is more conjugated, there is more linear conjugation, so this will be more stable. Okay, then linear conjugation is more stable than cross conjugation. See, so here linear conjugation is there, here cross conjugation is there. So two pi bonds are being conjugated to this carbon from the opposite side, from here. So this is cross conjugation, and here all the pi bonds are conjugating in same direction. Okay, so this is linear conjugation, this is more stable. Okay, and positive charge on less electronegative atom, negative charge on more electronegative atom. See, these two are different molecules again. So positive charge here is on nitrogen and here is on oxygen. So on nitrogen, positive charge is more stable as compared to oxygen, because nitrogen is less electronegative. Then these two are same, these two are different molecules. Here O minus, S minus, S minus, S minus. So here difference is in this oxygen and sulfur. So here negative charge is on oxygen, here negative charge is on sulfur. So negative charge is more stable on sulfur, because sulfur is larger atom, so negative charge will be stable on that, so it is more stable, right? So this is how you compare the stability of different resonance structures of different molecules. This is how you compare the stability of resonance structures of same molecules. Now do this question. Here same molecule is there, you have to compare the stability of different resonance structures of the same molecule and give me an order. So do this. हाँ ये कौन है भाई? वर्षाल. नोट्स मिल जाएंगे यार, नोट्स ठीक है मिल जाएंगे, देख लेना. ठीक है, फ्री मटेरियल में होंगे. इट विल बी इन फ्री मटेरियल ऑन द ऐप, राइट? सो गो देयर एंड फाइंड दीज नोट्स. ओके, you can download the app as well. Okay, ठीक है. So बताओ यार इसमें क्या होगा? See, so first we have to find the octates. So here carbon octet is incomplete, C positive. Okay, here basically octet is complete, carbon negative and positive. Octet is incomplete for nitrogen. Okay, and positive. Okay, here octet is complete for nitrogen and octet is complete for nitrogen. So basically what will happen? This will be more stable, I think, or this will be more stable. Third will be more stable, or this will be more stable. Tell me. See, count the number of electrons. Nitrogen needs how many electrons? 1, 2, 3, 4. So 4 electrons of nitrogen, 1, 2, 3, 4. Okay, so 4 electrons of other molecules. So 8 electrons are there. So octet is complete. Here 1, 2, 3, 4. 4 electrons are there and 6 electrons are there. Okay, a negative charge is there, and basically, okay, so 1 extra electron, 3. So nitrogen's valency is this. So right, so it needs 3 electrons to complete the octet. Okay, right, it needs 3 electrons to complete the octet. So 2 electrons are coming from this nitrogen and 1 extra electron via negative charge. So this is also complete, and here 2 electrons are coming from here, 2 electrons are coming from here. So 4 electrons are coming, but then 1 positive charge is there, so 1 electron is going. So both the nitrogens are having complete octet. So this will be more stable. Okay, okay. Then among these you can find here, so this octet is complete, nitrogen, and this octet is complete, this octet is complete. This is also, why this is not as stable as this? Because here negative charge is on carbon. Carbon is not electronegative. It is not electronegative, right? And you can see the electronegative part and also that. So basically this, and here what will be the octet? 1, 2 and 3 octet complete. 1, 2, 3 octet complete, and here octet is incomplete. So obviously second will not be the answer. In fourth 1, 2 and plus, so octet is incomplete again, and 1, 2, 3 and octet complete. So this is complete octet, only third is complete octet here. So first will be more stable, then third, then let's check for second and fourth. So what will happen in second and fourth? In second, positive is on carbon. In your fourth, positive is on nitrogen and negative is on carbon, and here negative is on nitrogen. So what will happen? Batao, number of covalent bonds 1, 2, 3, 1, 2, 3. So number of covalent bonds are also fine. Octet is not complete, octet is not complete. So number of covalent bonds are same. Then what will you check? See, number of covalent bonds are same. Neutral versus charge, so both are charged. Placement of charge, distance between the charge. So both are almost same. Both are almost same, don't you think? Don't you think? CH2 positive, CH2 negative. But the point is here negative charge is of complete octet. Here negative charge is of complete octet. Okay, and here also, here positive charge is of incomplete octet. Okay, okay. So how will you decide the stability then? Tell me fast. What will you do? First and third, after that what will be the answer according to you? बताओ जल्दी. Someone is saying D. D what? D what? D what? D what? See, here what is happening? Positive charge is on less electronegative atom, negative charge is on more electronegative atom. Here positive charge is on more electronegative atom, negative charge is on less electronegative atom. So charge distribution is wrong, na? So this will be least stable. Second, fourth. Positive charge on carbon, carbon is less electronegative, so it will be stable in positive charge. Negative charge on nitrogen, it will be stable in negative charge, but nitrogen is not stable in positive charge. Carbon is not stable in negative charge. Okay? So this will be the stability order. That's how you have to calculate the stability of resonance structures. Okay? Okay? Chalo. Okay. So then what is hyperconjugation effect? Hyperconjugation effect is just delocalization of sigma electrons with p orbitals or pi star orbitals. How? See. So this is my sigma electrons, CH. If there is a vacant p orbital, so this sigma electrons will go into vacant p orbital, and what will happen? So CH2 H plus CH2. So this will be the resonance form now, hyperconjugated form. So this is plus H effect. Why plus H effect? Because this sigma electrons of sigma carbon hydrogen are donated into vacant p. They are donated into vacant p orbital, right? So here overlapping is done with vacant p orbital. Similarly, here there is a radical. So radical is in p orbital. Okay. Similarly, again, this sigma electrons, only one electron will be shared, and one electron will go back to your hydrogen. Okay. So what will happen? CH2 double bond CH2 hydrogen radical will be there. So this is now hyperconjugated form. So hyperconjugation plus H effect also stabilizes your radicals. Okay. Then there is a pi star here. So here is a pi bond. So there will be a pi star, right? Pi star and pi star. So basically this sigma electrons will again overlap with this pi star. So what will happen? CH2 H positive double bond, and this bond will break. Okay, double bond CH CH2 negative, right? So this is now how hyperconjugation affects the pi star orbitals. So again, if you see this, what will happen? There is a pi star of benzene, right? So this sigma orbital will go into pi star of benzene, and this bond will break. So what will happen? CH2 H positive and this will be negative. So this is how hyperconjugation happens here. So these are different forms of hyperconjugation that happens. So is this fine? 1 3 2 4 पिछले वाले का 1 3 2 4. What did I write? सही लिखा है 1 3 2 4. हाँ सही है भाई, सही है. Good. चलो ठीक है. So this is hyperconjugation effect. Okay. So now tell the answer. The hyperconjugative stabilities of tertiary butyl cation is this. Tertiary butyl means 4 carbon and tertiary means 3 degree carbon cation. Okay. And 2 butene. So 2 butene. This 2 butene. So tertiary butyl cation and 2 butene hyperconjugative stabilities respectively are due to. So they are asking what will be hyperconjugation in this. Tell me the answer. Which orbitals will be involved? ये यहाँ पे ब्लर है, वहाँ पे इतना नहीं दिख रहा होगा, देखो. So which will be there? See, so there again, so you can write this as CH2H. So here there is a sigma CH, so it is interacting with vacant p orbital, just like this. Okay. So sigma CH to vacant P is the hyperconjugation here. Here, what will be the thing? So hydrogen. So again, here sigma bond will be there. So here it will interact with pi star. Okay. So this will be sigma CH to pi star C triple bond, C double bond C. So these will be the answer. So sigma to P empty, sigma to pi star electron delocalization. Right? There is no other option. Right? Is it fine? हाँ A. Good, good, good. फुल ईयर तो पार्ट भी ऐसे पढ़ा है पर अभी आपसे रिवीजन कर रहे हैं एक डिफरेंट पीओवी के लिए. अच्छा राजू, ठीक है चलो. नाउ द डिक्रीजिंग हाइड्राइड एफिनिटी फॉर द फॉलोइंग कार्बोकेटायंस. सो द पॉइंट इज हाइड्राइड मीन्स H minus. So this H minus, what it will do? It will attack at the carbocation. Okay, obviously because this has negative charge, this has positive charge. So this is nucleophilic, this is electrophilic. So this will attack on this. So the hydride affinity is tendency of carbocation to attract this hydride towards itself. So more stable this carbocation, more it will attract this hydride, because this carbocation, this positive charge will attract this negative charge when this positive charge is unstable. It wants to be stable. So hydride affinity directly or inversely proportional to stability of carbocation. Okay, acha, before this, see these thing. Wait. So how to check the stability of intermediates? What order you need to apply for the electronic effects to check the stability of intermediates? Okay, so you can remember this thing known as Madari. Madari means mesomeric. So you will first check if there is a mesomeric effect. Then you will see dancing resonance. Then you will see aromaticity. Then you will see resonance. Then you will see hyperconjugation. Then you will see inductive. So in this order, this is the order you have to follow. First check mesomeric, then dancing, then aromaticity, then resonance, then hyperconjugation, then inductive. Madari. Okay, but in Madari after R there is H. Madari. Okay. So now check the stability. First you see if there is mesomeric, if there is dancing resonance, if there is aromaticity, check the stability of carbocation. So more the stability, lower will be the hydride affinity. You have to give decreasing order of hydride affinity. Check this. So obviously this is carbocation. See here. So here there is a resonance effect plus R effect. Okay. So plus R is dominant. Here there are 3 plus C6H5 na. So C6H5 is benzene. So they will also provide plus R. So 3 into plus R. Okay. And then CH3, this is tertiary butyl cation. So 9 alpha hydrogens are there. So basically 9 hyperconjugation effect. 9 plus H. So only hyperconjugation effect is there. Then there is cyclopropyl group here. So cyclopropyl group does what? Dancing resonance. So this is dancing resonance only and it is very stable. So 3 into dancing resonance. So obviously more stable will be this. More stable is this. So this is more stable. So lowest hydride affinity. So D will be lowest. We have to find decreasing now, and most will be this because this is least stable, right? Here there is plus R as well as there are 3 and 3, 6 plus H effect as well, right? So this is least stable. So this is least stable. So it will have highest hydride affinity, C, then A, then B, CABD, CABD, B, right? Right? अरे A कैसे? A कैसे हो रहा है? अरे more stability means less hydride affinity, decreasing order you have to find. So most is C because that is the least stable carbocation here, and most stable carbocation is D, so that will have least hydride affinity. क्या कर रहे हो? Which of the following pair is more stable than the second? Do this. Again, intermediate, like we checked for carbocation intermediate, we will check for your radical. So do this. Please explain. Again, array. See, I told you na, this is the priority order. So first you need to see mesomeric, then dancing, then aromaticity, then resonance. Okay. So in this cyclopropyl, this cyclopropyl, and this cyclopropyl, these three will give 3 dancing resonance. What is dancing resonance? What is dancing resonance? These sigma orbitals will donate in this carbocation, positive carbocation. So this will be very stable, most stable. This is most stable. Among all these, this is most stable carbocation. So if this is most stable, it will not attract hydride. It will not want to combine with hydride because this is stable. So hydride affinity, tendency of hydride to attack on this carbocation will be least. So this is least affinity, right? Then among all these, this is least stable. Least stable among all these. वैसे तो this is stable carbocation, but among all these, this is least stable because there is only 9 hyperconjugation effect. There are only 9 alpha hydrogens. So alpha hydrogens will do this, something like this. See. So there is a carbocation. This is this carbocation attached to alpha carbon. So this is alpha hydrogen. So this alpha hydrogen participates into plus H effect. So if there are 9 alpha hydrogens, there are only 9 hyperconjugation effects. Okay. So this is least stable. So if this is least stable, the tendency of hydride to attack on this will be most. So this is most hydride affinity. Now A and B. So among A and B, so this carbocation is like this. This. So basically 3 benzene groups are there. So these benzene groups apply plus R effect. So 3 plus R effect are there. Okay. I'm not drawing this, I'm just telling you. So 3 plus R effect are there, which is very stable. So here there is only 1 plus R effect, wo bhi because of this one alkene. And 6 plus H effect because 6 alpha hydrogen are there. Here, right? Right? So among A and B, B is more stable. So tendency to attract hydride is less than A. So B will have second lowest hydride affinity, then A, then C will have highest hydride affinity. Okay? Okay? Done? Who was this? Mrinmay. ठीक है? चलो. Do this now. Do this. हाँ लिविया CABD राइट. पानी पी लेता हूँ मैं, तुम भी पी लो भाई, हाइड्रेट रहो, कीप योर सेल्फ हाइड्रेटेड. Today, how long you are attending this lecture will show your seriousness or your sincerity for your IIT exam. So, let's see who is more serious. Okay, so basically radical stability. So see, here there is plus R effect. Okay, plus R effect. Okay, so this is more stable. So which of the following first is more stable than the second? No, second is more stable, so this is not the answer. Here, this is 3-degree radical, so basically 2 hydrogens are here, 2 alpha hydrogens are here, 3 alpha hydrogens are here, right? So basically 3, 2, 5, 6, 7. 7 plus H effects are here, so obviously second is more stable, so no. First should be more stable. So here 3-degree, 3-membered ring is more unstable here. ठीक है? 3-membered ring is more unstable than 6-membered ring. Why? Because of angular strain in 3-membered ring. Okay, so stability of ring, 3-membered, 4-membered, 5-membered, 6-membered. Okay, so this is the stability of the ring. So this will be more stable. So again, this is not the answer. So obviously this will be the answer. But let's just check. So pH is 3 phenyl group. So pH. So 3 plus R effects, right? But here there is CH3. So 3 plus R effect are more stable than the hyper. So this is basically 3-degree, no? CH3. So they will just give hyperconjugation effect plus 9 into plus H effects. So obviously 3 resonance effect are more stable. So obviously first one is more stable. So D is your answer. Okay. Get a job. Arey, I am doing job. Okay. चलो, let's. अरे पता है मजाक कर रहा हूँ. ठीक. So let's see aromaticity now. So aromaticity, any compound which will be aromatic will follow your Huckel's rule of aromaticity. So for seeing Huckel's rule of aromaticity, you have to see 3 things. What? First thing is the molecule should have 4n plus 2 pi electrons. 4n plus 2 pi electrons. In this, n can be 0, 1, 2, 3 like this. Okay. So if n is 0, so this will be 2 pi electrons. If as n is 1, this will be 4 pi electrons. No, not 4, 6 pi electrons. If n is 2, this will be 10 pi electrons. So this is how these pi electrons should be there, and there should be complete cyclic conjugation of these pi electrons. How? See, if this is benzene, there are 6 pi electrons. So there should be complete cyclic conjugation. What does it mean by complete cyclic conjugation? Look here carefully. Okay. So if this is a pi bond, this will go here, this will conjugate here. So what will happen? This will come here, and here will be a positive charge, here will be a negative charge, and here will be a pi bond again. So this will then go there. So what will happen? Then here will be a negative charge, here will be a positive charge. Then this will go here. So what will happen? So this will be the structure. After this, again this thing will happen, and after doing this, again this structure will be formed. So these pi bonds are getting conjugated, but they are making a complete cycle. Cycle means from where they are getting started, they will again get to that position. This is the initial position. When this will again conjugate, this will go back to this initial position. So complete cyclic conjugation is there. So that is known as complete cyclic conjugation. So if there is a complete cyclic conjugation of these 4n plus 2 pi electrons, only then the system will be aromatic and the system should be planar. So one thing, one criteria to check planarity is all the molecules, generally all atoms, all carbons. This is not true in every case, but generally all carbon atoms should be sp2 hybridized. Okay, so then the molecule will be aromatic. So the compound where this rule is not valid is this cyclooctatetraene. So this is a tub-shaped molecule. Tub-shaped molecule is like this. Okay, so this is not planar. This is not planar. So because of this non-planarity, this is not aromatic or anti-aromatic. So acha, this is aromatic. So what will be anti-aromatic? If the molecule follows all these rules, but instead of 4n plus 2 pi electrons, it contains 4n pi electrons. So this will be anti-aromatic. Okay. So if this COT would have been planar, it would have contained 8 pi electrons, so 4n pi electrons. So this would have been anti-aromatic, but it is not planar, so this is non-aromatic. COT, cyclooctatetraene, is non-aromatic. Okay, but COT2 plus or COT2 minus. So COT2 plus contains 6 pi electrons because 2 electrons are lost na. Earlier there were 8 pi electrons. So 2 plus means 6 pi electrons. 2 minus are 10 pi electrons. So these are 4n plus 2 pi electrons. Now in these cases COT occupies planar structure. So in this case COT is planar and it is aromatic. Okay. So COT generally is not planar, but because due to aromaticity it wants to gain extra stability, so it will become planar. In this case COT2 plus and 2 minus. But in previous case, if it will become planar, it will be anti-aromatic. So stability is stability order aromatic, non-aromatic, then minimum is anti-aromatic. Okay, so because this anti-aromatic structure will have instability, so this will form tub-shaped structure. It will not be anti-aromatic. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 aniline. So this is also not stable. Why? Because if you see this is also not planar. Why? You must have studied this. Okay, so what happens is 1, 2, 3, 4, 5. So there is a hydrogen here, there is a hydrogen here. So these two hydrogens will repel each other. So this is known as flagpole repulsion. These two hydrogens will repel each other away. Okay, so because of this repulsion, one hydrogen will go above the plane, one will go below the plane, and the molecule will be non-planar. So this is non-planar. So non-aromatic. Non-aromatic because it is non-planar, and this is flagpole repulsion. Okay, then compounds, there are certain other compounds which you have to see. Like what? So basically this is a compound. So if this ring contains a positive charge, this will be aromatic, and this will contain negative charge. So what will happen? This bond will break and this compound will exist as this. Wait. Arre? Positive, negative. So this compound is now aromatic. This cyclopropene group with positive charge is aromatic. You can see 4n plus 2 pi electrons. N is 0 here, so 2 pi electrons are there. Okay. Now this, in this compound, in acha yahan pe dekh lo pehle. So this will break. So the electron will go here. Why? Because after breaking the pi bond, the molecule will be like this. Okay. Pi bond. So here there will be a plus charge, here there will be a minus charge. So minus charge on this 4-membered ring, this is also aromatic. Plus charge on this 3-membered ring, this is also aromatic. Okay, this 4-membered is also aromatic. It has 6 pi electrons. This 3-membered has 2 pi electrons, so both are aromatic. So it will exist in this structure. Okay, now this molecule. In this molecule, if you see, these pi electrons are in complete cyclic conjugation, but this is not in complete cyclic conjugation. Why? This can only go here. Can this go here? Can this go here? No, this can't go here. So it will not be a part of complete cyclic conjugation. So it will not be counted. So it will not be counted. So if this will not be counted, only this molecule will be counted, and this is benzene. So this is aromatic. So in a particular molecule, if one ring is aromatic, then the whole molecule will be said aromatic. So this is aromatic. But in this compound, see, this alkene can go here, this alkene can go here. So this can go anywhere. So this will be a part of cyclic conjugation. So this will now be counted. This will now be counted. Okay. So if this will now be counted, so then how many pi electrons will be there? 1, 2, 3, 4. So 8 pi electrons are there. So if there are 8 pi electrons and whole molecule is planar, so this will be anti-aromatic. Okay, so this will be counted. Okay, and last thing is anti-aromatic compounds. I don't know if you can see here. You will get this. Note, so you can see there. So this is anti-aromatic compounds are unstable at room temperature and they don't exist. So I will just keep them back. Okay, so anti-aromatic compounds are non-stable. Anti-aromatic compounds are non-stable and they don't exist at room temperature. Okay, so then among the following aromatic compounds will be batao, which will be the aromatic compounds among these? Check this. जल्दी बताओ. जल्दी जल्दी करेंगे, फास्ट फास्ट, गरीबी नहीं फैलाएंगे. Someone is saying C. So aromatic compound we have to find. So obviously first thing is 4n plus 2 pi electrons. So obviously, and 4n plus 2 pi electrons. So 4n plus 2 pi electrons, either 2 pi electrons, either 6 pi electrons, either 10 pi electrons, whatever. So this will be aromatic. Benzene yaar. Benzene is aromatic. Benzene, right? And then if you see D, here there are only 4 pi electrons. So this is 4n pi electrons. So this will be not aromatic. But here 6 pi electrons are there. So this is 4n plus 2 pi electrons. So this is aromatic. If you see this is not aromatic because complete cyclic conjugation is not present. These bonds are not conjugating with each other, right? There is not complete cyclic conjugation. Incomplete conjugation. Incomplete cyclic conjugation. So B and C is your answer. Okay? Okay? Chalo. Which of the following molecules in pure form is or are unstable at room temperature? See, I told you which compounds are unstable at room temperature. Which compounds are unstable at room temperature? Anti-aromatic. So they are asking which are anti-aromatic. Simple. Bata do. Which is anti-aromatic? I can see this one. Right? Cyclobutene. Basically 4 pi electrons are there, na? 4 pi electrons. So this is anti-aromatic. This is obviously this is not complete conjugation. So this is not aromatic, anti-aromatic, whatever. This compound here will break. So this will be O minus, this plus. But if this is plus, this is again anti-aromatic. This is again anti-aromatic. But the point is, here this structure is not given. Here this structure is given only. Okay. Here this structure is given only. Right. So for sure this will be anti-aromatic. If you are not sure about this will be anti-aromatic. Okay. And here this will be like this. Tropylium ion. So this will exist as this. See, so these molecules can exist as this. Why? Because by existing like this will be aromatic, right? But if this will exist as this will be anti-aromatic. This is. So this will not exist as this. Now, why will it attract instability towards itself, right? It won't attract instability towards itself, right? Right? So the only thing is this will be aromatic, this will be non-aromatic, this will be non-aromatic, anti-aromatic is this, 4 pi electrons. Okay? Okay? अरे B C नहीं, C should have been anti-aromatic, but it will not be. It will not exist as like this. It will not exist like this. O minus plus. Why? Because this is anti-aromatic. Why will it want to be unstable? It won't be unstable. It is stable. It is stable at room temperature. At room temperature, it will exist like this only. Okay? It will not exist as anti-aromatic. Okay. So then basicity. So we'll do basicity. You take 5 minutes break. Okay, जाओ 5 मिनट का break लो, because I think a lot of things I will put in your brain, it will all be mushed up. So basically till now, till aromaticity, is everything fine? Just tell me. Is everything fine? If everything is not fine, I won't give the break. I will give the break, but till now, till aromaticity, is everything fine? If the question didn't say room temperature, Olivia, but that type of question won't come. Okay, so that is a very vague type of question. They don't give such types of questions. Okay, so they don't give such types of questions. फिर भी I will check that question once. You will go into break. I will take 5 minutes break. I will check that question. I will come back to that question again. Okay, don't worry. Okay, तो चलो 5 minutes break. Then we'll meet. चलो थोड़ा सीट से उठ जाओ, go and have some walk, listen to your music, refresh your mind. Okay, don't be sitting in front of the screen. Okay, don't be like that. चलो. आ जाओ, come on. Are you guys there? So break is over. Am I audible? Am I audible? Break is over. Let's start basicity. Let's start basicity. आ जाओ जल्दी. Come on, come on, come on. Fast. Fast, fast. Are you back? Hello, hello, hello. आ जाओ जल्दी आ जाओ. जल्दी आ जाओ. Are you guys back? Shall we start? Are you done with your break? So shall we start? Shall we start? Okay. So in that question, I told you, I will get back to you with that question. So in that question, if this would have been a multiple choice, okay, then this would also have been correct answer. But generally, if this is not multiple choice, this is only single type of question, like where only one option will be correct. So more valid answer will be this only. Why? Because at room temperature, this is non-aromatic, anti-aromatic. This still has the choice to be anti-aromatic or not be anti-aromatic, because this has the choice to be present in this structure as well as this structure, right? So basically here things can be difficult, but the point is one short answer will be B, that is for sure. Okay, okay, audible. Okay, chalo. So basicity, basic strength. Basicity means basic strength. So basicity we have to measure for different types of compounds. So basic is a compound. Basic compound is a compound. Basic compound. हाँ, नहीं, thank you. Basic compound donates electrons. So that is a basic compound. Obviously basicity means donation of electrons, and acidity means acceptance of electrons. Let me, अरे यार मैं चश्मा. Wait. Okay. So if you need to check the basicity of a particular compound, so then you will check the availability of lone pair, because that is donation of lone pair, right? Basicity means donation of lone pair. So more available this lone pair is, more will be donation, right? So more will be the basicity. And stability of conjugate acid. What is conjugate acid? For example, ammonia. So ammonia is a base, so it will take H plus, it will donate its lone pair, right? After taking H plus, it will form NH4 plus. So this species, after donation of lone pair and taking H plus, this species is now conjugate acid. Why? Why this is conjugate acid? Because this has taken H plus right now. Now it has the option to give back that H plus. So the species that give H plus are acid. So this is conjugate acid of this conjugate base. Okay. So more stable this acid is, lesser will be the tendency for the reaction to go back, lesser will be the tendency to give H plus back, obviously. So more stable this is, means more is the basicity of the conjugate base. Okay, so now these are the amines given. Okay, so this is nitrogen lone pair, nitrogen lone pair, nitrogen lone pair, and then cyanide. So in cyanide, basically there is C triple bond N. Okay, so negative charge on more S character atom. More S character means sp, sp2, sp3. So sp has more S character, sp2 has lesser S character, sp3 has even lesser S character. So if the negative charge is on sp hybridized carbon or any sp hybridized species, so that is more stable. More stable with negative charge or lone pair. So if lone pair is on sp hybridized atom, so its tendency to give that lone pair is less, because lone pair or electron density at that sp hybridized atom is very high. So it will not give electrons that easily, right? So you can see, so here this is sp3, here this is sp2 nitrogen, here this is sp2 only. Why? Because this will go into conjugation. Okay, so for going into conjugation, this lone pair should be in normal unhybridized orbital. So this is sp2 only, and here this is sp. This nitrogen is sp hybridized. Okay, so lowest tendency to give electrons is of this nitrogen, which is sp hybridized. Then among these two, lower tendency is of this. Why? Because this is involved in conjugation. Okay, this is not involved in conjugation. This is not involved in conjugation. This still has its lone pair, it can give the lone pair, but its lone pair is involved in the conjugation, so it is not available. So this has less tendency to donate the lone pair, and this has the highest tendency to donate the lone pair, so its basicity is highest. Basicity means basic strength is highest, and if in the question pKb is asked, so pKb is inversely proportional to basicity. So more strong a base is, lower will be its pKb value. Okay, or you can say inversely proportional to Kb. So more stronger a base, more will be the Kb value, lesser will be the pKb value. Okay, so you can check that out. Now among these, so this lone pair is again involved in conjugation, this lone pair is also involved in conjugation, this lone pair is also involved in conjugation, but here this electron donating minus M group, NO2 is a very good electron, sorry, withdrawing group, minus M group. So it will attract these lone pairs. So these lone pairs will be more conjugated. Here there is no group, normal hydrogen, right? Here there is plus H group, so electron donating group. Here there is a electron withdrawing group. So this will donate electron to this center. So this lone pair will not go into this center. It's kind of cross conjugation type of structure. So basically this lone pair is more available for donation. So if this is more available for donation, so basically it will be most basic, then this is medium basic, and then this will be least basic. Okay, then these compounds, this is pyridine, nitrogen lone pair, this is aniline, this is pyrrole, okay, and this is normal cyclohexane amine, right? So here there is no conjugation, here there is no conjugation, here also there is no conjugation. Why? Because pyridine is aromatic. So if this lone pair will be conjugated here, so now 4n plus 2 pi electrons की जगह, मतलब 6 pi electrons की जगह there will be what? 8 pi electrons. So this will be anti-aromatic. So they won't go into conjugation. Okay. Now this will go into conjugation, and this is pyrrole. This will go more into conjugation. Why? Because of this conjugation, this whole pyrrole will turn aromatic. So there is a difference. Try to understand. This pyrrole will turn aromatic because of conjugation of this lone pair. This is already aromatic. That's why this conjugation is not possible. This conjugation is very much possible because of this will be aromatic. This will not be possible because of this will be anti-aromatic. This is already aromatic. So this does not need these electrons. Okay. So here obviously, but the point is this is sp2 hybridized, or sp2 hybridized, and this is sp3 hybridized. So I told you sp2 hybridized lone pair is more stable, so tendency to give this lone pair is less. So most basic is this, then this, and here will be conjugation. So this is more conjugated, so this will be least basic. Okay. Okay, this is how you check the basicity. बताओ. pKb increase, then solubility decrease है? ये क्या है? pKb increase. अरे solubility की कहाँ से बात आ गई अभी? अरे जो पढ़ा रहा हूँ उस पर ध्यान दो. Solubility वगैरह अभी, this is not ionic equilibrium going on. Don't worry about that. ठीक है, चलो. NH3, RNH2, R2NH and R3N. So this is 0 degree amine, basically ammonia. This is 1 degree amine, 2 degree amine, 3 degree amine. A lot of students get confused in this, a lot of students. So in general gaseous state, the order for basicity is 3 degree, most basic, then 2 degree, then 1 degree, then 0 degree. Why? Because in 3 degree, R, N, R, R. So basically there will be a lot of hyperconjugation plus I effect. So this lone pair, obviously there will be repulsion with this lone pair as well. So this lone pair will be more available. Like this lone pair has highest tendency to go, right? So this will be most basic, then followed by 2 degree, then followed by 1 degree, then followed by amine, normal ammonia, right? So this is gaseous phase. Now here in your solution phase, there will be hydration. So in solution phase, what happens is when R3 N donates its lone pair to a particular hydrogen. Obviously, being a base, it will donate lone pair, so it will convert into R3NH positive. So this is conjugate acid. So this conjugate acid will be stable in solution via hydrogen bonding, OH. Okay, so more the number of hydrogen bonding, more stable will be the conjugate acid. So in 3 degree, only one hydrogen bonding will be there. In 2 degree, there is a plus. In 2 degree, there are 2 hydrogens. So basically 2 hydrogen bonding will be there. In 1 degree, there are 3 hydrogens. So 3 hydrogen bondings are there. Okay. In ammonium ion, there will be 4 hydrogen bonds are there. But the point is, this ammonium ion is still least basic. Why? Because there is no R group here. So R group will push the electrons further, but there is no R group here. So this will be least basic in both the cases, 0 degree, 0 degree, right? But then point is, according to this, 1 degree should be most basic, and according to this, 3 degree should be most basic. 2 degree is the silent warrior. It is lying in between, right? So in solution, 2 degree gets lucky and it is most basic. Then if there is CH3 group, then 1 degree will be basic, more basic, then 3, then 0. If there is C2H5 group, C2H5 group is more bulky. So if it is more bulky, then this factor plus R effect, plus H effect, plus I effect, steric repulsion, that dominates. So if that dominates, so 3 degree will become more basic than 1 degree because of 3 bulky groups. Okay, so that is the logic here. Okay, batao, is it fine? Is it fine? Last example again. Which example? ये वाला. अरे यार, अच्छा देखो, समझो मेरी बात समझो. क्या है, मैं यहाँ पे दिखा देता हूँ. समझो, ध्यान से समझना. NH2. Okay, this is normal cyclohexane amine. Then your pyridine. There is a lone pair here as well. Lone pair here as well. Then your aniline, NH2, then pyrrole. देखो, right? This is pyrrole and there is a lone pair. Now see. What is happening here? There is sp3 nitrogen. There is no conjugation here. Obviously, this is easy. I think there will be no problem here. So this will be most basic. Tendency to give electrons is most here. Now, the main problem I think that would be that you would have encountered is in pyridine and in pyrrole. Okay, so in pyridine, count the number of pi electrons. So 6 pi electrons are already inside the ring. So this is aromatic, no? This is aromatic. So if this goes here, if these two electrons also go here, from 6 pi electron it will become 8 pi electron. So this will become anti-aromatic, and this is also not possible. Why? Because this nitrogen is sp2 hybridized. If this lone pair also goes into conjugation, this will turn into sp hybridized. Sp means 180 bond angle. So that will be a lot of steric repulsion, angular strain. Okay, so this lone pair going into conjugation, is not possible. So this lone pair does not go into conjugation, but this is still sp2 hybridized nitrogen. So less tendency to give lone pair as compared to this sp3 nitrogen. Okay, now in this there are 4 pi electrons. So if this goes in conjugation, there will be 6 pi electrons, and this will be sp2 hybridized. So this will turn aromatic because of this conjugation. Okay, and because this conjugation turns this aromatic, this is extensively conjugated, like very much conjugated in this system. Okay, like high conjugation. Okay, but this is also conjugated, but But because of this conjugation, there is no aromaticity. There is no aromaticity. Aromaticity only disturbs because of this conjugation, because benzene itself is aromatic. But when this is conjugated, benzene's aromaticity will be disturbed. So this conjugation is not as much preferred as this conjugation. So there is lower conjugation compared to this. Both are sp2 hybridized. This is also sp2 hybridized. Okay, so if this is more conjugated, this lone pair won't be available compared to this, and this lone pair will be more available than both of these because this is not conjugated. So order will be this of basicity, right? Right? Okay. Chale? So this is the basicity of amines in aqueous and your gaseous state. Okay. So do the following question. In the following compound, favorable site for protonation. So protonation means addition of H plus. Proton means H plus, na? Do this question. अरे कौन सी मानसी है ये? Do this question. So basically, site for protonation, basically the most stable site will be most favorable for protonation. Most basic site will be most protonated, obviously. If it is one site is most basic, so it has highest tendency to take H plus, so it will be highest. It has highest tendency to take the H plus, so highest tendency to get protonated. So favorable sites for protonation is NR. So this is basically lone pair, pyridine. Okay, this is pyridine. This can go and take H plus. Okay, here there is a lone pair which is involved in conjugation. So if this is involved in conjugation, there will be a negative charge here, or there is a lone pair here which can go into protonation. Okay, so in both of these, one can be protonated. Okay, so I am assuming this E, this is E, this is E, I don't know if this is visible, this is E, this is protonated, or not protonated, I am saying this is conjugated. This lone pair is into conjugation, so this won't be available for donation. So this lone pair will be available for donation. Similarly, this A lone pair is also conjugated, but this lone pair will be available for donation. Okay, this will be available for donation. So basically, this is your A, B, C. This is C, this is D, this is E. So B, C, and D. B, C, and D. Fine. Fine. बताओ. अरे C कैसे? A and D. A and D. A is involved in conjugation, so why will it protonate? It won't protonate. Protonation will happen with the electrons which are not in conjugation. So this, and this. So B, C, and D. Okay, chalo. Arrange the following amines in the decreasing order of basicity. So decreasing order of basicity, you have to arrange them. हाँ लिविया, B, C, D. Good. चलो, increasing or decreasing order of basicity. So decreasing order means like most basic then least basic. So most basic among this will be, I think this is your sp3, na? sp3. So this is most basic. This is going into conjugation, pyrrole, aromatic. This is not going into conjugation, but this is sp2. So most basic will be third, then first, least basic will be second, because this conjugation is causing aromaticity. So tendency to give electron is least in this, so falling decreasing order of basicity. That is the thing. 3, 1, 2, right? 3, 2, 1 नहीं, अरे 3, 2, 1 नहीं, 3, 1, 2 भाई. 2 will be least basic. अरे पायरोल है, अभी तो समझाया. So Is this visible? This is aniline, this is ethanamine, this is N-ethyl ethanamine, this is N-diethyl ethanamine. pKb values are given. So basically you have to match the pKb values. Do this. हाँ अली भैया 312 आएगा, अभी तो समझाया 321 कैसे होगा. Do this. So aniline is basically, so aniline is this na, benzene and NH2, so this is A. Then ethanamine, ethane, CH3, CH2, amine, NH2. Then N-ethyl ethanamine, so this is 2 degree, N-ethyl ethanamine. See again, if you don't know the nomenclature, you won't be able to draw the structures. N-diethyl ethanamine. So N-diethyl ethanamine. So this will be ET, N, ET, ET. So this is your 1 degree. This is also 1 degree. This is 2 degree. This is 3 degree. 3 degree amine. Okay. So, but this is 1 degree, but their electron is going into conjugation. Okay. 1 degree along with conjugation. So lone pair won't be available for donation. So here 3 degree lone pair will be, if nothing is given. If nothing is given, I think take for solution. If nothing is given, take solution phase, aqueous solution, because pKb is measured in aqueous solutions, it is not measured in gaseous phase. Okay, so take aqueous solution. So in aqueous solution, obviously 2 degree will have the maximum basicity. If it will have the maximum basicity, it will have least pKb value. So this C part will have least pKb value. Okay, then it is ethyl, not methyl. So in ethyl, 3 degree has more basicity than 1 degree. So 3 degree is D. So then 3 degree will be most basic. Wait. So most basic is your, most basic is 2 degree. So least pKb value. Then lower basicity will be 3 degree. So it will be higher pKb value, 3.25. Then 1 degree. So 1 degree will be least basic among these 3. So it will have highest pKb value, 3.29. Okay. Then aniline. Aniline will be least basic among all 4. Why? Because lone pair is conjugated. So if this is least basic, this has highest pKb, which will be 9.38. Okay. You can check that. Is this fine? बताओ अब जो भी है, D है या क्या है, D है या क्या है, कोई नहीं, जो भी है, बट ये होगा मैचिंग. ओके चलो, इंक्रीजिंग ऑर्डर ऑफ pKb फॉर द फॉलोइंग कंपाउंड्स. सो कंपाउंड्स आर गिवन, फाइंड द इंक्रीजिंग ऑर्डर ऑफ pKb अगेन. सो इफ सच क्वेश्चन इज गिवन, डोंट बी कंफ्यूज्ड. फर्स्ट फाइंड द order of basicity, increasing order of basicity. Okay, if you are finding increasing order of basicity for pKb, reverse this order. Reverse this order for pKb. It's simple, na? Reverse order. Okay, so let's see for basicity. If you are seeing this is 2 degree, this is 2 degree, this is again in conjugation. See, this lone pair is in conjugation, but this will be available for donation, but this is sp2 hybridized. But here this is 2 degree and this is sp3 hybridized, normal aliphatic. So obviously most basic will be this, most basic. So if this is most basic, least pKb. Okay, this has least pKb. Then among these two, so here there is 1 lone pair for donation. Here how many lone pairs are there? This will go into conjugation. Okay, so if this will go into conjugation, this lone pair is there for donation. Okay, and this will also go into conjugation, but at a single time only one will go into conjugation. Na? At a single time only one will go into conjugation. Okay, so if let's make the conjugate acid. Let's make the conjugate acid. Wait. Nitrogen, 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 H. Okay, so let's suppose this takes hydrogen. Okay, this is plus. Now what will happen? This will go into conjugation. Okay, so if this goes into conjugation, now this will have plus, not this, right? So this plus is shared by this nitrogen. Okay, then after that this can go into conjugation. So if this will go into conjugation, then this will have plus. So one positive charge, one positive shared by 3 atoms. So conjugate acid is stable, more stable. If it is more stable, the base is more basic. That's what I told you, na? If this is more basic, then less pKb. So least pKb is this, then this, highest pKb is this. So pKb A, B, C. Right? बताओ बताओ अरे इंक्रीजिंग ऑर्डर में करना है. इज दिस फाइन? लेट मी चेक द आंसर वंस. मैंने भी ठीक किया है कि नहीं किया? वेट, I also check the answers, no? I am also not perfect, so maybe I have done some mistake. अरे एक सेकंड हाँ ठीक है मैं वही सोच रहा था ठीक है. सो द एक्सप्लेनेशन इज फाइन. नाउ द पॉइंट इज this order will be reversed actually. Why? That's what I was thinking. That's why I checked. Why? Because in all of these, here you can see 2 lone pair donators. Here you can see 3 lone pair donators. Here there is only 1 lone pair donator. Are you able to see? So only one donation. So this will be, again, let's see the Kb value. Kb is basicity value. So most basic will be B because of this explanation. Stable conjugate base, most basic, right? B, then A, then least basic will be C. Why C? Because it only has 1 lone pair donators, other has more lone pair donators. So obviously they will be more basic. So if they are more basic, then pKb A, C. Okay, that's why I wanted to check, because I was confused. Now you are fine? Is this fine? बताओ. Clear? बताओ. जल्दी बताओ. Is this clear why I did this? You have to see how many lone pair donators are there first of all. So in these molecules obviously more lone pair donators are there, so this will be less basic. But how much less basic, that is the thing. But these will be more basic. But among these, this will be more basic. Why? Because it has 3 lone pair donators first of all, and its conjugate base is more stable. Conjugate acid is more stable, so basicity will be more. Okay? Okay? Tell me. Chalo, do this. Increasing order of basicity of the following intermediates. So there are intermediates and increasing order of basicity you have to find. Find them out. Find out here. देखो again, this is C minus, this is C minus, this is C minus, this is everything is C minus. But the point is here this is sp3 hybridized, here this is in conjugation, so this will be sp2 hybridized, here this is sp hybridized, here again sp3 hybridized, here again Cn minus is this C triple bond N and C पे minus दे रखा है, it is not on N, it is on C, so C minus, so again sp. So I told you negative charge on lone pair is more stable on more S containing or more S character atom. So this atom contains more S character, sp hybridized. So this will be more stable compared to sp2 and sp3. Similarly, this will be more stable compared to sp2 and sp3. So you can check the stability. You can check the molecule which will be more stable will be least basic. So more stability. So it means it won't want to donate the electrons. So if it won't want to donate the electrons, among these you can check first B and E. So this is in conjugation. This is in B and C, sp hybridized. Okay. So this is triple bond. So there is a nitrogen electronegative atom. So electronegative atom will obviously pull some electrons towards itself. So this will be less basic. So E is least basic. KB order I am finding. Then there will be C. Then there will be C. Then after that sp2 hybridized is this B. Then after that among these sp3 hybridized, so this will be more unstable because 3 bulky groups are there, 3 CH3. So they will make the negative charge more unstable. So most basic will be A and then D. So if this is KB, then increasing order of the basicity, so basicity order is this. So increasing if you have to find, reverse this. So A will be there and E will be here. So increasing if you have to find, this is the thing. Okay, बताओ. Okay, chalo. Do this. Compounds which will liberate CO2 with sodium bicarbonate solution is or are. So sodium bicarbonate solution, you have to liberate CO2. So what happens? The concept is sodium bicarbonate is HCO3 minus. So bicarbonate ion. So if your compound can give H plus to this bicarbonate, so this will form what? H2CO3, and this H2CO3 in aqueous solution will convert into H2O and CO2. Okay, so CO2 will liberate. So this is the concept, but the point is this reaction is reversible as well. This reaction will reverse as well. Why? Because compound after giving H plus will form conjugate base. Right yaar? Conjugate base ही तो बनाएगा. So if this will form conjugate base, so this H2CO3 can again give H plus to conjugate base to go back to this thing. So point is my compound a better acid than H2CO3? If my compound is a better acid than H2CO3, the H plus donating tendency of my compound will be more. Okay, so this reaction is only possible if acidity of my compound is more than carbonic acid. If this is the case, then it will donate H plus to HCO3 minus and form its conjugate base, not the reverse reaction will happen. More reaction will be this, forward reaction will be the major reaction, and that will then liberate CO2. So you can see which of the acids here are more acidic than H2CO3. Obviously carboxylic acid will be there. So this will be more acidic. Simple. Then picric acid. Picric acid is OH, and then there are 3 NO2 groups. And then OH, 3 NH2 groups. So these NH2 groups are basically what? Electron donating. If they are electron donating, after giving H plus, O will convert into O minus, and if they are donating the electrons to benzene ring, so this electron will not be conjugated. Less conjugation, because ring is already very much electron, like electron excess, right? Because of this 3 plus M effects, plus M plus M plus M plus R, whatever you want to call. So basically least donation or least conjugation, or least, you can say least stable conjugate base. So if its conjugate base is least stable, this is less acidic than H2CO3, so this will not form the compound. This reaction, these both will give this reaction because these are minus M groups, minus R groups, minus M groups, right? So when there will be O minus, this will go here, so on ortho and para, minus will be there. So this minus will be stabilized by minus M of NO2. So this is very much acidic group, picric acid. Okay, so these both groups are more acidic than H2CO3, so they will give this reaction. Okay, बताओ. हाँ लिविया, you should यार. ठीक है, ठीक है, चलो. So this is acidity ना, this is acidity. So again, acidic character or acidity will be availability of H plus. Like their availability of lone pairs were checked for basicity. Why? Because base is a compound which gives lone pair. So acid is a compound which gives H plus. So if it is giving H plus, you have to check the availability of H plus first, then stability of conjugate base. So stability, more stable the conjugate base, more stable conjugate base, it means more acidity. Okay, that is the thing. So correct order of acidic character, find out. Correct order of acidic character. So acidic character, again you will see the stability of conjugate base, right? So these are the acidic characters. So give me the answer, I am waiting. See, here make the conjugate bases. So conjugate base of phenol will be O minus. Conjugate base of COH NO2 will be COO minus NO2. Conjugate base will be COO minus. Remove the H plus to make the conjugate base, okay? And here COO minus CH3, right? So the point is here there is a electron withdrawing group. So this electron withdrawing group will attract this negative charge, so via minus R effect. Okay, so this electron withdrawing group will attract and stabilize this negative charge. There is a no group here and there is electron donating group. So this electron donating group will push this negative charge away via plus R effect, plus M effect, whatever. Okay, so most stable conjugate base will be this. Okay, so this will be most acidic. So this is second is most acidic. Then, so obviously phenol is less acidic than this. Why? Because there is a COO minus group here. In all other groups there is CO minus. So obviously there is a resonance between two oxygen atoms, but here there is only one oxygen atom to share the negative charge. So obviously this conjugate base is the least stable conjugate base. Okay, so least acidic will be first. Okay, then among these two, so this will be more acidic because it does not have any electron donating group. So third, then fourth, then first. So this is the order, right? 2, 3, 1, 4. 2, 3, 1, 4. So you are saying 4 is more unstable than first, according to you. I don't think so. There is obviously CO minus group, na yaar. Obviously there is CO minus group. बताओ. बताओ. I think this will be the answer. Chalo, do next question. Increasing order of pKa of the following phenols. So following phenols are given. Increasing order of pKa you have to give. Find out the answer. है ना 2 3 4 1 ही तो किया मैंने. हाँ ठीक तो है. चलो. So basically these are phenols. 2,4 dinitrophenol. So first will be phenol and 2,4 dinitro. Second will be 4-nitrophenol. 4-nitrophenol. Third will be 2,4,5 trimethylphenol. 2,4,5 trimethylphenol. 2, 4, 2, 3, 4, 5. बहुत ही बढ़िया. Okay. Then fourth, phenol, normal phenol. Then 3-chlorophenol. 3-chlorophenol. Okay. Now you can find out. Now you can find out. So what is happening? So pKa again inversely proportional to acidity. Like pKb was inversely proportional to basicity, na? So pKa is inversely proportional to acidity. So if it is inversely proportional to acidity, so most acid will have least pKa. So most acidic group here will be this. See, because O minus here in the conjugate base will be stabilized by 2NO2 at ortho and para position. Then this, so acidity order, if I want to write acidity, first, second, then there are 3 electron donating groups there, and this is just phenol. So phenol will be more acidic than this, and then Cl. So Cl is applying minus I effect here. Minus I effect. So this will be more acidic than first, then least acidic will be third. So pKa value will be 1, 2, 5, 1, 1. अरे 5 के बाद क्या था? 3 था. एक सेकेंड. 5 के बाद 4 था यार. क्या कर रहा हूँ? 4 and 3. 4, 3. So is there any option? 1, 2, 5, 4, 3. Right? C option. अरे D नहीं है भाई. C option. It is C. Okay. So now halogen. We have to see halogen. Here Cl was present. So we have to see for this Cl. What this Cl does? This Cl, it dominantly applies minus I effect. See, minus I dominant. Okay. So what happens is this Cl has electrons as well. So it can donate electrons or Br whatever or iodine whatever. Okay. It can donate electrons as well as it can attract electrons via minus I. So minus I and plus M. But because carbon has 2p orbital and they have 3p, 4p, 5p orbital, so this overlap is not strong enough. So because of this weak overlap, minus I is dominant, plus M is weak. So generally they are electron withdrawing group, but in case of fluorine, like somewhere, like if fluorine comes, so this plus M is moderate. Why? Why plus M is moderate? Because fluorine also has 2p orbital, carbon also have 2p orbital. Okay, so this is effective overlap, but because fluorine has very high electronegativity, it is the highest electronegative element, so it is still minus I dominant. Okay, but the point is, even after minus I being dominant, the lone pairs are still donated in all the cases. And if the lone pairs are donated, Cl, if this is donating electrons, lone pairs. So negative charge will be there on ortho and para position. So this will be ortho and para directing. Even after being electron withdrawing group, it is ortho and para directing. So this is curious case of halogen. So don't be confused. Whenever halogen comes, like here, you will have to apply minus I. Minus I is more dominant. Okay? Okay? Chalo. Here you have to find the highest enol content. So I told you na tautomers. I told you tautomers. Like tautomer, for example, this is keto. So this is 1,3 shift. Right now I told you na in the beginning. So this is 1, 2, 3. So hydrogen from third position goes into first position and pi bond shifts from this position to this position. So this is tautomer. So this is keto form. This is enol form. Enol form. So generally keto form is more stable. That is what has been written. So percentage enol. So this reaction is at equilibrium. So at equilibrium, how much percentage of enol is present depends on the stability of enol and the stability of keto. So percentage enol at equilibrium depends on the stability of enol. More stable that enol, more stable the enol, more stable enol, higher enol percentage at equilibrium. That is the concept that you have to apply in this question. Do the question. Okay. So basically in this question you have to find the highest enol content. These compounds are given. Find the question. Find the answer. Minus I stronger. Right, Olivia. Right. So find the answer. So if you see this C, so what happens is double bond O, double bond O, double bond O. There is hydrogen. Do 1,3 shift. There is hydrogen. Do 1,3 shift. There is hydrogen. Do 1,3 shift. So this takes hydrogen from here. This takes hydrogen from here. This takes hydrogen from here. So this will become what? This will become benzene with 3 OH. Okay, so because of aromaticity, this enol is more stable than keto. This is aromatic. Okay, because of this aromatic, the maximum enol content will be in this molecule. Okay, is this fine? Is this fine? So we have completed GOC. So is GOC fine? So these are the concepts that you have to do in GOC: basicity, acidity, stability of intermediates, radical, carbocation, and all that stuff. And then your before GOC, stereochemistry, we did structural isomerism, IUPAC. So all those things, optical activity, right? As well as in GOC, acidity, basicity, enol, tautomerism, these things you have to revise. We have revised and we have practiced questions as well, right? So shall we move on to hydrocarbon? Shall we move on to hydrocarbons now? बताओ. बताओ. So are you guys understanding, or am I just saying things? Am I just blabbering? Are you guys understanding what I'm trying to say? What I'm trying to say, are you guys understanding? बताओ, फिर आगे चलते हैं. बताओ. Yes? चलो, let's move on to hydrocarbon. So hydrocarbon, obviously, in hydrocarbon we will see what? Alkanes and alkenes and alkynes, right? Alkanes, alkenes, alkynes. So these three things we will see in hydrocarbon. Okay? Chalo. So first of all, we will see preparation of alkanes. So these are simple. Basically, I will tell you three different types of reaction here: Wurtz reaction, Fittig reaction, and Wurtz-Fittig reaction. What happens is, from your alkyl halide, this is alkyl halide. Okay. There is a metal which will react with alkyl halide. It gives electrons because metals have the tendency to give electrons. So it will give electron to this halogen, halide. Okay, if this gives electron to this halogen, X minus leaves. So X minus will leave. So X minus will leave and form bond with M plus. Okay, so Mx will leave and then there is a R radical there. So two R radicals will be there, R radical, R radical. They will form bond with each other to form RR. So basically this is how you prepare, alkane from your alkyl halide. Okay, so first reaction is Wood's reaction. In this reaction, this alkyl halide, this alkyl group is aliphatic. Okay, that is the only difference. So there is Na, dry ether. So this Na will remove this Br and CH3 will make bond with each other. That's it. Okay, and there will be NaBr obviously, 2 NaBr. Okay, this is a side product you can write, right? Then there is Fittig reaction. In Fittig reaction, this alkyl halide, this alkyl is aromatic. Simple, that's it. So if this is aromatic, so this Cl will be removed, NaCl will be removed, and this aromatic group will couple with each other to form alkane. Okay, then Wood's Fittig is a mixture of Wood's and Fittig. So one alkyl will be aliphatic, one alkyl will be aromatic. So this Na, 2 Na will come and remove this 2 Cl, and this CH3 and that aromatic compound, benzene, will form a bond together, and this is how you form 3 different types of alkanes. ठीक है, बताओ. Then 2 more reactions, Franklin reaction and Ullmann reaction. So Franklin reaction is basically wait a second, ये क्या हुआ? Wait a second guys, just give me 1 second. This okay, ठीक है, चलो. So what is happening? This zinc has a tendency to give 2 electrons, so it inserts between this alkyl halide, this R and Cl, this carbon and Cl bond will be there, so it will break. Okay, this will give 1 electron here, 1 electron here, so this will become C minus, Cl minus, and Zn2 plus will insert in between of this and make a bond. Okay, you can understand this via any pathway, via radical pathway, via positive negative pathway, whatever, right? So this is what happens. So Zn is inserted between Cl and carbon. Okay, then so because Zn is with carbon, so electronegativity is more of carbon. So if electronegativity is more of carbon, so carbon will have delta negative, or you can also say that it has negative charge, but it has delta negative, not complete negative charge, it has delta negative. So this behaves as a nucleophile, and it attacks on the other molecule, same molecule, and the Cl will release, and then ZnCl2 minus ZnCl2 will release, and this and this will make bond together, right? So this is Franklin reaction. So you don't have to remember the mechanism. If Zn and heat are given and alkyl halide is given, remove Cl, make bond of this alkyl part, that's it. So remove Cl, remove this and join these two, that's it. Okay, that's what you have to do. Okay, I'll write electronegativity of zinc is less than carbon, and this will react as nucleophile. Okay, now Ullmann reaction. Ullmann reaction is also same type of reaction, but instead of zinc there will be copper. So copper and heat, same radical pathway as Wood's reaction, as all other reactions. So basically this I will leave and 2 bonds will be formed between these 2 molecules. Simple. Okay, बस reagents अलग हैं, right? Okay, chalo. So basically here again, see Zn HCl now. See, here Zn and heat was there. Here now there is Zn and HCl. So same thing will happen. Same thing will happen. Zn will insert between this carbon and chlorine, and if this will insert between carbon and chlorine, this carbon will now interact with this HCl. Okay, so this is now acting as a base. Why base? Because this will have a delta negative charge. So because this is a negative charge, it will attack at H positive and take H plus from here, and ZnCl2 will remove. Okay. Okay. Now again ZnCu coupled together and ethanol is there. So CH3Br. So again CH3ZnBr, same mechanism, but then there will be a acid base reaction. Why? Because ETOH is there. There is also acid base reaction here, no? See, this is base, this is acid. So similarly, this is now base, it will interact with this hydrogen, it will take this, so CH4 will leave. That is what happens. Okay, so very simple thing. Okay, so again here also we are making a alkane, here also we are making a alkane, but we are not coupling things. Why we are not coupling this? Because this does not interact with this again. This is not attacking on this again. This is attacking on acid. So there will be no coupling. Similarly, there will be no coupling here as well. Okay, so apply logic. Okay, don't try to cram things. Okay, so now we need to study reduction. So reduction means we are forming alkane from carbonyls by reducing carbonyls. Okay, so there are two types of methods. Are you with me? Methane, yeah. So there will be two types of methods: Clemmensen reduction and Wolff-Kishner reduction. Clemmensen reduction is in acidic medium. It is in acidic medium. Okay, and Wolff-Kishner is in basic medium. Okay, so the reagent is ZnHg. So zinc amalgam is present here in acidic medium. So what happens is it removes this carbonyl, ketone and aldehyde. So ketone and aldehyde, it converts into simple alkane. Okay, see. But point is, because there is a H plus here, acidic group is there, HCl is there, na? Acidic medium is there. So if my molecule, aldehyde and ketone, if it contains acid sensitive group, any group that can react with that acid, HCl, so that will react. For example, this is a ketone. Here it is alpha beta unsaturated ketone. So at alpha beta there is alkene. Okay, so this alkene will react with HCl. So HCl will addition of HCl to alkene. Okay, so what will happen? This will attack on H positive, right? And negative charge will be formed. Okay, so positive charge will be formed. What is happening? See. So this will attack on H plus. So positive charge will form where? Here. Why here? If here it will be formed, it will be closer to C double bond O. So C double bond O is electron withdrawing group. So that positive charge will not be favorable there. So it will be formed here. So here then it will Cl will attack. So HCl will be added to this alkene, and obviously this whole group will be reduced. So this product we don't need. We need this product. Simple. We just want to remove this double bond O. So what will we do? We will use a reagent which will use basic medium. So that is Wolff-Kishner. So NH2 hydrazine and base. So we take that in basic medium. So that is also does the same thing. This C double bond O of aldehyde and ketone, it removes. Okay, so when it removes, so if you react this acid sensitive group with NH2 and base, so it won't affect the alkene. It will just reduce this double bond O. It won't affect the alkene. See, okay. So again there is another acid sensitive group, alcohol. So acid sensitive groups are alkenes and alcohols here. So what will alcohol do? OH will attack at HCl. So it will take H plus, then Cl will remove this OH2. So when OH takes H plus, it gets activated, it becomes a good leaving group, OH2 positive. So Cl will then remove this by nucleophilic substitution reaction. So Cl will come there, and obviously this group will be reduced, but we don't want that, we want this. We want this compound. So obviously we will use Wolff-Kishner reagent here as well. Okay, then there will be a base sensitive group. Obviously this is a basic medium. So if this compound contains a group which will interact with base, then what will happen? So see, here OH minus is there, base, hydrazine, and there is a Cl along with double bond O. So this will remove this Cl via SN mechanism. So this is base sensitive group, but we don't want that. So we'll use, what we'll use? Clemmensen reduction in this, because Cl will not interact with HCl. So it will just reduce this C double bond O. That's what we want to do. So we are just making alkanes. We don't have to do anything else to any other entity in the molecule. Okay. 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 And again, addition reaction of alkenes. So again we are forming alkanes. So we are adding things into alkenes. So like this is alkene. So we are adding AB. So what is happening? It will attack on A. So let's suppose among A, B, A contains delta positive and B contains delta negative. Because B is more electronegative, so it will attract electron pairs towards itself. So A will have delta positive. So A is electrophilic. And if A is electrophilic, my alkene is nucleophilic. It wants to donate electrons, so it will attack on A. Okay. If it will attack on A, so what will happen? CH2. This A bond will be formed, but here positive charge will be there. So here B minus will be waiting for attack. So B minus will attack here. So A and B will be formed there. Okay. So this can be syn addition, this can be anti addition, whatever. There can be different mechanisms, we'll see that. But this can be syn addition, means A and B are added on the same side. This can be anti addition, A and B are added on the opposite side. Okay. So how will we know if it is syn or anti? So this is the chart. This is the chart. Okay. So you won't be confused. See, you won't be confused. We'll go logically. We will go logically. See, syn addition has these reagents. Syn addition means when A and B are added synergistically, like on the same phase to the alkene, these reagents will be there. Okay. So first reagent is H2PD carbon, hydrogen palladium carbon. So it attaches hydrogen on the same phase. See. So C double bond C will break and one hydrogen will be there on the syn phase, like same phase. Then BH3THF H2O2 OH minus. So this is very famous hydroboration oxidation reaction. So in hydroboration oxidation reaction, there is syn addition of H and OH, but OH is added to less substituted carbon. See, I am not going to explain the mechanism here, but I will just give a hint. For example, this is an alkene. Let's suppose this is an alkene, CH3, CH double bond CH2. Okay, so BH3 adds like this, BHH2. Okay, so boron electronegativity is, hydrogen has more electronegativity than boron. So hydrogen is delta negative, boron is delta positive. So this alkenes attack on this. So obviously there will be a positive charge, so hydrogen will attack on this. Okay, so positive charge will be on more substituted carbon, therefore hydrogen attacks on the more substituted carbon, and this after this boron will be there is a single bond, hydrogen will be there, so this boron will be replaced by OH. So therefore OH comes at the less substituted carbon. Okay, some people call it anti-Markovnikov rule or something like that, but point is I don't remember the rules or something like that. I apply the logic. Okay, so that is the thing. And cold diluted KMNO4. See, KMNO4 you will see in various forms, but cold diluted KMNO4 is applied for dihydroxylation. So you are adding two OH groups to alkene. Dihydroxylation. So alkene will be removed and OH and OH will be added syn to each other. Okay. So dihydroxylation. Then osmium tetroxide. This is also doing dihydroxylation. Same. Dihydroxylation, syn dihydroxylation. cold dilute KMnO4 and osmium tetroxide are doing the same thing, dihydroxylation. Okay, then anti-addition. So anti-addition is addition of Br2 with CCl4. CCl4 is a polar, non-polar solvent. Sorry, non-polar solvent, right? CCl4, non-polar solvent. So what happens is there is addition of bromine first to the alkene, and brominium ion is formed. How? See, so CH2, I will CH2, so plus Br2. So this attacks on Br, and this bromine minus is removed. So CH2, Br, and there is a positive charge here. If there is a positive charge here, this lone pair will donate here and form a 3-membered ring. CH2, Br plus. So brominium ion is there. So if this brominium ion will be formed, then Br minus, the Br minus that left from here, then Br minus will come from any particular side. So basically it comes from the more substituted carbon. More substituted carbon. More substituted carbon. So there is obviously anti-addition, because it comes from below the plane. Like brominium ion is above the plane, this comes from below the plane. Anti-addition, right? Wait. CH2, Br. That is what happens. Dekho. Okay? Okay? That is what happens. Then Br2 and H2O. If H2O is present, then solvent is present for attack. So instead of Br minus attacking, solvent H2O will attack. Okay? Then there will be OH instead of Br. So this Br that is attacking, instead of Br, H2O will attack, then H plus will remove, then OH will be there instead of that Br. Okay? So that is solvent effect. Okay? Then Br2 plus H2O again. So this is the mechanism that is happening. So Br2 plus H2O means what is happening here? So HBr and HOBr is forming. Okay, so this HOBr, OH minus, this OH minus attacks there. Okay, that happens. Okay, so this is nothing, this is same thing only. Then Hg2 plus salt plus H2O plus NaBH4, this is oxymercuration, demercuration, right? First, you are making mercurium, ion, like brominium ion, you are making mercurium ion here. CH2, Hg positive. Okay, so Hg2 plus salt will be there, HgOAC2 or something like that, something. Okay, so this mercurium ion will be formed, then H2O will attack, then after that NaBH will oxidize this mercury to hydrogen. Okay, so H and OH will be there. Okay, then last but not the least, per acid. So per acid is this RC double bond OOH. So this oxygen, which is a per acid, like peroxide bond. So this oxygen just inserts itself to the alkene. How? Like this. CH and epoxide. So epoxide is formed, then H2O will attack here on the more substituted carbon. So both OHO and OH will be there. So basically epoxide is formed in this. So mechanism I am not going to write whole. So these are the anti-addition, this is the syn addition. So these are the reagents for anti and syn addition. Okay, so here same thing is written. See, HgOAC2, H2O, NaBH4. So OH added to carbon where carbon plus will be more stable. Achha. Here I told you OH will be added to carbon where carbon plus is less stable, basically least substituted carbon, right, in hydroboration oxidation. So but in oxymercuration, demercuration, OH will be added to that carbon which is more substituted. That carbon which is more substituted, at which carbon positive will be more stable. So more substituted carbon, and this will be added to less substituted carbon. Do this question. करो भाई, क्वेश्चन करो. करो. Do the question. So basically, this is the alkene. Here HgOAC2 and H2O is added, oxymercuration is done. Here BH3 THF is added. So on this alkene, this is the alkene. Wait. This is the alkene. So obviously this is more substituted carbon, this is less substituted carbon. So do what you are going to do. Do what you are going to do. In both the cases, HNOH will be added. Both the cases. See, HNOH, HNOH. One will be cis, one will be trans, and obviously, but point is syn and trans is not asked here. Okay. So in B, what will happen? OH will be added to this carbon. Okay. So this will be OH, and here will be, this carbon will be H. Okay. More substituted carbon. At A, OH will be added to this carbon, OH, H. Okay. So you can see. So B is this. See, here a B to ठीक है, and A is this. So see, A answer, right? A is the answer, right? Right? Chalo. Major product of the following addition reaction. Karo bhai. Cl2 is being added. Cl2 is being added. This is Cl2 with H2O. Okay. H3O plus या फिर H2O लो. ठीक है. So this is the reagent and that is your alkyne. That is your alkyne. CH3CH, नहीं alkene, double bond CH2. Okay. That is your alkene. If it is not visible, and that is Cl2 and H2. Add this. I told you, no? This is water solvent. Polar protic solvent is present. So what will add, what will not add, I just told you. Do this. Batao. I am giving you time. बताओ भाई. बताओ. देखो. So alkene will attack on this chlorine. So obviously positive charge will be formed at your more substituted carbon. CH2Cl positive. So if positive charge is formed, so obviously brominium or chlorinium ion will be formed. Here, see, chlorine plus, then H2O will come and it will attack at more substituted carbon. So obviously the answer will be C. What is happening here? There is one more thing. CH3, C, OH, H, CH2, Cl. Now most of you will leave this answer here, but the answer is not this. If you have understood SNNGP, neighboring group participation, what happens? There is a leaving group, and anti to that there is a group that can donate its electron to sigma star of leaving group. There is a leaving group. This is sigma star CCl leaving group, and there is a group on the beta position. So this is alpha, this is beta. There is a group on the beta position which can donate its electron in sigma star CCl and remove this. So CH3CH, CH2, epoxide. Okay? Okay? Is this fine? क्या बोला था? ऑप्शन सी. अरे वही देखा, ऑप्शन सी. जिसने भी ऑप्शन सी किया है, you didn't do NGP. NGP you have to take care of. SNNGP. Okay, neighboring group participation. Okay. Chalo. So now let's come to ozonolysis. Okay. So ozonolysis is of two types. Basically ozonolysis means oxidation. So you are oxidizing your alkene. In ozonolysis, you are oxidizing alkene and alkyne. Okay, so one is reductive ozonolysis, one is oxidative ozonolysis. In both the ozonolysis, obviously ozone will be there, O3, O3, both will be there, no? Both will be there. So if O3 is there, in reductive ozonolysis, you will find something like Zn, H2O, DMS. So Zn means metal. You will find metal. Metal. Why metal? Metal gives electrons. So it will give electron to someone. So someone will take electron. So that species will reduce. So this is reductive ozonolysis. Okay. And also why is DMS? So this DMS takes oxygen to form DMSO. So taking of oxygen is basically reducing someone else because someone is losing oxygen, right? So basically this is reductive ozonolysis. If you see ZnH2O, if you see DMS, this means reductive ozonolysis. What you have to do, it is very simple. Break the double bond, pi bond, and add one oxygen here, one oxygen here. See, so CH3COH, CH3COH. So 2 into CH3COH. Now this won't oxidize further. Why? Because you are adding reducing agents. So if you are adding reducing agents, this is giving oxygen, nascent oxygen. So this will take this nascent oxygen and will not let that oxidize further. Okay, so this is the magic of reductive ozonolysis. If you have to stop further oxidation, you will do reductive ozonolysis. Again, in triple bond, you will break the pi bond. You will break one pi bond. So basically you will add oxygen and oxygen. So oxygen, oxygen, and one single bond will be left. See, one single bond will be left, oxygen and oxygen will be there. But again, this will not be further oxidized because this is reductive oxidation, reductive ozonolysis. If this would have been oxidative ozonolysis, then this would have gone into CH3COOH, both. But this will not oxidize further because this is reductive ozonolysis. Now let's move to oxidative ozonolysis. In oxidative ozonolysis, you will have per acid, H2O2. So again, this double bond will be broken, this double bond will be broken, so oxygen, oxygen will be there, but this oxygen and oxygen will convert into, this aldehyde will convert into OH. Okay, this aldehyde will convert into OH. But the point is, obviously two equivalents will be required here. Two equivalents will be required here. Again, right? So this will be converted into OH. Why? Because there is hydrogen here. Here, this triple bond will be broken. Again, there will be this double bond O, two ketones are present. So ketones are not further oxidized. I just said that maybe this will be converted into acid. No, ketones are not converted into acid. These are ketones. I am sorry for my mistake. By mistakenly, I said that ketones are not further oxidized. Okay, ketones are not further oxidized. If this would have been like this and this. So I meant for this. So if this is the thing, then it will oxidize. Okay, but ketones are not further oxidized. So ketones will remain as ketone. Chahe oxidative ozonolysis ho, chahe reductive ozonolysis ho. And one very important thing. See, KMnO4 plus H plus or KMnO4 base and heat. See, these two reagents. What? KMnO4 H plus, not cold diluted KMnO4. What does cold diluted KMnO4 does? Dihydroxylation, syn dihydroxylation. Just now we saw that, right? Just now we saw that, na yaar, either. Ye dekho. I am not talking about the cold diluted KMnO4. I am talking about concentrated KMnO4 in acidic medium and KMnO4 in basic medium plus heat. If that is the case, you will always get the product as of oxidative ozonolysis. If you add KMnO4 to this, let's suppose you add KMnO4 plus base plus heat to this, you will get the same product. Okay, so this is very easy. Or KMnO4 in acidic medium, you will get the same product. Okay, do this question. Do this question. So basically, alkene is given. Here O3H2O2 is there. Here KMnO4 OH minus heat is there. Here O3 DMS is there. Here cold dilute KMnO4, which is Bayer's reagent. This is Bayer's reagent. Cold dilute KMnO4 is there. What will be the answer? What will be the answer? See, first of all, this is what? You have to identify the reagents, na? You have to identify the reagents, first of all. So obviously, this is what? This is oxidative ozonolysis. So what you will do? What you will do? Just break this. Just break this and add oxygen, oxygen. So what will happen? Oxygen, hydrogen. Oxygen, hydrogen, right? So 1, 2, 3, 4, 5, 6. 6 carbons are there. So we have broken this first, but this is oxidative. So after oxidative, this aldehyde will be converted into COOH. COOH. Obviously, aldehyde will be converted into acid. We saw that, right? But in this is reductive ozonolysis. So this product will be formed here. CHO. CHO. So for reductive ozonolysis, further oxidation will not be happening, right? Now, KMnO4, cold diluted KMnO4. So this is Bayer's reagent. This will do syn dihydroxylation. So your answer will be, wait. Okay. So it is syn. So basically, stereochemistry will be just like this, syn dihydroxylation, right? But here, this is KMnO4 OH minus and heat. So this will give same product as this, oxidative ozonolysis. So this will be this only. Batao. Fine? 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 Batao, is this fine? So these are different products that will be formed. Chalo. So 2-hexane O3H2O product. So two products are formed in the above reaction. That will be, batao bhai. Two products that will be formed in the above reaction. So this is 2-hexane. So I will write it here. You can form the product. 2-hexene. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 1, 2. 2-hexene, right? And O3 and H2O is given. Okay? Batao. What will be the answer? बताओ. What will be the answer? See, obviously you have to do ozonolysis. So break this bond. So oxygen here, oxygen here. So if this is happening, 1, 2, 3, 4. Oxygen, hydrogen, and 1, 2. Okay. Oxygen, hydrogen. Right? This is happening, but this is not reductive ozonolysis. Is DMS present here? Is Zn present here? Nothing is present, na? So this will be oxidative only. Oxidative ozonolysis. Okay. So this will convert into what? 1, 2, 3. COOH, right? 1, 2, 3, 4. Butanoic acid, and this OH. So this is ethanoic acid, acetic acid. So butanoic acid and acetic acid, right? A is the answer. Okay. अरे D नहीं है भाई, D नहीं है, A है. D कहाँ से आ गया? Butanoic acid and acetaldehyde. अरे, if you are oxidizing one, so why are you not oxidizing the other? Oxidize the other as well. Why are you not oxidizing acetaldehyde to acetic acid if you are oxidizing the butanol to butanoic acid? Okay. Okay. Sir, is H2O why acid? अरे जब तक till they don't give you DMS or ZnH2O, till they don't give you this means reductive ozonolysis. If they are not giving you this, everything else is oxidative ozonolysis. Why? Because if they are not even giving H2O2, O3 is still a very strong oxidizing agent. It will give oxygen itself, nascent oxygen. So you need DMS to trap this oxygen. If this is not provided, this will further oxidize. If H2O2 is not present, that even in that case also. Okay, so this is everything else is oxidative ozonolysis. Okay, chalo. So an unsaturated hydrocarbon absorbs 2 hydrogen molecules on catalytic hydrogenation and also gives the following reaction. So catalytic hydrogenation reaction, I told you, no? This is catalytic hydrogenation. See, this is catalytic hydrogenation. H2 is being added to CH2CH2. So here CH2CH2 is reacting with H2. So if there is 1 mole CH2CH2, there is 1 mole pi bond. So 1 mole H2 will be required. So H2 required will be equal to number of pi bonds broken. So if you are breaking 1 pi bond, so obviously you require 2 hydrogen atoms. So 1 H2 molecule will be required. If you are breaking 2 pi bonds, you need 2 H2 molecules, so 2 moles H2 molecules. So that is what is happening. So basically, that is what this question is saying. So 2 hydrogen molecules are absorbed. So if 2 hydrogen molecules are absorbed, an unsaturated hydrocarbon absorbs 2 hydrogen molecules. So this 2 hydrogen molecules means here 2 pi bonds are there. So if 2 pi bonds are there and they are giving this reaction, so basically ozonolysis is, and after ozonolysis this is AgNH3 2, ammonical silver solution. This is Tollens reagent. See, Tollens reagent. So ammonical silver nitrate solution. What happens? It oxidizes all the aldehydes to ketones. Okay, it oxidizes that. But Fehling solution is copper sulfate solution with sodium potassium tartrate. It does not oxidize what? What? Only oxidizes aliphatic acid. See, so basically Fehling solution only oxidizes aliphatic aldehyde. Okay, not aromatic aldehyde, but this Tollens reagent, aliphatic aldehyde means this aldehyde, this, and aromatic is this, obviously. So Tollens reagent will oxidize these. It will oxidize these. Okay, to acid, not ketones. This is written wrong. Acids. Okay, it will oxidize to acids. Okay, but this Fehling solution, which is copper sulfate solution, it will just oxidize your aliphatic acid, aldehyde, not the aromatic aldehyde, and reddish brown copper color will be there. Here silver Miller test is there, so silver color will be there. So with Fehling solution, reddish brown copper color will be converted into deep blue color. In Tollens reagent, the test tube will be turned into silver Miller, silver color, right? So basically, what will happen? We have to find the unsaturated compound. So this is 3-oxohexane dioic acid. So 1, 2, 3, 4, 5, 6. COOH. So 1, 2, 3, 4, 5, 6. Hexane dioic acid and 3-oxo. 1, 2, 3. 3-oxo. So this is the final product B. If this is the final product B and this has, wait a second. हाँ ठीक है. And this has been formed from this, right? So, अरे वो है screenshot का है. Is it very much blur, guys? Is the screen very much blur? Are you guys facing any problem with this? Please tell me. Are you guys facing any problem with this? Are you able to see properly? Please tell me guys if you are able to see properly or is there any problem. In slides where there is some problem, I am already writing itself. But in this slide, I think that there is no problem, like in slides like this. So are you guys facing any problems in these slides as well? Okay, yes. क्या is everything clear? Yes, क्या बोल रहे हो? No problem ना, ठीक है, चलो, ठीक है. So if you will find any problem, just tell me in the comments, okay? Right? So what I am trying to say is this product is formed from your tolerance reagent. So tolerance reagent, what it does, it oxidizes aldehydes into acids, right? So obviously this A will be CHO, CHO and double bond O. So ketones won't be oxidized, right? So A is this. So after ozonolysis you have to form this. So if you form this, wait, 3 na, on 3, okay. So if you break this, okay, and you break this, okay. So if you are breaking this, 1, 2, 1, 2, 3, okay. So what will be formed? What will be formed? 1, 2, 3. So CHO, this is reductive ozonolysis, no? CHO, double bond O and HCOH. So this will be the product, right? Right? So A is your answer. No? Is it fine? Is it fine? Was this a good question? This is a good question, no? See? So basically B is 3-oxohexane dioic acid. I will explain again. This is hexane dioic acid. So this is the final product. So obviously tolerance reagent, after reacting with tolerance reagent, you are finding this. So tolerance reagent does what? It oxidizes aldehydes into acid. So wherever there is acid, there must be an aldehyde in A. So see, and obviously ketone will be remaining ketone because tolerance and valence reagent do not oxidize ketone. So basically this ketone will remain as that. So 3-oxo will remain as that. So if you are doing this ozonolysis for this compound, so this bond will be broken, this bond will be broken, here double bond O will be there, here CHO will be there because this is reductive ozonolysis, Zn is there, right? 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 Chalo. So choose the correct set of reagents for the following. So from trans alkene you have to form cis alkene and these are the reagents. Okay. So find this. Find this. So I have taken good questions for you which will improve you conceptually. Okay. Find this one. Correct set of reagents. So basically trans alkene to cis alkene. So first of all you have to convert this into bromine. Basically everything is bromine, na? Br2. So basically Br2 will be added. So add Br2. So pH, let's suppose this is C, double bond C, H, and this is CH3. Okay, and this is pH. This is H. Okay, you have to add Br2 alcoholic KOH in all of this. Instead of alcoholic KOH, here there is aqueous KOH, but that is okay, fine. So basically Br2 you have to add. Br2. So this alkene will take Br. Okay, so brominium ion will be formed. CH, PH, CH, no, CH3, H. So brominium ion, Br plus will be there. So after Br plus, another Br2 will be there, right? Or what? Alcoholic QH will be there or Br2 will be there. See, this alcoholic QH and NaOH2 is different reagent. This is different reagent. So this is just Br2. See, after Br2 they are adding a comma. So this is first reagent that they are adding. So obviously second Br will be added here, Br minus. So where will it be added? On this, more substituted, right? So let's not right now think about the stereochemistry more. Br HCH3. So this is my molecule after first reagent. Then you are adding alcoholic KOH and NaNH2. Alcoholic KOH and NaNH2. So what does this do? What does this do? What is NaNH2? NaNH2, what is this? Tell me. Tell me what is this? So this is a base, na? NaNH2. NH2 minus is a very strong base. So NH2 minus is a very strong base. So it will remove bromine. Okay, it will remove bromine. No? No? First alcoholic KOH is there, then NaNH2 is there. So first, let's suppose alcoholic KOH, OH minus is doing what? Let's suppose this hydrogen is taken. So this bromine will be removed. So C, H, PH, double bond, C, Br, CH3. Okay, then after that, what will happen? NaNH2. NaNH2, NH2 minus is a very strong base. It will take this hydrogen and will remove this bromine as well. So this will form PH, C, triple bond C, CH3. So this is alkyne formed. So after alkyne you are adding what? Na liquid NH3. Birch reduction. So Birch reduction does your transalkene, but you have to form cis alkene, so you will add H2 Lindlar's catalyst. H2 Lindlar catalyst. Lindlar's catalyst is PDBaSO4 quinoline, right? So this will form your cis alkene. PH, CH, CH3, H. Okay, so this will be your answer. So the point is, here you can see the concept. So alkyne, if you are adding H2, Lindlar's catalyst is H2PD CaCO3, PBO quinoline, anything like this is written with H2PD. That is Lindlar's catalyst. It will form cis alkene. If you are adding Birch reduction, so it will form transalkene. Okay, so if I would have added Birch NH3, Na liquid NH3 there, so this will be formed into transalkene. Okay, then terminal alkynes. If terminal alkynes are present, this is just normal alkyne. If terminal alkyne is present like this is terminal alkyne group is, or molecule is ending with this alkyne. So this Birch reduction or this Birch reagent will attack with this hydrogen because this is acidic hydrogen. Okay, so this will form this RC triple bond C minus Na plus, and then it will react further as nucleophile or base or whatever, right? So this will not give here alkene, this will give acid base reaction here. Okay, so this is the difference. Is it fine? Is it fine? ठीक है बताओ. Okay, so then let's see the preparation of benzene. Okay, acid base reaction happens. So benzene is formed by 3 methods. See, first method is make your ethyne. Basically this is ethyne, right? Ethyne reacts with red hot iron tube. So this will convert into benzene. So basically you have to take 3 ethyne. So they will convert into benzene. Why 3 ethyne? Because 3 to the 6. So 2 carbons are present and benzene 6 carbons are present. So 3 to the 6. So basically they will form into benzene. If you are taking this, like instead of ethyne you are taking propyne. So then 1 CH3 will be added here, 1 CH3 will be added here, 1 CH3. It's just like this will attack on another molecule of this, right? Another molecule, not this same molecule, another molecule. So obviously there will be a carbon and this carbon will attack on another molecule, this carbon. So this will have CH3. Then this molecule's carbon will attack on another molecule's carbon, which will again have CH3. So this is mesitile. Okay, this group is mesitile group. Okay, okay, and then phenol. From phenol, what will you do to make benzene? So you add zinc. So this zinc will absorb this oxygen, and if this will absorb this oxygen, it will just form benzene. Okay, okay. हेलो कौन बोल रहा है? हेलो गुरुजी कौन बोल रहा है भाई? अच्छा अनूप, हेलो भाई, हेलो. ठीक है. नाउ आइसोमराइजेशन ऑफ एल्केन एंड एरोमेटाइजेशन ऑफ एल्केन. एरोमेटाइजेशन ऑफ एल्केन अगेन ऐसी बात है ना, देखो हियर वी aromatize the alkenes and alkynes. See, we are aromatizing the alkynes and we are making the benzene from phenol. So here we are doing the same with alkanes. So if we are taking CH3, CH2 to CH3, okay, so we are reacting this with transition metal oxides. Transition metals, molybdenum, cobalt, vanadium, any oxide, like for example V2O5 and heat. So if you are adding V2O5 and you are heating this, this will convert into benzene. Okay, okay, right? Then there is isomerization. So isomerization happens because of anhydrous AlCl3 and HCl. Okay, so normal butane, right? So it will convert into isopropane. Okay, this might be CH3 CH2 CH2 CH3 1 2 3 4. This might be 4. This might be 4. Okay, this is not the right thing. This might be 4. Okay, just check this once if I am saying right. Obviously this will convert into benzene, na? Right? So it needs 6 carbons, right? So am I right or am I wrong? Tell me. This is fine. So basically normal butane you have to isomerize into isopropane. So basically anhydrous AlCl3 and HCl and heat. Simple. बताओ बताओ. ठीक है, चलो चलो. So free radical substitution, this is very important, very important. Okay, so in free radical substitution what is happening? So generally in your alkenes, if you are adding bromine or chlorine or you are adding halides वगैरह, right, fine, but the point is there are some reagents which will give you radicals, like for example NBS, N-bromosuccinimide. This is the structure. Okay, so this will give you bromine radical, Br radical. So this Br radical will form the most stable radical. It will react with this Br radical will react with this hydrogen. Why this hydrogen? Why not this hydrogen? Why? Because if radical is formed here, it is not stable. This is sp2 carbon, right? If it is forming here, this is also not stable. This is not into conjugation. But if this radical forms here, this will be in conjugation. Okay, so this is a most stable radical. So it will form the most stable radical like this. So stable radical, resonance stabilized, right? So if this is forming stable radical, then another Br radical will interact with this, another Br radical will come and will interact with this and form this. Okay, so instead of adding bromine into alkene, when you are adding NBS, that bromine will be added to this allyl carbon. This is allyl carbon, na? This is carbon adjacent to double bond is allyl carbon, right? So instead of adding to alkene, it will be added to allyl carbon. Now it can also be added to benzylic carbon, this carbon, see. So again Br2, if instead of NBS H nu or heat is present, okay, then Br2 again dissociates into Br radical, and this Br radical will again interact with this hydrogen to form carbon radical. Why? Because this radical is again resonance stabilized. Okay, so if this is happening, so this radical will be formed, this radical will again interact with another Br to form Br. So this is benzylic carbon. So this is allylic, this is benzylic. Okay, बताओ, fine, fine, okay, done. So hydrocarbon is done. Want some rest? Want some rest? So question practice we have done, right? Question practice we have done, theory we have done for hydrocarbons, Lindlar's catalyst, your Birch reduction, your this is very important. Not this is also okay, fine. This ozonolysis is very important in this. right? Reductive and oxidative ozonolysis is very important. And then this oxymercuration, demercuration, and this BH3 like hydroboration, oxidation, this whole chart, syn addition and de-addition, very important. Okay, and then addition of alkenes, simple. Then again, Clemenson and Wolff-Kishner, very important. So these are the very important things. Again, these like Woods, Fittig and all these are fine, but most important things are these, right? So again, we have done this hydrocarbon chapter, right? Now we'll start alcohol and phenol after 10 minutes. Okay, what is the time? Go and have your lunch. Almost 4, so we'll start with at 4:05. Okay, chalo. अरे वो है एक्सटेंशन. आ जाओ एम आई ऑडिबल आ जाओ एक बार इसकी मैं चार्जिंग देख लूँ भाई एक बार ठीक है कम ऑन लेट्स कंटिन्यू लेट्स कंटिन्यू लेट मी जस्ट सी हाँ ये था ना इससे पहले ओके आ जाओ गाइस आ जाओ हाँ so excited still excited still do you guys have any energy or are you guys like dead आ जाओ come on हाँ यार had my lunch not lunch I had fruits I gave 10 minutes break to you guys so that you can have lunch right आ जाओ so am I audible let's move let's start again so basically we have to start our what alcohol phenol and ether right yeah full of energy right so basically before starting with the alcohol phenol ether there was one concept that was left this right so basically we are converting alcohol into alkene only so basically I put it into you can put that into alcohol also you put this into alcohol phenol ether also you can put this into alkene also so whatever so we can do this so this is basically sorry a 2 degree alcohol okay this is a 2 degree alcohol so basically in this 2 degree alcohol there is this is alpha carbon this is beta carbon so on this beta carbon this is beta hydrogen so these beta hydrogens can be removed and beta elimination can happen of H2O can happen this OH will be removed and one of this hydrogen will be removed now which hydrogen will be removed depends on the reagent okay so if you take p block oxides means aluminium oxide phosphorus oxide Al2O3 P2O5 you will form ZSF product ZSF alkene means more stable alkene so basically this hydrogen will be removed and अभी क्या नहीं अभी खाया ठीक है ठीक है so basically this is more stable alkene ZSF alkene and then Hoffman alkene will be formed Hoffman is less stable alkene so this will be formed if you will take D block oxides thorium oxide tungsten oxide something like that so then that hydrogen will be removed and alkene will be formed so this is less stable alkene this is obviously more stable alkene because this is more substituted right more substituted right fine चलें चलो alcohol phenol and ether चलो start करते हैं so acid hydrolysis के साथ we will start so acid hydrolysis means hydrolysis is reaction with water hydrolysis means reaction with water hydro right and acidic means there will be acidic medium H plus in this okay so what will happen H3O plus देखो H3O plus means H2O and H plus so water is there for reaction and H plus is acidic medium right so that is H3O plus right let me take another marker I will take orange okay so what will happen so there is an ester so hydrolysis of ester will do what you will break this bond put OH here and H here okay put OH with carbonyl group okay and H with your alkoxy group so alcohol will be formed and your acid will be formed simple then if there is ethers okay this is ethers diethers so you are doing hydrolysis again so what can you do you can again break this bond and OH will be there and OH will be there what will happen? What will be the mechanism? For example, this is H plus. So this ether oxygen will take the H plus. So if this ether oxygen will take the H plus, it will become OH positive. It will be activated. Now H2O can react here as well as here. Wherever it will be reacted, this will be forming OH, and CH3OH will be removed. Minus 2CH3OH. CH3OH will be removed. So this OH, two OH groups on single carbon atom are unstable. So minus H2O. H2O will be removed and it will be converted into ketone. Okay? 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 Is this fine? Is this fine? Chalo. Ab now basic hydrolysis. Again, hydrolysis is reaction with water, but reaction with water can also happen in your basic medium. So basic medium means OH minus is present. Base OH minus or whatever is present. So basically see OH minus and H2O is present. So what does OH minus does? So this is acyl chloride. This is acyl chloride. So OH minus will attack on this carbonyl. This will open up, then this will come back and this will remove Cl. So addition elimination reaction is happening. So this will convert into OH, COOH, right? So this will be converted into acid. Okay. Then this is your anhydride, right? This is your anhydride, na? CH3COO, CH3, COCH3, acidic anhydride. So anhydride. So again same thing happens. So OH minus will attack here. So here or here, wherever, it will attack here and this will leave. This will leave taking H plus and this will be H plus. So this basically 2 into CH3COOH. Two acids will be formed. Simple. Then this is amide. So amide is kind of a crazy thing. So why? Because this again OH minus will attack here and NH2 minus will leave. So while leaving NH2 minus will take this hydrogen. So this will convert into O minus. It will take hydrogen from H2O. Okay. So basically this will convert into acid and NH3 gas will leave. So these are basic hydrolysis of your acyl chloride, anhydride and amide. This is amide. Okay. Okay. So hydrolysis of cyanide. So cyanide is obviously again, so you can do basic hydrolysis as well as acidic hydrolysis, whatever. So what will happen? H2O will attack on this carbon. So one of the triple bond will be broken. So here nitrogen will then take hydrogen from H2O, because when H2O will attack on this, it will be like this, H plus. So this nitrogen will take one H plus, right? Simple na? Simple na? So basically this will convert into NH, this will be OH. Then this will tautomerize. Tautomerize, how? This will attack here, this will open up and this will take hydrogen. So this will tautomerize into amide. Okay, so then again hydrolysis of amide will give you what? Acid. Here also we did that, no? Right? So hydrolysis of amide will again give you acid. Simple. So hydrolysis of cyanide will also give you acid, because cyanide will first convert into amide, amide will then convert into acid. Okay? Okay. Do this question. Major product in the following reactions. So basically CH3, CH, CH3, C triple bond CH. So alkyne is present, HgSO4, H2SO4 is present, and basically then this is Grignard reagent. See, this is Grignard reagent, RMgBr. This is known as Grignard reagent. In this reagent, R has minus charge, negative charge. So it will attack as nucleophile or base or something like that. And after that, they have given concentrated H2SO4 and heat. So this concentrated H2SO4 and heat is a reagent for dehydration. Dehydration means it absorbs water. Okay, so do this. I have given you enough hints now. Do this. do this. Do this. Are you able to do? So basically what will happen? What will happen? This HgSO4, this HgSO4, H2SO4, H3U plus, what will this do? This will oxidize this carbon into C double bond O. So CH3, CH, CH3, C double bond O, CH3. Okay, so this will do this. So this is oxidizing agent again. Okay, so what will it happen? HgSO4 and H2SO4, this will form a, basically I won't go into the mechanism, but this will form a complex with this alkyne. Okay, so after forming a complex with this alkyne, always remember that this HgSO4 will convert the more substituted carbon into C double bond O. Okay, okay. Okay, so the product here will be C double bond O, CH3. Okay, this is the product, this is X. So if this is X, then R MgBr. So ET, Mg, Br and H2O. So ET will attack here. So this will form into alcohol, right? Right? So CH3, CH, CH3, COH, CH2, CH3, CH3. Then basically dehydration, concentrated H2SO4, heat. So if you are heating with concentrated H2SO4, this OH will leave, along with this one hydrogen will leave. Either this hydrogen will leave, or this hydrogen will leave, or this hydrogen will leave. If this OH will first take this H plus, so it will convert into OH2 plus and H2O will leave. So if H2O will leave, what will happen? See, CH3, CH, CH3, C, CH3, CH2, CH3. So a positive charge will be here. So here what will happen? This positive charge, if a positive charge is formed, you will see if it can convert into a more stable positive charge. So here migration will happen. This migration will happen, or this hydrogen migration will happen. So if this hydrogen migration happens, what will happen? CH3, C, CH3 positive, CH, CH3, CH2, CH3. If this is happening, then obviously hydrogen will be taken from here and an alkene will be formed here. CH3, C, CH3, double bond C, CH3, CH2, CH3. So this is the most stable alkene here, right? So obviously dehydration product will be this, right? Right? हाइड्रोजन रीअरेंजमेंट, हाँ ठीक है, नो बढ़िया, हाइड्रोजन रीअरेंजमेंट बढ़िया, ठीक है. So this alkene will be formed. Not basically alkene can be formed from here, but this will be the most stable alkene. So you will form the most stable alkene in dehydration. Most stable alkene. Okay. Okay. चलो. Decreasing order of reactivity towards electrophilic substitution reaction for the following compounds. So electrophilic substitution reaction. See, this is the electrophilic substitution reaction in your aromatic compounds. Add benzene. See, so what happens is electrophile comes from outwards, from outside electrophile is added. So benzene has nucleophile. Basically it has pi bonds, right? It has pi electron density. So benzene behaves as nucleophile, and it attacks at the electrophile. So when it will attack at the electrophile, let's suppose these are the bonds, let's suppose. So it will attack at the electrophile. So this will attack as minus, so this will become plus. C, right? So this plus is there, then there is a hydrogen here, right? So this hydrogen is removed and minus will come here, so minus will again form the aromaticity. That will happen, right? So again aromatic compound is formed. So what is happening? Hydrogen is replaced by electrophile. So electrophile, according to this theory, electrophile is the species which has less electron as compared to the other one. So why is hydrogen electrophile here? So hydrogen is bonded to carbon, right? So carbon is more electronegative. So hydrogen is less electronegative. So hydrogen will obviously contain delta positive, here delta negative. So this delta positive, a species with less electron, that is electrophile, is being replaced by another electrophile, that is electrophilic substitution reaction. Okay. So rate of reaction for this electrophilic substitution reaction. So it will depend on two things: electrophilicity of the electrophile and nucleophilicity of the benzene. More the electron density on benzene, more it will attack on the electrophile, and lesser is the electron density on electrophile, more it will attack on the benzene. So rate of reaction here also depends on electrophilicity of electrophile and also nucleophilicity of benzene. So benzene, if electron donating group is present, some electron donating group is present in benzene, let's suppose electron donating group. So this electron donating group will increase the electron density in the benzene. So rate of electrophilic substitution will increase. C. Okay. And if electron withdrawing group is present, this will absorb the electron density of benzene and it will become less nucleophilic, and if it will become less nucleophilic, so the rate of reaction will decrease. Rate of reaction for electrophilic substitution reaction will decrease. Okay. And if CF3 is present, see carefully, CF3 is applying minus I effect. Why? Because 3 fluorine are added there. So fluorine is the most electronegative atom, as well as it is also applying minus H effect, minus hyperconjugation effect. You might not have seen, but it applies this. How? See, so there, let's suppose the CF3 is added to benzene. Okay, so this pi bond goes here, so this sigma bonds goes here. So we talked about hyperconjugation effect, no? So sigma bonding electrons goes into pi star or vacant p, right? But that is for plus H. In minus H, the electrons from pi or filled p or lone pair, whatever, goes into sigma star. So this is minus H. That is what is happening. See, so F minus will be formed and that double bond will be formed. So this is minus H effect, and this is very strong for CF3 because fluorine is very electronegative atom. Okay. So that is the thing. So if in the benzene CF3 is added, so it is a very good electron withdrawing group. Very strong electron withdrawing group. Okay, chalo, karo question. Identify the correct A, B and C in the reaction sequence. Concentrated HNO3, concentrated H2SO4, then Cl2 anhydrous AlCl3. So basically AlCl3, anhydrous AlCl3 and HCl does what? I'm not saying that it will happen in this reaction, but there is one similar reaction. Isomerization, na? No? See, anhydrous AlCl3, HCl heat, so isomerization. So don't be confused. Okay, so this is not going to happen here. That is isomerization of alkanes. Here something else is there. Okay. Do this question. Chalo. Do this question. Arey, 7 guys watching. Thala for a reason. I love Thala. Anup is saying my answer was same. Congratulations Anup. चलो करो ये वाला करो. I hope you are able to understand what to do in this question. Okay, so see this reagent concentrated HNO3 and concentrated H2SO4. This will give NO plus. So basically here nitration will happen. So this benzene will attack at NO and will form NO. ठीक है. So this is HNO3 ना, तो NO2 plus ना, or NO plus what? So HNO3, how does it dissociate? How does it dissociate? OH minus and NO2 plus. That is how it dissociates, right? So basically NO2 plus, so nitrobenzene A. Okay, so after that chloride and anhydrous AlCl3. So chloride and anhydrous AlCl3, what will happen? AlCl3. So they will form this complex. So this will increase the electrophilicity of this chlorine. So there is a electrophilic substitution reaction, but for electrophilic substitution reaction you need to attack via the places where electron density is high. So basically this is minus M group. So minus M group will take the electrons. How? Here electrons will go here, right? So what will happen? At ortho and para position plus will be there. At ortho and para position electron densities will be low. So which carbon will attack at Cl? Meta, right? So meta carbon will attack, electrophilic substitution, NO2 Cl, but then FeHCl. See, instead of FeHCl, if SnHCl is there, ठीक है. और one more reagent was there. Wait. SnHCl. I forgot. ZnHCl. Sorry. So if ZnHCl is there, so they all will do one thing. They will convert NO2 to NH2. Okay. So convert NO2 to NH2. NH2 Cl. Okay, so this is my C. Okay, and B is this. Okay, fine. Ananya is saying, and after FeCl it will be NH2. हाँ बढ़िया अनन्या, ठीक है. हाँ सही है भाई, सही है. Everyone is fine. Everyone is doing good. चलो. So let's move to. So how many of you have problem regarding identifying SN1, SN2, E1, E2, these types of reaction? Is there anyone? Tell me. Is there anyone? So first do this question, then we'll go towards this. So OH first, HCl second, AlCl3 anhydrous. Okay, do this question. What will be formed? Do this question. Is it lagging? Is something wrong? Is it lagging? Okay, do this question. See, first is HCl. So HCl will be added to what? Alkene. So do that. I've given first hint. Then do the second part. Second part is AlCl3, anhydrous AlCl3. So anhydrous AlCl3 is there to improve the electrophilicity. So try to make something out of it. Two cycles, right? So what is happening here? What is happening here? What is happening here? First, this will attack at hydrogen, and chlorine will then attack at Cl. This carbon. So what will happen? What will happen? So OH. Okay. 1, 2, 3. 1, 2, 3, 4. Or let's do like this. Cl, hydrogen. So this is the product that will be formed. After that, anhydrous AlCl3. So AlCl3 will interact with this chloride. So OH is a nucleophilic group. So it will attack from para position. Okay, and this Cl will be removed. So 1, 2, 3, 4, 5. So 5-membered ring will be formed here. OH. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there will be alkene here. Alkene methyl group here. Okay, so this will be the product, right? Right? So your final product will be this. Okay, so this is intramolecular reaction. So here again, before this we did SNNGP. There is again a neighboring group participation here. So please take care of these things. Okay, try to make a note of these things. Okay, chalo. After that, question. So benzene plus double bond O, oxygen, AlCl3, 2 equivalents. Okay, A, Zn, Hg, HCl. So you need to remember what is Zn, Hg, HCl. Hint is there only. B. Do this. What will happen? What will happen? What will happen? So this is again electrophilic substitution, right? Right? So how will this happen? Sir, will practical organic chemistry be asked in NEST and IIT? Koteshwaran, it can be. Not in IIT maybe, but it can be asked in NEST. Can be. So if you have time, just do that. Okay? But maybe mostly one question, max to max. That's it. In NEST, that's also in NEST. I don't think in IIT they will ask. So what will happen here? So there, oxygen will interact with AlCl3. If oxygen will interact with AlCl3, here plus charge will be increased. Electrophilicity improves. AlCl3 improves the electrophilicity, right? So this will attack here. This will open up, right? If this will open up, so 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, O minus AlCl3 plus. Okay, so this is the thing that will happen. So this will convert into OH. This will convert into OH, obviously, right? So if this will convert into OH, right? Then what will happen? then what will happen? So obviously this will be double bond O ना, double bond O तो रहेगा ही, वो थोड़ी जा रहा कहीं, right? So 1, 2, 3. So after that this is A, after that this is Clemmensen reduction here, ZnHg HCl. So this will be removed, obviously, right? 1, 2. Okay, बताओ. Is this fine? बताओ. Shall we move on? Chalo. Let's do a very good thing. SN1 versus SN2 versus E1, E2 and all that stuff. Okay? Chalo. Let's start this. Chalo. So how will you identify? SN1, SN2 and E1, E2, all that stuff. How will you do that? So SN1, SN2, E1, or I would say SNAR, aromatic substitution, right? E1, E2, E1CB. So all these things we'll see, right? In short, obviously it is revision, right? Obviously it is revision. So basically what happens? So let's see first of all, let's see for SN1 and SN2. So for SN1, see, if your solvent is neutral and polar protic, so there SN1 will be done. Okay, but if your solvent is ionic, basically in your solvent there are ions and this is aprotic solvent, so then SN2 will be there. Okay, let's see some examples. For example, you tell me what will happen. This is OH, Br, okay, C2H5OH. Okay, so what will happen? Batao bhai, batao. What will happen here? See there, I have just written the information, just this information is required, everything else is fine. What will happen? Ethanol is the solvent, everything is given. What will happen? हाँ, तो वही confusion I am going to resolve. What will happen here? This is neutral solvent, na? Neutral solvent, there is no ion here, and obviously this is polar protic. So neutral and polar protic. Neutral plus polar protic. हाँ, obviously in SN1 you have to see that stable carbocation is formed. If stable carbocation is not formed, this will not do anything. Okay, so you have to see that. So obviously if this removes, stable carbocation will be this benzylic carbocation. Obviously benzylic carbocation is stable, na? So benzylic carbocation will be there. So instead of now this, Br will remove and OH, O, C2H5. बताओ. Right? SN1. Right. ठीक है. और दूसरी चीज देखो. So NO2. Okay. This section will be a bit slower, okay, because I need to explain this. So we'll take 10 minutes here. So don't be impatient. Okay, we'll do this. Okay, don't worry. Chalo. Br, then C2H5O minus K plus. बताओ. what will happen now? So same, not the same substrate. Here NO2 is there, here OH was there. So obviously this OH was also stabilizing the carbocation by giving electrons by plus M effect, but there is NO2 here, which is electron withdrawing group, first of all. Okay, okay, electron withdrawing group. Okay, but then there are ions, if you can see. If you can see, there are ions, right? This is not neutral. This is not neutral, there are ions, right? So if ions are present, and obviously if this Br will leave, carbocation will form, it will not be stable because this is electron withdrawing group NO2, right? So you have to see if stable electron withdrawing or stable carbocation is also formed, that is also you have to see, and obviously there is ion. So if there is ion, it will attack and SN2 will happen. Here SN1 will happen. See, okay, NO2 OET, ET is there na, C2H5. Okay, बताओ, SN2 fine, चलो. Then another example, you tell me. Br again C2H5OH, बताओ what will happen? What will happen here? What will happen here? So again, neutral plus polar protic solvent. So remove this, na? Remove this, add plus here. So carbocation will be formed, but this carbocation will be undergoing a rearrangement. Ring expansion will happen here, right? Ring expansion will happen here. So what will happen? 1, 2, 3, 4, 5, 6. So from 5-membered ring, 6-membered ring will be formed, right? Positive charge will be at this carbon. So let's suppose this. Okay, this is positive charge. So now C2H5OH will attack, right? Right? So from here, OET will be there, right? So SN1, but always remember, in SN1 carbocation can undergo rearrangement. So if it will undergo rearrangement, just do the rearrangement. Okay, okay. Then CH3 Br NaCN, बताओ what will happen? What will happen here? बताओ. So basically here, see, Na plus is there, na, and Cn minus is there. So ions are there, and obviously if this will be a carbocation, CH3 carbocation is not stable, so this will not form a carbocation. So basically this will undergo via SN2. Here it is SN1 again. So what will happen? CH3 Cn. Okay, via SN2. Okay, chalo. Let's take next page. Okay, this will all be cleared. Just wait for 5 minutes. All be clear. Okay. Okay, chalo. Do this. Tell me the answer of this. So double bond. अच्छा, ET and Cl, okay, and H2O. बताओ भाई, what will happen? what will happen? बताओ, here what will happen? देखो, either से SN2 can't happen because this is very bulky group, right? So it can't attack from behind, right? So SN2 can't happen first of all, and this is neutral molecule, neutral solvent. So if this is neutral solvent, Cl will be removed, and if Cl, ये है यार 59% चाहिए, हाँ ले लो, ठीक है, क्या गिरा दिया? So ET positive charge. So here positive charge will be formed, and then what will happen? H2O will be added. So OH will be added. ET OH. बताओ भाई, बताओ जल्दी बताओ. Okay, then if the same reaction happens, ET Cl, so now OH minus is given, not H2O, OH minus is given, see, this is ion, not neutral, so now SN2 can happen, but point is it won't still happen because this is very bulky, so no SN2. So what will happen then? OH minus E2 will happen. Elimination reaction will happen. If this will not substitute, this will eliminate. Simple. And E2 reaction will happen. How it will happen? See. So CH2, CH3, CH2, CH3, chlorine, right? So this OH minus will take either of the H plus, and this will remove this. Okay, so what will happen? So double bond CH2 CH3, right? CH3. Okay, this will form, alkene will be formed. Now you must ask that why this didn't happen here or why this didn't happen here. इधर भी तो elimination could have happened ना? Why it didn't happen? अरे गरीबों. Point is, here there is only one carbon. There is only alpha carbon. For beta elimination you need beta carbon. So beta carbon is not available. Not here. There is only one carbon. See. So elimination can't happen. Are you able to understand? So elimination won't happen. ठीक है, but here it can happen, and there it won't happen. Why? Because there is not a strong base. H2O is not a strong base. It won't take hydrogen from there. It will just undergo SN1 reaction, and all the SN1 reactions where solvent is acting as a nucleophile. So basically this solvent is only substituting the nucleophile. Na? So this reaction where solvent is undergoing SN1 reaction with my substrate, this is known as solvolysis. So if in the question they give you solvolysis, this means SN1 reaction with solvent. Okay, don't be confused here. Okay, SN1 reaction with solvent. Okay. Then so basically generally, if in the elimination generally they would have given you heat. If they would not have given you heat, because substitution reaction, see, substitution reaction happens at low temperature, and elimination reaction happens at high temperature. Okay, so if elimination will be happening, they will give you heat. In this case, if they will not give heat, it is already understood that elimination will happen because SN2 can't happen, right? SN2 can't happen. ठीक है? चलो. Then okay, do this. do this. So this is my molecule, okay, NO2, okay, CH2, CH2Cl, okay. There is alcoholic KOH and heat. What will happen now? Batao. Alcoholic KOH and heat. What will happen? Heat is provided. See, heat is provided. I told you something right now. Just right now I told you. And what is alcoholic KOH? Alcoholic KOH is just alcohol plus KOH. Let's suppose ETOH plus OH minus. KOH will give OH minus. So this OH minus will take this H. So it will be OET minus. So OET minus is the reagent here. Okay. And heat is given. So obviously elimination reaction will happen. So what will happen? See. So this is CH hydrogen. Okay. So this OET minus will take hydrogen. But the point is this will not undergo E2 elimination. No. Why? Because when this hydrogen will be removed, minus will come here. And this minus is stabilized by this electron withdrawing group. See, NO2 is here. Okay. So this is SN, not SN, what am I saying? E1CB. Why? Because see, after this hydrogen is removed, this is acidic hydrogen. So this is removed. So this is conjugate base. This conjugate base is stable. That is why elimination reaction conjugate base E1CB. Okay, that happens. So if that is happening, what will happen? NO2 CH negative CH2 Cl. So then this will remove this. Okay. NO2 CH double bond CH2. Same thing can happen with fluorine, and if fluorine is present, it will be much better. In case of fluorine F as leaving group, E1CB is much better. Why? Because fluorine is even a poor leaving group as compared to chlorine. Chlorine is still a good leaving group, but fluorine is a very poor leaving group as compared to chlorine. So if let's suppose chlorine was replaced by fluorine, this would not have left, and the base would have taken the hydrogen. So obviously there would not have been any other option but to get a negative charge here. Okay, so it would not have been like that this negative charge will be forming and fluorine would be removing all simultaneously. No, because fluorine is a poor leaving agent. It can't happen, right? Poor leaving group, right? So E1CB is much better as compared to chlorine. Okay, बताओ, समझ आई बात? प्रॉपर लीविंग ग्रुप, अरे प्रॉपर लीविंग ग्रुप तो है ही भाई, ऐसा कुछ नहीं है. There is nothing called as proper leaving group or something like that. If a negative charge will be formed here, it will leave the other group. It will make the other group leave. If the other group is poor leaving group like fluorine, then E1CB will be much better. But if it is Cl, much better means there will be only one option from where the reaction will go, that is E1CB. Here E1CB can also happen, here E2 can also happen, but dominantly E1CB is here. Here dominantly E1CB is there, but it can also undergo E2. But here E2 is not a case, only E1CB will be there with fluorine. Okay? Okay? चलो. For example, लो C triple bond N CH H CH2 F, again alcoholic KOH, heat. So see, now fluorine is there, right? And there is a electron withdrawing group. So this will take this, negative charge will be formed here. So E1CB. Now fluorine is not a good leaving group, but there is a negative charge. It will want to stabilize. So this will remove fluorine. So E1Cb and CH double bond CH2. बताओ, is it fine? Is it fine? I have written poor, no. अरे नहीं भाई अनूप, ऐसा नहीं होता भाई. ठीक है, चलो. Do this. Fluorine, chlorine, NO2. Okay, and then ETO minus K plus. Do this one. What will happen here? बताओ भाई, जल्दी बताओ. So here fluorine is a leaving group, but it is a poor leaving group. So chlorine is a good leaving group. Fluorine is a poor leaving group. So this is good leaving group. This is poor leaving group. But the point is here NO2 is present. So this is an example of SNAR. So you are substituting nucleophile in aromatic compounds. So what happens in aromatic compounds? So we have seen electrophilic substitution. Similar to that, nucleophilic substitution happens. In electrophilic substitution, benzene attacks at the electrophile, right? If you remember. But in nucleophilic substitution, nucleophile will attack at the benzene. So benzene needs to be more electrophilic. Benzene needs to be more and more electrophilic. So that is why NO2 is present here. But the point is, if NO2 is present, it will take electrons by minus m, right? If it will take electrons by minus m, plus charge will be at ortho and para position, not at meta position. So even if chlorine is a good leaving group, see Anoop, even if chlorine is a good leaving group, here fluorine will leave. Why? Because chlorine carbon has more electron density as compared to fluorine carbon. So carbon attached to fluorine is more electrophilic. So OET minus will attack here. So if it will attack here, what will be formed? So this will be fluorine, this will be OET, right? So this will be minus NO2 chlorine. So now this minus can go into resonance and go here. So it will be stabilized by NO2 minus M effect, right? That can happen. So that happens, but point is this F minus then leaves, and if F minus leaves, here positive charge will come, and again aromaticity will be formed. O, ET, Cl, NO2. So whatever is at the ortho and para of electron withdrawing group, that will be substituted. Ortho and para of electron withdrawing group. You have to see that for obvious reasons, right? सही है कि नहीं? चलें आगे, चलो. Do this. So F NO2 NO2 and NO2. Okay, so now NaOH. So that is SNAR. This is SNAR. This is also SNAR. This one. So what will happen? Do this. What will happen? This is a simple one. What will happen? See, the point is 3 electron withdrawing groups are present. 3 electron withdrawing groups are present, right? So all 3 will make a positive charge, very good positive charge here on this carbon attached to fluorine, if you see, because this is ortho to this, para to this. So basically electron density will be reduced a lot. So what will happen? OH minus will attack here and fluorine will leave. OH, NO2, this is what? Picric acid, na? NO2, picric acid, right? Now do this. do this. So CH3, CH3, Br2, H nu. Okay, then so this will be A, then NaI, acetone. Okay, so this will be B, and AgF, HgF2, okay, and H2O plus ETOH. Do this. This will be C. बताओ भाई, बताओ. हाँ, फ्री रेडिकल, दैट इज गुड. हेयर इधर क्या बनेगा? इधर बनेगा फ्री रेडिकल, ऑब्वियसली H nu and Br2. So Br free radical will be formed. So if Br free radical will be formed, both the carbons are equivalent. You can do anything. So A will be CH3, CH2, Br. Okay, then you are reacting A. You are reacting A with NaI and acetone. Which reaction is this? Can anybody tell me? Which reaction is this? This is halogen exchange reaction. I minus will replace Br by Sn2. So I minus will replace Br by Sn2. Why Sn2? See, there are ions na, plus minus, and acetone is polar aprotic solvent. So Sn2 will be preferred. So Sn2. So what will happen? Which reaction is this? बताओ. हाँ, Br की जगह तो आ जाएगा अनन्या, बट रिएक्शन का नाम क्या है? Is this some kind of reaction? Or not? हाँ, ठीक है. अरे स्वार्ट्स you can say, but ठीक है, ठीक है. So this is general halogen exchange reaction. So what will happen? CH3, CH2, I. You can also say Schwarz reaction, whatever, right? So this is your B. Okay, if this is my B, so then AgF and HgF2, H2O, ETOH. So basically this will provide me F minus. So instead of I minus, now F minus will be provided. So F minus will replace Br. Simple है ना यार? Simple है. So your this is what? C, na? So C will be CH3, CH2, F. But point is here Ag is there. So Ag and Br will precipitate out. Ag and Br will precipitate out. So this is what? Schwarz reaction. Okay, बताओ. हाँ, Finkelstein reaction. So basically this is Schwarz reaction, that is Finkelstein reaction. So this one is Finkelstein reaction. Okay, बताओ. ठीक है, तो ऐसे you have to remember what is happening, what is not happening. Okay, चलो. अरे कार्बोनिल कहाँ से आ जाता है बार बार? चलें आगे. Okay, so now do the questions. So question is, carbon double bond CH, 2 single bond CH3 plus HBr A. So major product. What is major product? बताओ. HBr is given, alkene is given. What will happen? What will happen? अनूप Hg2F, अरे इतना मत सोच, Hg2F2, HgF2, whatever it is, these will come together, AgF, HgF2. So if you are not able to understand why HgF2, so Ag will be present, Ag plus 1 will be present, fluorine will be present. So try to put common sense into things. Okay, not everything has to be very perfect. Okay, don't worry, even if I have written wrong, it is Hg2F2, or I don't know, it is HgF2, whatever it is. So the point is, if that comes, you will know that it is Schwartz reaction. Okay, so basically what will happen here? So according to me, what should happen? This will attack at H, so a positive charge will be formed here. So positive charge CH3 CH2H. Okay, positive charge will be formed here. So positive charge, if it is forming, so obviously ring expansion will happen. So if ring expansion is happening, so this will be okay. So let's say this is this. So basically here positive charge will be there, and on this carbon there will be a CH3, right, and CH3, right. Again one thing can happen. Again this can migrate here. You have to make the most stable carbocation. Still it is not the most stable one, right? So again, now this is more stable, right? Now this is more stable. Now if Br will be added, so what will happen? Okay, fine, chalo. Do the question again. Okay, so I am giving you some halogen compounds. Wait. So A, B, C, D. ठीक है? Br नहीं, थैंक यू. ठीक है. Br. So this is A, this is B. Okay. This is IA, this is IB. Okay. Then this is BR, A, ME, BRB, and then BR, BRA, BRB. So basically in May we have to choose the halogen which is most reactive towards SN1 in all the compounds. Choose the halogen most reactive towards SN1 reaction. So in all the compounds, A or B, whichever is most reactive towards SN1 reaction. Choose this. Arey, Anoop, wherever carbocation is formed, rearrangement can happen. SN1, addition, whatever. Okay? So Vishwa is giving A का A, B का भी A. ये क्या है? दथन. A का A, Anoop is saying, अच्छा Anoop is saying, Vishwa is saying C का B. अरे क्वेश्चन करो भाई, एक ही आंसर क्यों दे रहा है? क्वेश्चन करो. Do the question. So basically, for the halogen to be more reactive towards SN1, उसके निकलने के बाद after leaving it, the carbocation should be more stable. More stable carbocation, you have to see. More stable carbocation. So if this Br will leave carbocation, this Br will leave carbocation. So this carbocation is more stable, na? Benzylic carbocation. This carbocation is more stable. So A is more stable here. Now here, if this will leave, this will leave. So positive here, this will leave, positive here. So this one is more stable due to resonance. So IA is more stable again here. Here, what will happen? If this will leave, positive on here. If this will leave, positive here. So here, one more thing, Brett's rule. So those who don't know, Brett's rule says that on bridgehead carbon, so this is a bridgehead carbon. Why? This is bridgehead. Why? Because this is a bridge, right? So this bridge, so these two carbons are the heads of these bridges, right? So these two carbons are the heads of this bridge, right? So if this is bridgehead carbon, so add bridgehead carbon. sp2 hybridization is not stable. Okay, so please don't try to make sp2 carbon on bridgehead carbons. Basically, it is not like it does not form, but it is very unstable. Okay, so obviously this B1 will be more susceptible to SN1 reaction. Why? Because if this will leave, the carbocation form will be more stable. Okay, and then if this will leave, so carbocation will be this. If this will leave, carbocation will be this. So here A is more stable. Is it fine? Is it fine? ठीक ठीक है, चलें आगे. देखो, अच्छा, अब थोड़ा सा we'll mix physical chemistry with organic chemistry. देखो, so basically there is a graph. With this graph I will also tell you a concept, but I will give you a question. So this is energy. Okay, this is reaction coordinate. Okay, so this is A, reactant. Wait. Okay. Okay, and this is B. So this is my reaction coordinate, this is my reaction curve. So basically this is step 1, this is step 2, this is step 3. Okay, so this is physical chemistry we are adding. Obviously chemical kinetics we are adding to the organic chemistry. So basically this is my product, this is my product, this is my reactant. So you have to find what? First, total intermediates. How many intermediates are there? B. Total transition states. How many transition states are there? C. Rate determining step. So please find out total intermediates, total transition states, and what will be the rate determining step in this step 1, step 2, step 3. What will it be? हाँ अनूप, वो यार सर आई एम सचिन, तो मैं क्या करूँ, जॉब छोड़ दूँ? इफ़ यू आर सचिन इट्स ओके, कॉन्ग्रेचुलेशन ब्रो. बताओ, देखो, so intermediates are these species which are formed between two steps. So this is step 1, this is step 2. So the species which will be formed between two steps will be intermediate. Okay, it is not marked here, but obviously two intermediates will be formed. Okay, transition states will be formed. In each step there will be one transition state. This is transition state of first step, this is transition state of second step, this is transition state of third step. So total number of transition states is equals to total steps. Okay, so this will be 3, and total number of intermediates will be total steps minus 1. Okay, and what will be the rate determining reaction? Rate determining step will be the slowest step. So slowest step. So how will you find the slowest step? The step for which activation energy is maximum. So max activation energy. So max activation energy is for this step. See, this is the maximum activation energy, no? For this step, second step. This one. See, देखो. So EA2, if it is max, so second step is the RDS, because slowest rate of reaction will be for second step. Okay? Okay? सचिन कह रहा है रोस्टिंग अगेन. अरे आज तो पहली बार ही किया मैंने. चलें आगे. चलो. Question. So I am giving A, B, C, D. So this is Cl and O2. This is Cl and O2 and O2. This is Cl and O2. This is Cl and O2. So basically, which will have the lowest rate towards your SNAR? Lowest rate towards SNAR with OH minus ion. बताओ बताओ बताओ. चिदम्रदा, जो भी है चिदम्रदा, you are asking organic part, is this lecture enough? This lecture is for revision, so we are doing MAHA revision. Okay, so obviously if your organic is weak, this lecture will help you a lot. The points that I am telling you in this lecture, even if you revise that, even if you do question practice regarding that, I am also helping in question practice here. So basically that will obviously help. So after this lecture, if your organic is weak, for anyone who is watching, if your organic is weak and you are sitting throughout this lecture and you are doing question practice, then after this session you are again doing question practice at home, you can easily do 3 to 4 correct answers in your IIT, and in IIT almost 5 to 6 organic questions are asked, so you can easily do 60% organic questions, 60 to 70, and if your organic is strong, you can do 80-90% questions. Okay, चलें. So see, देखो मैंने क्या बोला था, nucleophilic substitution reaction. So nucleophile will attack on benzene. So rate of reaction will depend on nucleophilicity of external nucleophile, but here external nucleophile is not given, so we can assume that external nucleophile is same, so it is also directly proportional to electrophilicity of aromatic ring. So more the electrophilicity of aromatic ring, more will be the rate of reaction. We have to find the lowest rate of reaction, that means lowest electrophilicity. So lowest electrophilicity will be, so lowest electrophilicity on this carbon, see this carbon, this carbon, this carbon. So obviously this is at ortho, so obviously minus M will be there, so positive will be at this and this. Here again positive will be at this places and this. So basically there are two NO2, so positive will be more on this para position, and there obviously NO2 is there, so positive will be an ortho and para, but here it is at meta, so positive will be here, here and here, so this will not be positive enough. So least electrophilic, so least electrophilic means least rate of reaction. ठीक, बताओ बताओ, ठीक है ठीक है, चलें नेक्स्ट क्वेश्चन. चलो ये वाला नहीं करते यार, ये तो एक मैंने करवा ही दिया ना. हाँ ठीक है, चलो. So you have to identify the correct order of reactivity. So identify the correct order of reactivity. So A. So you have to identify for SN2. ठीक है. Br greater than Br. B. For SN1 you have to identify Br greater than Br. Then C. Electrophilic substitution. Okay. Cl greater than Cl NO2. Then D. Nucleophilic substitution, SN. Just simple SN, not SN1, SN2, whatever, just simple. Br greater than Br NO2. बताओ भाई, बताओ. So what is the correct one here? What is the correct reactivity? हाँ MSQ भी हो सकता है, MSQ भी हो सकता है, MSQ भी हो सकता है. Check everyone, check every option. MSQ भी हो सकता है. So what is the time right now? Okay. देखो SN2 reaction obviously. So at SN2 reaction the carbon attached to the leaving group should be less bulky. So this is more bulky carbon, na? This is more bulky carbon. If you see this is more bulky carbon. Okay, so this carbon is less bulky. So obviously rate of SN2 will be higher here. So this is correct. Okay, for SN1 the carbocation formed should be more stable. So obviously carbocation formed here is this and here is this. So here obviously there is plus R effect is obviously more ज़्यादा it is dominant. So obviously this is also right. Electrophilic substitution. So electrophilic substitution, the benzene ring should be nucleophilic. So nucleophilic. So here NO2 is there. So obviously and Cl also is there. Cl is providing minus I effect and NO2 is providing minus M effect. So two electron withdrawing groups are there. So electrophilic substitution, very less nucleophile alkene will be benzene will be this will be more nucleophile benzene. So basically rate will be higher. And SN, normal nucleophilic substitution reaction, your benzene will be more electrophilic. So see, NO2 is there. So obviously more electrophilic benzene. So all of them are right. Okay. अरे आयुष, एवरीथिंग इज राइट. क्या कर रहे हो तुम लोग? अरे भाई, न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन, तो बेसिकली this benzene will act as electrophile, na? Nucleophile will attack on it, so NO2 is added. Here no NO2 is there, so this will be more electrophilic, so rate of reaction will be more, na? Here and here electrophilic substitution, so benzene needs to act as electrophile, so here NO2 is added. There is no NO2, So obviously more electron density will be here. So more nucleophilic ring. So more nucleophilic ring means more electrophilic substitution. अरे क्या गरीब हो भाई, गरीबी का आलम खत्म नहीं होता भाई तुम लोगों का. करो भाई. Major product for Friedel Crafts acylation of chlorobenzene. बताओ. So for chlorobenzene you have to do Friedel-Crafts alkylation. So chlorobenzene is this. This is chlorobenzene. Friedel-Crafts acylation CH3COClAlCl3. So this will interact with this. So this carbon will form or will be very high electrophilic. So this benzene will attack at this C double bond O. But for that the benzene carbon needs to be nucleophilic. So here chlorine will be ortho and para dialectic. So para will form the major product because obviously acyl group is bulky group. So it will not come at ortho of Cl. No? So major product will be para product COCH3. ठीक, बताओ बताओ बताओ. देखो, number of moles of AgNO3 or AgCl formed in the following reaction. Okay, so Cl double bond ClH AgNO3 and it is in excess. Okay, so A plus X AgCl. So you need to find X. Find out. बताओ भाई, what will happen? Basically number of moles of AgCl that will be precipitated out, you have to find. So AgCl, basically Cl will remove. So what will Ag do? What does Ag do? This Ag, this is a good precipitating agent for halides. This Ag precipitates halides, right? So if it will precipitate halide, this will take Cl and leave. So if this will take Cl and leave, it will form a positive charge. So the positive charge will only be formed at stable positions, like where the positive charge will be stable. So positive charge will be stable here because of plus R effect of benzene. It will be stable here at this carbon as well. This carbon from where Cl will leave, because it is a 2-degree carbon, right? So this will be stable here as well, but not stable here. It is not like AgCl will take Cl from here and positive will be formed at benzene. No. sp2 carbon is there on benzene, so on that positive will not be formed. Similarly here also it will not be formed, sp2 carbon. So Cl will leave, sp2 carbon won't have positive charge. Na? So here 1 and 2. So 2 Cl will leave. So basically 2 AgCl will precipitate out, and after that positive charge will be formed. So then basically different reagent you can use to do the substitution. Okay, fine. So answer is 2. Yeah, correct. अरे ये वाला कैसे बता दिया तुमने? बढ़िया भाई, बढ़िया. चलो चलें आगे. अच्छा चलो, दिस इज अ गुड क्वेश्चन. इसको ध्यान से करना. चलो This is a concept as well. Cl. देखो AgCN and C2H5OH H2O. ठीक. NaCN again C2H5OH H2O. So this will be A major. This will be B major. So find out A and B. बताओ भाई, बताओ. किस किस को ये कॉन्सेप्ट पता है? Who knows this concept? Who knows this concept? What is happening here? What will happen here? Who knows this concept? Yeah, I will have to explain. So see, what is happening? देखो, AgCN has covalent bond. Ag and carbon has covalent bond. Okay. So if that happens, so this cyanide, obviously cyanide is there. So and heat is not present. So there will be a substitution reaction. So substitution reaction will be there. So this will be obviously basically not a. The point is here SN1 can't happen because the carbocation is not stable enough. It is 1 degree carbocation, so it won't form. So it will be through SN2, but that is not the question. Whatever it is, point is nitrogen will attack here because carbon is bonded from Ag from covalent bond. This is covalent bond, right? Covalent bond. So if this will form, so Ag will then take Cl and Cn will be added. So A will be NC. So isocyanide. So isocyanide will be formed as major product here. But here, what will happen? This is NaCN, Na plus Cn minus. So Cn minus is present. So Cn minus is minus on carbon charge. Minus charge is on carbon. So since Cn minus will replace this Cl. So B is your Cn, cyanide, major. Okay, because this is ionic bond. Okay, बताओ. हाँ, ionic in cyanide and covalent in isocyanide. Yeah, that is right. Okay. चलो देखो, क्वेश्चन iodine, fluorine, NO2. Okay. PHS minus Na plus DMF. बताओ भाई, बताओ. So basically this is PHS minus. Obviously this is nucleophile. So it will obviously substitute something. So SNAR can happen, SN2 can happen, SN1 can happen. Basically heat is not provided, so elimination won't be done here. So what will happen? Tell me. And obviously DMF is what? Aprotic solvent. So aprotic solvent prefers what? SN2. I told you. Aprotic solvent prefers SN2, right? हाँ AgNO2 NaNO2 ओके, वो तो ठीक है। ठीक है, तो देखो क्या ही होगा यार यहाँ पे, this will be SN2. Okay, SNAR will not happen. Why SNAR will not happen? Because this fluorine is not at the para of NO2, first of all, and I is a better leaving group. So here better leaving group can leave. We did one question where better leaving group could not leave, like chlorine could not leave. That's why fluorine left, because fluorine could. But here fluorine can't leave because it is at meta, not at para, right? So basically what will happen? The answer will be okay, so this will be SPH. Okay, whatever it is. Okay, ठीक है, चलो कुछ एक कॉन्सेप्ट है जो देखना बहुत ज़रूरी है। देखो, दिस इज़ अ वेरी इंपॉर्टेंट कॉन्सेप्ट। सो चलो, अरे इसको करो डिलीट। OH, ठीक है, ठीक है। सो फर्स्ट इज CH3 SO2Cl. Okay, and pyridine. This is pyridine. Second is NaCN and DMF. Okay, so what will happen here? What will happen here? What will happen here? Iodine replaced by SN2. हाँ, देखो क्या है, this whole group, if you guys know this whole group, this is tosyl group. Okay, this is tosyl group. Okay, so what happens is this pyridine is a base, so it will take hydrogen from OH. So O minus. Okay, now this will attack at this group. What group? SO2Cl. Okay, CH3, tosyl group. Why? Because this is electrophilic. So this happens and chlorine is removed. So this becomes OTS. This whole I can write as TS. So this becomes OTS. And this OTS is a good leaving group. Okay? Okay? And here basically then NaCN will be added. NaCN will be added. So if NaCN will be added, what will happen? And DMF, sorry, not OMF, DMF. So DMF is non-polar and there are ions. So obviously there will be SN2. So SN2. CN. Okay. So you converted this into good leaving group. This is OTS. So if in the reaction they give you OTS or they give you TS or they give you this CH3 benzene SO2Cl and pyridine, so you should be aware that okay, they are trying or they are telling us to make a good leaving group like OTS. Okay, ठीक है sir? If someone's chemistry is weak, yeah, if some, that is the purpose of this session. If your organic chemistry is weak, please watch this, because I'm not teaching very advanced things. You can ask in the comments from the children, okay, who are attending the lecture. I'm teaching from, like, the concept is very basic. Okay, I'm not doing something very advanced. Okay, चलो Okay, now next is also a very important concept. So you have to do this question. Okay, चलो, जिसको नहीं आता I will explain, वो तो है ही, but try this. CH2OH OH, okay, SOCl2 A, major. Do this one. What will be the answer? OTS is also the name of planet. I didn't know that. Okay. Chalo. Do this. What will happen with SOCl2? What does SOCl2 do? Let me drink some water. What does SOCl2 do? देखो क्या होता है, देखो ध्यान से देखो. So if there is R, let's suppose there is CHOH group. Okay, what happens is it interacts with SOCl2. Right? This is SOCl2. So this OH will attack here. This will open up, then this will close. Addition elimination reaction. Cl will take this H. So HCl will be removed. So what is happening? CHOSOCl. Okay, this is happening. So now what happens is, if nothing is given, okay, so this lone pair will attack here and this will attack here. So this lone pair attacks here, this opens up, then this closes, then chlorine leaves, and then chlorine attacks from the side of this oxygen. So retention happens. Okay. So CHCl. So this is SNI. Okay. Internal nucleophilic substitution. So retention happens. Okay. So that is the thing. Okay. In this one. So basically, देख लो कहाँ पे. So this also happens with this group, OH group. So basically we need OH, no? So this also happens with acidic group. Okay. So if there is acidic group or if there is OH group, so you can see. So there is a OH group here. So it will interact with SOCl2. This will interact with SOCl2, but this will not interact with SOCl2. Why? Because this is a phenolic OH, na? So phenolic OH won't interact. Phenolic OH won't, like here Cl is substituting O. Here Cl can't just substitute OH from phenol. So that is not happening. So this will happen. Okay. So what will happen? Cl, अरे ये CH3 लगेगा तुम्हें. Cl, CH2, Cl, OH. Okay, is this fine? हाँ, chlorinating agent, बढ़िया. कोई नहीं अनूप, यहाँ से पढ़ ले, कोई नहीं. ठीक है. So this is an important concept. Okay. So now, चलो देखो, do this question. A interacting with first Cl2 and heat, then Cn minus, then H2O H plus, and 4 bromo phenyl acetic acid. Acetic acid is formed. Okay, so what is A? बताओ A बताओ, what is A? See, so question might not be asked like this in IIT and NEST. I am here to improve your concepts. This question might be asked in a very theoretical manner maybe. Okay, so don't be like this question will come in IIT or NEST. No, concept can be asked. So that is what we are revising. We are revising the concepts, no? So we are revising through questions. Baki to PYQs of IIT and NEST you can any day do, right? Batao, what will happen? What is A? What is A? So I will give you a hint. First form this. What is this? Bromophenyl acetic acid. First form this. देखो, what is this? This is 4-bromophenyl acetic acid. Phenyl, acetic acid, CH2COOH. So this is acetic acid. Now bromophenyl, 4-bromophenyl is added. So 2 4 ठीक है. So 1 2 3 4. So this is being made. So if this is being made, so from what it is being made? First of all, here there will be a radical mechanism, Cl here. Okay, so if I take this, bromine and CH3, now can you do this Cl radical mechanism? So from this Cl radical mechanism, this will be converted to CH2Cl, Br, CH2Cl. After that, cyanide is present. So cyanide, what will it do? Cyanide will do SN2 here. Okay. Bromine, cyanide, and then hydrolysis of cyanide. So hydrolysis of cyanide will give you acid. No? We saw the hydrolysis of cyanide. So it will first form amide, then it will form acid. Br, C. Wait. अरे वही ठीक है, मैंने यहाँ पे इसको क्यों कर दिया? अरे CN यहाँ पे आएगा ना, वेट, CH2CN, हाँ, तो CH2COOH. ओके, डन. So retrosynthesis can be asked like that. Okay, so be aware of things. Chalo, I am doing so many questions so that your concepts can be strengthened by that. Okay, these concepts can be asked. CH2Br. Okay, so who among you know Gabriel-Thalamide reaction? O minus N minus K plus. First is this, second is OH minus H2O. So you have to find A. Batao. So this is thalamide, type of that only, right? So do this. Do this. जिसको भी पता है, those who know Gabriel Thalamide, do this. So by Gabriel Thalamide you find what? You synthesize what? You synthesize your primary amine. No? So देखो what happens? देखो. So this N minus will attack HCH2 and by nucleophilic substitution it will replace Br. So what will happen? First CH2 N ठीक. That is what is happening. It is substituting bromine, right? Now you are doing hydrolysis. OH minus H2O basic hydrolysis. So OH minus will go here and also here, right? So if this will go here, what will happen? These two will be formed into acid. What will happen? These two will be converted into acid. OH, and this nitrogen will gain this hydrogen from water, right? So two hydrogens from water, CH2 NH2. So we got what? 1 degree amine, and that is what we get from Gabriel Thalamide synthesis. Thalamide synthesis. So what happens? It is very simple. First, this thalamide will attack at CH2 to displace Br. Then hydrolysis will happen. In some cases, they won't give this thalamide. They will give this. This is thalamide. Actual thalamide is this NH. Okay, but then they will give KOH. So this KOH will take this H and K plus will be formed here like this. Okay. So from that you have to form this. This ion will then substitute this. Then hydrolysis will happen and you will get 1 degree primary amine. Okay. Is that fine? चलें आगे. अच्छा रुको भाई रुको. देखो तो भाई मैंने लिख दी. I will write here what? Rx plus R plus, not plus, here Rx will go into R plus X minus. ठीक है. So ion pair. Okay. So R plus X minus, this is solvent. Okay. Separated ion pair. Okay. Then Y minus will come and then Ry will be formed plus X minus. So this is SN1 reaction. You have to find the correct statements. I am writing the statements in short, okay? I won't write the complete statement. Okay. So A, reaction favored by weak nucleophile. B, R minus formed easily if substituent R minus or R plus? R plus. Substituent R bulky. C, reaction accompanied by racemization. This is the last question for this topic. Then we will move to next topic. D. Reaction favored by polar solvent. बताओ, which is the correct one? Which is the correct one? ओके इसके बाद एक और करेंगे बस, ठीक है, दैट इज द लास्ट. बताओ भाई, विच इज द करेक्ट वन? रिएक्शन फेवर्ड बाय वीक न्यूक्लियोफाइल. अरे basically nucleophile is not even present in the rate determining step. This is the rate determining step. This is the rate determining step. This is the rate determining step. So rate determining step does not depend on the nucleophile. Does not depend on nucleophile. So reaction favored by weak nucleophile or strong nucleophile, whatever you can say. But the point is if the nucleophile is so strong, for strong nucleophile, it will attack immediately on R. So strong nucleophiles give SN2. So obviously if you are taking strong nucleophile, it will go for SN2. So by that analogy, you don't have to take strong nucleophile, you have to take weak nucleophile. Why? Because weak nucleophile won't favor SN2. So indirectly it is favoring this reaction, but directly it is not favoring this reaction. Are you able to understand? So this is correct. Okay, R plus formed easily if substituents are bulky. Obviously R plus, if substituents are bulky, so basically more substituted carbocation, so basically more stable carbocation. Reaction accompanied by racemization. Yeah, obviously racemization is what I told you, na? I told you. So basically here solvent assisted ion pairs are formed, R plus X minus. So this R plus is sp2 hybridized. Carbocation is sp2 hybridized. So this is planar, na? Planar. Planar means C, A, B, D. There is a carbocation here. So incoming nucleophile will come from above as well as will come from below. Now how much it will come from above, how much it will come from below? So it will form both R and S. So if it will form both R and S, I don't know how much. If it will form more R or more S, whatever. But generally, some amount of racemization will happen. So obviously, right? Reaction favored by polar solvent. So polar solvent, polar protic solvent. Polar solvent, it's fine. Reaction favored by polar solvent. Yes, right? 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 All statements are correct? No? बताओ भाई. अच्छा ये नॉन पोलर सॉल्वेंट है, मैंने पोलर कर दिया, ठीक है. इसमें तो ऑल स्टेटमेंट्स आर करेक्ट, बट इन द ओरिजिनल क्वेश्चन इट वाज नॉन पोलर सॉल्वेंट, देन दिस वुड हैव बीन रॉन्ग. ओके, ठीक है, ठीक है. सो लास्ट क्वेश्चन, देन वी विल मूव टू व्हाट मोस्ट इंपॉर्टेंट चैप्टर, दैट इज कार्बोनिल ग्रुप्स. ओके, so last question, see this one. So this is ether and this is CH2Br. Okay, HBr, heat A, then Na, ether. So intermolecular product B. ठीक, बताओ what will happen? After this I will give you 10 minutes of break, क्योंकि भाई मुझे भी भूख लग रही है अब. बताओ. अरे लाइव चैट कहाँ गई? लाइव चैट तो दिखे. Can't see the live chat. ठीक है, ठीक है, बताओ क्या बनेगा यार. देखो देखो, so this oxygen will take this hydrogen, and then what will happen? O CH2 Br OH. So basically this is activated. Now bromide can attack from here as well as it can attack from here. Okay, but the point is, by attacking sp2 carbon, like it is very difficult for attacking sp2 carbon, so it will attack here. So what will happen? SN2 reaction, na? So SN2 is not favorable on sp2 hybridized carbon. So basically OH, and this will be 1 2 3 1 2 3 Br, right, and CH2Br, right. So then Na ether, Woods reaction, nahi, Na ether. So basically this hole will be removed and 5-membered ring will be formed here. नहीं, बताओ और कुछ भी है क्या यहाँ पे? 1 2 3 Br 3 4 5 1 2 3 4 5 6. So 1 2, एक सेकेंड, अच्छा 1 2 3 4 5. So 1, अच्छा 1 2 3, ठीक है, तो यही बनेगा ना यार. दिस विल बी फॉर्म ना. बताओ, दिस विल बी फॉर्म्ड और समथिंग एल्स विल बी फॉर्म्ड. मेरे को लग रहा है मैं कार्बन में आई एम मेकिंग अ मिस्टेक इन कार्बन. 1 2 3 4. So here, okay, here there is one CH2 as well ना यार. वही मैं कह रहा हूँ, क्या कर रहा हूँ मैं. ठीक, अरे भाई CH2 थोड़ी निकल जाएगा, वही मैं कहूँ. Br, ठीक है. So these Br will be removed and 1 2 3 4 5 6-membered ring will be formed. Okay, so this will be your answer. ठीक, ठीक, सही बात है. So now we'll start with what? Carbonyl compounds. So yeah, so carbonyl compounds we'll start with. So basically I will give you, what is the time here? 18:08. So let's start with 18:20. At 6:20 we'll start this by, so after carbonyl compounds only amines will be left. So carbonyl compounds will take, let's suppose, almost 3 hours. So 9:20 or 9:10, 9:15, and then amines will take 1 hour most probably. So I will end this by 10:30, max to max by 10:30. Okay, biomolecules I'm not doing, right? So obviously you can revise biomolecules yourself. So we'll start with 6:30. Okay, let me have some lunch, I need some energy. Okay, chalo. आ जाओ. हेलो. आ रही है आवाज़? आ रही है आवाज़? आ रही है. So let others come as well. So आ जाओ. थोड़ा रिफ्रेशन अप होके आ जाओ. Refreshen up and come. Okay. So wait a second. So shall we start our carbonyl compounds? So point is, from last night I have just slept for 1 hour, and from today's morning I'm just surviving on fruits. So I'm not very well, but point is, let's just, because this is the end game, na? This is the last time. So basically we are here, you are here. So let's just give our best, right? So let's go. As Khalid sir says, let's go. Shall we? Let's go. चलें, एक बार thumbs up. But just give me a thumbs up, एक बार, so that I can know that our frequencies are matching, so that we can begin. Shall we go? बताओ जल्दी बताओ. चलें, चलो. So carbonyl compound, the first thing we need to see in carbonyl compounds is oxidation and reduction. Is this visible? Tell me, is this visible enough? I think this is visible. Is this visible enough? Right? Is this visible? Is this visible? हाँ, let's go. चलो, ठीक है. So oxidation and reduction we have to see. So now I will give the break after this carbonyl compounds. Okay, so after 2.5 hours we'll take a break. Now till next 2.5 hours, 3 hours, no break will be there, because I have to complete this. This is the biggest chapter, and most questions come from this chapter only. Okay, so basically oxidation and reduction. So oxidation of 1 degree alcohol will give you what? Aldehyde. Okay, then aldehyde will oxidize to carboxylic acid. Okay, so if you are adding weak oxidizing agent to 1 degree alcohol, it will convert it into aldehyde. But if you are adding strong oxidizing agent, it will convert into complete oxidation. It will do complete oxidation. It will convert into carboxylic acid. Right? This is my handwritten notes. This is this is complete organic chemistry from 11th and 12th that we are doing today. Okay, so then 2 degree alcohol, either weak oxidizing agent you can take, or you can take strong oxidizing agent, whatever you can take. So basically this will form ketone. Okay, so then 3 degree alcohol won't be oxidized. Why? Because there is no hydrogen here. Is there a hydrogen here? No, I don't see. These are getting oxidized because there is a hydrogen at carbon. See, right? See, carbon, hydrogen, 2 hydrogens are there. So now here also hydrogen is present. So if hydrogen is present on the carbon, oxidation will take place. If not, it will not take place. Like 3 degree alcohol won't get oxidized to any other thing like ketone or something like that. Okay. Now there is a reagent known as copper at 300 degrees Celsius. So what does that do? So 1 degree alcohol converts into aldehyde, and 2 degree alcohol converts into ketone, like happens. So basically this is a mild oxidizing agent. This works as a mild oxidizing agent. Copper plus 300 degrees Celsius, copper plus heat. Okay, then if you are taking your 3 degree alcohol, this does dehydration. So what happens is, so this is a OH, so this OH and this H, it will remove, so it will form a alkene there. Okay, so this is a dehydrating agent, copper plus heat, 300 degrees Celsius. Okay, so that is the difference between copper and heat. So if you are adding any other oxidizing agent, this won't do anything to this 3 degree alcohol, but copper plus heat will dehydrate it. Okay, is this fine? Is this fine? Okay. मेरा ऑर्गेनिक नहीं पढ़ूं, हाँ हो जाएगा हो जाएगा हो जाएगा, चलो ठीक है. Then next, now let's see different types of reducing agent. So I think that you guys are very confused about different types of reducing agents. So we'll spend some time here. Like which reducing agent will reduce which compound. Okay. So this is the substrate. This is the substrate list. Okay, this is the substrate list. So this list is in the order of decreasing electrophilicity. Okay, first of all you should know this. Okay, why? Because Cl, see here, C double bond O, Cl is applying minus I and oxygen obviously is applying minus I, so this is very electrophilic, right? Similarly here, this is anhydride, so this whole group will apply minus I effect to this carbon. Okay, so again this is electrophilic, then your aldehyde is electrophilic. Now ketone is less electrophilic because there is CH3, so obviously this will provide hyperconjugation effect, so this is less electrophilic. Then ester is even less electrophilic. Okay, so ester is even less electrophilic because it will donate electrons directly towards this oxygen. Then acid is less electrophilic. Okay, and then NH2 is less electrophilic, even less electrophilic. Okay, are you able to understand? So the point is this is the order of electrophilicity. Okay, this is the order of decreasing electrophilicity of these substrates. So substrates first we have studied. Okay, it's fine. Okay. Now after substrates, let's see the reagents. So LiAlH4, this is the strongest reducing agent among these four: NaBH4, LiBH4 and diol H. So basically these four reducing agents we have to see right now. So LiAlH4 reduces everyone. See, everyone. So tick mark means it will reduce everyone. Okay, it will reduce everyone. So what it does to acyl chloride? So it provides hydride, na? So hydride will go there, H minus. So Cl will be removed. So it will first convert it into aldehyde. Then again it will provide H minus. So it will again open up. So this will convert it into 1 degree alcohol. Okay. So take your time. This is important. Take your time. Understand this properly. So LiAlH4 will convert into 1 degree alcohol acyl chloride. It will convert into that. Now anhydride will be the same. Again H minus will attack here. This will leave. So this will be first converted into aldehyde. Then again H minus. So this will be converted into 1 degree alcohol. Again. So this symbol means same. So this will be converted into 1 degree alcohol. Same for so point is these both are converted into aldehyde. Then aldehyde is converted into 1 degree alcohol. So aldehyde itself will be converted into 1 degree alcohol. So this is also same. Right? So all of these will be 1 degree alcohol. Now ketone will be converted into 2 degree alcohol. Why? Because H minus will attack here. This will open up. So this will be 2 degree alcohol. Na? Right? So 2 degree alcohol. Now ester, same mechanism, 1 degree alcohol. Acid, same mechanism, 1 degree alcohol. Amide. What will amide do? See, NH2. So H minus will go here. So it will remove it to be amine. So if this is happening, then again aldehyde is formed. Right? But this aldehyde can be again reduced to alcohol, but this does not happen because here amine is written. So you need to understand that something else is happening, right? Something else is happening, not the usual mechanism is happening. So you don't need to remember the mechanism here. You will just remove this double bond O. So it will just be formed like NH2. That's it. 1 degree amine. That's it. Okay. So amide will convert into 1 degree amine by LiAlH4. Now let's move to NaBH4. So NaBH4 is milder reducing agent compared to LiAlH4. Okay. Okay. So here what will happen? It will again convert acyl chloride into 1 degree alcohol, but it does not reduce your anhydride. So LiAlH4, remember like this. If you are not able to remember the order first. LiAlH4, NaBH4, LiBH4, dival H. LiAlH4, NaBH4, LiBH4, dival H. This is the order. So first one will be all tick. First one will be all tick. Second one will be this one tick, this one cross. So anhydride won't be affected by NaBH4. You don't need to know the mechanism or reason. That is not what we are going to discuss here, because we have to revise this, right? We are not going too deep into this. Then aldehyde and ketone, again 1 degree alcohol, 2 degree alcohol, simple. Then ester, no. Acid, no. Amide, no. Okay. Okay. So you can remember this, that the reagent below LiAlH4, that is NaBH4, will only have 3 ticks. First is acyl chloride, second is aldehyde, third is ketone. Simple. Okay. So 1 degree alcohol, 1 degree alcohol, 2 degree alcohol. Simple. Then LiBH4. So third reagent. It is similar to LiAlH4. This is similar to LiAlH4. So you can also make your own notes and you can swap this. You can write LiBH4 above, NaBH4 below. Whatever makes you understand, whatever makes you learn faster, it's fine. Okay. So this is similar to LiAlH4. It reduces everything except acid and amide. Reduces everything. So these 3 will be reduced to 1 degree alcohol. This will be reduced. Ketone will be reduced to 2 degree alcohol, obviously. And this again, ester will be reduced to 1 degree alcohol. But acid and amide are not reduced by LiBH4. Simple. So remember this, LiAlH4 reduces everything. LiBH4 does not reduce the last 2, amide and acid. Okay. Then comes NaBH4. NaBH only reduces 3, acyl chloride, aldehyde, ketone. Now coming to dival H. So dival H is also a mild oxidizing agent. Mild oxidizing agent. So what happens is it reduces, not oxidizing agent. This is, what am I doing? Reducing agent. Mild reducing agent. So what happens is, the only thing it does not oxidize or reduce is acid. So this you have to remember by dival H. So dival H, okay, you can remember like this. So acid is the thing that gives H. So dival H. So H and H. So it does not reduce acid. Simple. So acid gives H. So dival H has H. So it does not reduce acid. Simple. Rest other it will reduce, but it is mild reducing agent. So mild reducing agent means it will just go up to first step. It will not go up to second step. So basically here what is happening? H minus will attack and will convert this into aldehyde, I told you. But then again H minus will attack to convert this into 1 degree alcohol, right? But dival H does not go up to second step. It will just convert this into aldehyde. See, it will just convert this into aldehyde. Simple. But then when you will react it with aldehyde specifically, then it will convert to 1 degree alcohol. Ketone, 2 degree alcohol. Again, ester will be aldehyde again. So it won't go up to alcohol, right? And acid, it won't reduce. Then this amide, it will go to aldehyde. So amide also dival H goes to aldehyde. So there are only 2 species which are reducing amide. You can remember that easily. One is LiAlH4, second is dival H. So LiAlH4 completes the reduction. So it completes it into amine, NH2. Simple. But this aldehyde, this dival H will convert it into aldehyde. So I think this is simple now. Is it simple? See this. For 1 minute, just see this table. I have made this very in a very compact way so that it can help you memorize things. See this table. What will reduce what? Why written in this? अरे वो अनूप वो लिख दिया था उस वक्त. I didn't think about writing, but you can write LiBH4 above NaBH4. You can do that. Okay, चलो ठीक है. Now we will see 3 other types of substrates: nitro substrate, cyanide substrate, imine. Imine means amine is CH2NH2, imine is CH double bond NH, right? So this is imine. So now we will again see 4 different types of reagents. Because I wrote these reagents in this order, here also I wrote this in this order. Okay, okay. So first LiAlH4, strongest reducing agent. What will it do? Reduce everything. So NO2 into NH2, NO2 into NH2. 3 other reagents that will convert NO2 to NH2. We saw Fe, Zn, your tin, right? So FeCl2, ZnHCl, tin HCl, right? So we saw in the previous slides, right? So again NO2 will be converted into NH2 by LiAlH4. Okay, then cyanide. So cyanide will do what? Convert into amine. So hydride will attack here, H minus will attack here. So this will open up. So if this will open up, it will take H plus. Again H minus will attack here. This will again open up. This will take H plus. So basically this will again convert into amine. Simple. Now imine, again hydride will attack here. So again, so imine, see, its intermediate will be imine only. Attack hydride here. So R CH double bond NH. So that is imine na, this only na. So if it is converting this into CH2 and NH2, so this will convert this also into CH2 NH2. Simple hai na? Simple hai na? It is not that much difficult. It is not that much difficult. Okay. Okay. Then NaBH4. So NaBH4 is very weak reducing agent as compared to LiAlH4, right? So it will just reduce imine. Similarly LiBH4. LiBH4 will also just reduce imine. That's it. Dibyl H on the other hand reduces only cyanide. No nitro, no imine. Okay, and why does it do that? It reduces cyanide to this. It is mild reducing agent, so it won't complete the reduction, obviously. Like in the previous one, it was reducing to aldehyde, not to alcohol. So it will reduce to imine, but it can't reduce imine further. So you will do hydrolysis of imine. So if you are doing hydrolysis of imine, H2O will attack on this. This will open up. Okay, this is NH here. यहाँ पे NH आएगा. ठीक है. So this will open up. So this will take again one H and one OH will be there. So here NH2 will be there. Okay, single bond. So this nitrogen will take again one hydrogen from here. This will come here and NH2 will go. So basically aldehyde will be formed, NH3 will be formed. Okay, okay. After hydrolysis, but dibyl H gives imine, cyanide to imine. That's it. So you can see this table as well. So basically these 2 tables, if you remember, you can do a lot of things in this chapter. Okay, whole chapter is in these 2 tables and one more table we'll see. Is it fine? देखो. Now, if there is 3 degree benzylic carbon, see, so here no oxidation to benzoic acid. So you can't oxidize it to benzoic acid, but you can oxidize this to CHO, aldehyde. What? This Itard reaction. What is happening in Itard reaction? See, CH3 is toluene, benzene CH3 is toluene. So CrO3, CH3COO2O. So basically CrO3 means chromium in +6. Here also chromyl chloride, chromium in +6. In both of them, chromium is in +6. ठीक है. So in both of them, chromium is in +6 and you are taking the conditions in which water is not present. See, in the first step, water is not present. This is anhydride. In the first step, water is not present. This is CS2. carbon disulfide. In the second step only you are doing workup, H3O plus. So in the first step, no water is added. So if no water is added in the first step, then acidic workup is done. So this will be converted into benzaldehyde. And this chromyl chloride reaction is known as IISr reaction. Okay? Tell me, IISr reaction. Fine. So if you see chromium 6 plus, you see anhydrous situations, and then you see acidic workup, you have to convert toluene into benzaldehyde. Simple. Simple. ठीक, चलो बताओ. Major product P formed in the given reaction. So first is alkaline KMnO4 heat. Alkaline KMnO4 heat, remember, it gives the product of oxidative ozonolysis, if you remember this. Oxidative ozonolysis and H3O plus. Do this question. Do this question. Give me the answer, I am waiting. Wait a second here. Wait a second. So what will be the answer? What will be the answer? Alkaline KMnO4. What will be the answer? बताओ. बताओ बताओ. COOCH3. So this is your what group? This is your ester group. This is your alkene. Right? This is normal alkane. So what will happen? What will happen? बताओ भाई, बताओ. नो वन इज आंसरिंग यार. कोई तो आंसर करो भाई. एटलीस्ट समवन आंसर यार. कोई तो आंसर कर दो भाई. See what happens. See, so obviously you have to do oxidative ozonolysis first. So it will give the product of oxidative ozonolysis. Oxidative ozonolysis. Okay, so do this, but this will be aldehyde. This will be aldehyde, CHO. So you have to oxidize it. So this will convert into COH. So this group will convert into COH, right? 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 Any other thing? Any other thing? Obviously. Obviously. So this whole group and this whole group, this will be converted into COH. So basically the carbon attached to the benzene ring, if it has a hydrogen, carbon attached to benzene ring, if it has a hydrogen atom and you are reacting it with alkaline KMnO4 and heat. Alkaline KMnO4, heat, and then you are doing acidic workup. H3O positive. So what will happen? This whole thing will be removed. This whole thing will be removed, and this will be converted into COH. This will be converted into COH. So this will be this carbon will be converted into COOH. As simple as that. So your product will be COOH, COOH, COOH. बताओ, बताओ, is this fine? बताओ. Olivia, this is the answer. Okay, this is the answer. देखो, now let's move on to, so this is the role of alkaline KMnO4. You can make a note here. You can make a note here. So these are the things that I'm doing through questions. I'm not, telling everything through theory. So these are the things that I'm telling through questions, na? Okay. So basically, you can make a note here. Okay. Chalo. So strong oxidizing agent, mild oxidizing agent. So obviously, we have seen the reducing agents. Now we'll see the oxidizing agents. So obviously, this was oxidizing agent. I gave the quotient before. So this is oxidizing this carbon to COH, oxidizing this to COH, this to COH, right? So this is oxidizing agent only. So now let's see different types of oxidizing agent. So obviously chromium in +6. Chromium in +6. Where did you see? ITARD reaction. Chromium in +6. See. So it is also oxidizing this CH3 into CHO, right? So this is a oxidizing agent. See. So chromium in +6 plus H2O. So if water is present along with chromium in +6, it will be strong oxidizing agent. So chromium CrO3 H plus H2CrO4. What is H2CrO4? So this is CrO3 plus H2O only. Okay, so this is H2CrO4. Same. Okay, K2Cr2O7 dichromate H plus CrO3 aqueous H2SO4 acetone. This is Jones reagent. So if Jones reagent is written or this is written, whatever is written, it's fine. Okay, so now mild oxidizing agent for chromium is CrO3 in non-polar solvent. Okay, in water it is strong oxidizing agent, but in non-polar solvents it is weak or mild oxidizing agents like CS2, CCl4. Okay, so you have to keep that in mind. So pyridinium chlorochromate, PCC is also mild oxidizing agent. Pyridinium dichromate, you don't have to know the structure of this, it's fine. PCC or PDC will be written. So that is, these are weak oxidizing agents or mild oxidizing agents. Okay, now MnO4 minus in acidic or basic medium, whatever it is. So KMnO4 H plus heat, KMnO4 OH minus heat. So these are strong oxidizing agents. That is why they completely oxidize the carbon. Alkaline KMnO4 in basic medium plus heat. देखो, even if it would have been a acidic medium, it would still have been a strong oxidizing agent. Then Collins reagent is there. Collins reagent is again a reagent of chromium. So chromium O3 CrO3, pyridine, solvent is CH2Cl2. Okay, so this is Collins reagent. So any of these is mild oxidizing agent, any of these is strong oxidizing agent. ठीक? Now formation of benzoic acid. So I told you this, that 3-degree benzylic carbon won't be converted into benzoic acid or benzaldehyde, because here we were converting into benzaldehyde, but 3-degree carbon won't be converted into benzaldehyde. Okay, or benzoic acid. So this is what? This is oxidation only, na? This is oxidation, so it won't be oxidized to benzoic acid or benzaldehyde. But here, ITARD reaction will oxidize this, and there you can see benzene to benzoic acid. So basically, see, अभी मैंने क्वेश्चन करवाया वही मैंने लिखा. That is what I have written. Any carbon attached to the benzene that contains hydrogen, contains multiple bond, contains carbonyl group. Any of these. So this will be converted into COH by KMnO4, basic KMnO4. Example, see, CH3 is attached. So this carbon has hydrogen. This carbon has 2 hydrogen. Okay. So this will also be, everything will be removed and this will be converted into COH. Simple. You don't have to remember anything else. This carbon has double bond. So this will be removed, COH. This carbon has carbonyl group. So everything will be removed, COOH. This carbon has hydrogen. Everything will be removed, COH. Simple. Simple and simple. fine, benzoic acid will be formed. बताओ, is it fine? हाँ अरे यार ठीक है, एल्कलाइन KMnO4 ठीक है चलो हाँ तो करो product P in the above reaction. वैसे reaction is given below but I have written above reaction. I don't know what is happening. So diable H, toluene 78 degrees Celsius H3O plus. Do this. Do this. Do this. So basically what will diable H do? What diable H is a mild oxidizing agent. So what can be oxidized here? What can be oxidized here? So there is a ester, right? There is an ester. So diable H does not oxidize what? Does not reduce what? This is a mild reducing agent. Does not reduce what? It does not reduce acid, but it reduces ester, and it reduces ester to what? Aldehyde. It reduces ester to what? Aldehyde. So basically hydride will be going there, right, and this will remove, right? That is what will happen. So the first product will be this OH 1 2 3. After that they have given what? H3O plus. So acidic medium, acidic workup. What will happen then? Can anybody tell me? Can anybody tell me? Is this the final product or something else will happen here? Is this the final product or something else will happen? वैश क्या है वर्षा यादव what are you saying? So is this the final product or something else is happening? बताओ. So this is the final product, nothing else will happen. So obviously this is CHO. What will happen? Nothing will happen. There can be no intramolecular reaction, there can be nothing. So this is just simple question. Sometimes that is the trick. I was asking you the question why? Because sometimes in the question in the exam they will give you such a big question and you will think it can't be that simple. There might be something else. It happens na? It happens na? So you might be like, there might be something else. There might be something else. Something else might be happening. This can't be like such a big substrate, such a big reagent. So like in IIT maybe this will be asked in theoretical way. So you will be like, this can't be so simple. But sometimes the questions are that simple if you just know things. Okay. Chalo. Major product NaBH4 is given and substrate is given. Substrate is given. So basically ketone is given, alkene is given and imine is given. So NaBH4 does what? Remember, try to remember. I won't go back. I also don't remember, but let's try. So NaBH4 only reduces three species. First, acyl chloride. Second, ketone and aldehyde. So obviously it will reduce this. Alkene it won't reduce obviously. So NaBH4 reduces imine or not? It reduces both NaBH4 and LiBH4 reduces imine to amine. So obviously your final product so basically ketone into 2 degree alcohol and this into amine NCH3H. Okay, so this will be the product. No, this will be the product. or anything else will happen? Batao. Again, I'm asking the same question. Will anything else happen? It was very simple, na? Nothing else will happen, yaar. Yahi rahega. This will be the answer. Okay. Okay. Chalo. Major product in the following reaction. So NaOH is there, heat is there. So OH minus and heat is there, and there is ketone. Then there is aldehyde. Okay. So what can happen? OH minus and heat. What will happen? बताओ. What will happen? So what reaction is this? Arey garibo, what reaction is this? Suraj is saying aldehyde ketone as अच्छा नहीं वो उसका था. अरे this is your most famous reaction of all यार. Most famous reaction. Aldol condensation. Okay, so what is happening here? In aldol condensation, a particular carbonyl compound with enolizable protons. So this is carbonyl compound with enolizable protons. Hydrogen is present here, hydrogen is present here. So these hydrogens can be enolized. These hydrogens can be taken up by the base. Can be taken up by the base. Okay, so again, so this is also CHO. Okay, so this is also an enolizable proton, right? This is also an enolizable proton, right? So basically it can attack here as well. So basically, how many? 1, 2, 3. You have to see CH3, CHO, CHO, and C double bond O. So negative can be made here, negative can be made here, negative can be made here. So if negative will be made here and it will attack on this carbon, so this will be 1, 2, 3, 4, 5, 6, 7. So 7-membered ring will be formed. If negative is that. So 1, 2, 3, 4, 5-membered ring is formed. If this is negative, so it will attack here 1, 2, 3, 4, 5. So this will also be 5-membered ring. But the point is the negative formed here will be not that much stable. It's okay, you can do whatever you want to do. But the point is, because negative formed here, there is a CH3 group, no? There is a CH3 group here. Okay, so ठीक है. So what you will do? You will attack from here. See, or wait. So you will attack from here on this. So stability of ring. Always remember 6-membered ring is more stable, 5 than 7. Okay, so 5-membered ring is more stable than 7. So in intramolecular aldol, if 5-membered and 7-membered are formed, always make 5-membered. Okay. So basically 1, 2, 3, 4, 5. So do this 1, 2, 3, 4, 5. So if this is my first carbon, so COCH3, right? So 1, 2, 3, 1, 2, 3, 4. On 4 there is a methyl, then 5th. So this is OH. Okay, this will be OH, then there will be a hydrogen here. Okay, so there is hydrogen here as well, but you have to remove this because the product of aldol is alpha beta unsaturated carbonyl. Alpha beta unsaturated carbonyl, right? If you will remove from there, so this will be alkene here. So alpha is this, beta is this. So your alkene should be between these, not between those. So that will be beta gamma. So that does not happen. That does not happen. So what will happen? This OH will be removed, okay, and hydrogen will be removed, and the final product will be COCH3. Okay, so obviously a product can be formed from here as well. 5-membered product can be formed from here as well. So both products can be formed. Okay, the point is that, but if this is the product that is formed, this will be the product that will be formed. Okay, fine. Batao. So intramolecular aldol reaction. This is very important. This is asked almost regularly. Aldol reaction. So this is intramolecular, right? Right? See, aldol condensation, enol or enolate. So basically, when this hydrogen will be taken, so this will be formed enolate or enol, whatever. So this attacks on the carbonyl to produce on another carbonyl, whatever carbonyl it will be, maybe the same molecule, maybe the different molecule, whatever, to form alpha beta unsaturated carbonyl, stability of ring, 6-membered, 5-membered, 7-membered, aldol reaction versus aldol condensation. Now, condensation means, you have to remember this, not remember this, understand this. Condensation means removal of water here. Removal of water. So that last step, this step, where water is removed, this is condensation. Condensation. Okay, if this step does not happen, if this is the product that is being formed, if this step does not happen, so then it will be aldol reaction, not condensation. Normal aldol reaction. And when will that happen? If this heat is not provided. If something like water or like H plus is not provided, like if they are not providing any heat or something, they are not providing any acidic workup, nothing, they are just writing NaOH, just NaOH, right? So obviously they don't want you to do condensation, because condensation happens at high temperature. Okay, okay. So in condensation, in aldol reaction, condensation does not happen. So see what is asked. Does not happen. ठीक? बताओ. बताओ. How we assign groups while cyclizing the product? अरे अनुष्का, देखो, अच्छा जिसको भी, those who have a problem in cyclizing, see properly. I will explain again. Okay, learn from here so that you don't do any mistake in the exam. I will give 2 minutes, it's fine, but point is you need to understand. So this is aldol condensation. So let's say this is CH3 CHO then double bond O. So let's say an enolate will be formed from here, this carbon O minus, this is the first step, that hydrogen will go and enolate will be formed. So you number this, first you number this, which carbon is attacking, number that one, the carbon that is attacking, number that one. So 1, 2, 3, 4, and the carbon at which that carbon will attack, number that 5. Okay, last number 5, 6, whatever. So here 5-membered ring is formed, so 5 number is there. Okay, so then this will attack here, this will go back, okay, and here it is C double bond O H. So this bond will be opened up, right? This bond will be opened up. Now you have to cyclize. How you will cyclize? You know that 5-membered ring is formed, so make a 5-membered ring. I will tell you most simple thing. Okay, don't have to see these things. Just make a 5-membered ring first. 1, 2, 3, 4, 5. Made it. So you know your first carbon is this. You make any carbon as first. I generally make this carbon as my first carbon, this above carbon, because that is the simplest thing to do. So this is first, this is second, this is third, this is fourth, this is fifth. You can do above, or you can do reverse numbering as well, you can do this numbering as well. Right now it does not matter. Okay, so first carbon, on this first carbon, which group is there? Which group is there? C double bond O CH3 group. C double bond O CH3 group, right? So make this C double bond O CH3. Then second carbon there is nothing, third carbon there is nothing. On fourth carbon, what is this? Methyl, CH3. So CH3. On fifth carbon, this is fifth carbon. Fifth carbon will contain OH now. So OH. Simple. So then do the condensation reaction. This H and this OH will be removed. So this will be CO CH3. So this is alpha, this is beta. Alpha beta unsaturated ketone CH3. बताओ. Now understood how to do this? बताओ. हाँ यार, जो भी है गुलजार, it is enough. Okay, understood. Now let's move to next. So this is aldol condensation versus aldol reaction. Then benzene to benzaldehyde. We have seen toluene to benzaldehyde, ITARD reaction. This is benzene to benzaldehyde. When I am doing this, I make a connection with previous reactions as well, so that you can remember instantly. Okay, yeah, we did ITARD reaction where toluene converted into benzaldehyde, right? So then we did reaction with KMNO4 in alcoholic medium where benzene or carbon attached to benzene converted into benzoic acid, right? So here now benzene will be reacted to with reagents to convert into benzaldehyde. So all the reagents are similar. You don't have to remember anything. See what happens here. So HCN, HCl-AlCl3, KCN, HCl-AlCl3, CO, HCl-AlCl3. So HCl-AlCl3 is permanent for converting benzene into benzaldehyde. Done? Then this can be HCN, KCN, CO. This can be HCN, KCN, CO. So basically, why they have CN, CN and CO? Because in benzene you have to add another carbon for COH. So this another carbon will come from this. So you can remember like this: HCN, KCN, CO, HCl, AlCl3, HCl, AlCl3, then H3O plus is acidic workup. Here this is Gutterman reaction. So basically there H3O plus is not needed as such, right? So basically, so Gutterman-Koch reaction where CO and HCl plus AlCl3 is given, so you don't need to revise any mechanism or something. If these reagents are given, make benzaldehyde. Simple. Okay. Chalo. So consider the following reaction. Alkyne is given red hot Fe tube 873 Kelvin CO HCl AlCl3. देखो CO HCl AlCl3 कहाँ है? CO HCl AlCl3 product. The number of sp2 hybridized carbon atoms present in the product is, बताओ भाई, बताओ. कार्बोक्सिलिक एसिड बॉन्ड फॉर्म व्हाट? अच्छा उसमें, हाँ ठीक है, बताओ. डू दिस क्वेश्चन. Do this question, bhai. If you just remember this lecture, na, if you have not studied organic complete year, if you just remember the points which I have told or which I will be telling in this entire lecture, you can easily do 3 to 4 questions of your organic chemistry in your IIT as well. In NEST, obviously more questions will come, so you will do more, obviously. So in IIT, you can easily do 3 to 4 if you have not studied organic that much, if your basics are not even clear. If you just remember these things, मतलब आई थिंक कि कोई इतना पागल होगा रट के ही चला गया पूरा लेक्चर, तो 3-4 क्वेश्चन तो ऐसे ही हो जाएंगे, ट्रस्ट मी. ठीक है, देखो, अरे ये तो दिस इज तो रेड हॉट Fe. सो this converts into benzene na, this converts into benzene. So benzene plus CO HCl AlCl3, so benzaldehyde, simple. Benzyl dehyde COH. Now sp2 hybridized carbon. So all these carbons are sp2 hybridized. All the carbons are sp2 hybridized. Benzene has 6 sp2 hybridized carbons. So now this C double bond O is also sp2 hybridized. So 7 sp2 hybridized carbons. बताओ, ठीक ठीक ठीक. Chalo, major product you have to find. So here acid is there, here ester is there, LiBH4 ETOH H3O plus. बताओ भाई, बताओ. So LiBH4, remember what does LiBH do? What does LiBH do? Remember the two species which it does not interact with, which it does not reduce. What are the two species? LiBH4. What are those two species? Remember. अरे आदित्य, तू यहाँ क्या कर रहा है भाई? पढ़ ले होमी में जाके. SK Parveen. Yeah, see, you don't have the time to watch all the lectures of crash course. Obviously, you are preparing for NEET, so I think your basics would have been clear. So you can use rescue series, our rescue series, as well as our MAHA marathon, as well as 50 most important questions. So these things you can use. Don't watch the complete crash course lectures. Okay. Chalo. So what will happen? अरे भाई LiBH4 किसको करता है? एसिड को it does not reduces acid. It does not reduces acid. So basically it reduces CO2 ET. So it will reduce completely into aldehyde. It will reduce completely into aldehyde, COOH, then CHO, right? That is what happens with LiBH4, right? Right? So tell me, is this fine? Is this fine? बताओ. Acid amide. Acid amide? Amide? Where is amide भाई? अच्छा, किसको नहीं करता? हाँ, एसिड अमाइड, ठीक है. एस्टर टू 1 डिग्री अल्कोहल. अरे एस्टर, हाँ ठीक है 1 डिग्री अल्कोहल. मैंने किया नहीं. एस्टर को पहले वो CHO में करेगा, देन इट विल कन्वर्ट इट इनटू 1 डिग्री अल्कोहल. सही बात है, मैंने पूरा नहीं किया था, सॉरी. सो COOH, सो दिस विल बी 1 डिग्री अल्कोहल. ठीक है. सो इफ दिस इज 1 डिग्री अल्कोहल, so will there be esterification? Will there be esterification? Can esterification happen in H3O plus? बताओ. So 1, 2, 3, 4, 5, 6, 7, 8. 8-membered ring is formed. No. Okay. So even if it wants to do that, it won't form. Okay. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7-membered ring is not very stable. Even if it is forming, then ठीक है. यहाँ पे for esterification they need to give ठीक है, एस्टेरिफिकेशन नहीं होगा, ठीक है, छोड़ो, ठीक है, चलो. Now coming to B2H6, another reagent. So what type of reagent is this? This is reducing agent, but this is electrophilic in nature. Why? Because B2H6 means two molecules of BH3 and BH3 has incomplete octet, right? So because of this incomplete octet, here nucleophile can interact or base can interact or whatever. So this is electrophilic reducing agent. Okay, so the substrates with these reagents found difficult to reduce. Which reagents? These reagents. See, these are the substrates which have very less electrophilicity. These are the substrates which are less electrophilic, right? So if you can see, most of like NaBH4 can't reduce these three. ठीक है, LiBH4 cannot reduce these two. Like diol H cannot reduce acid, right? So these are the substrates which are difficult to reduce because they are themselves nucleophilic. They are less electrophilic and they are nucleophilic. So basically, to reduce them, you need an electrophilic reagent. So electrophilic reagent is what? B2H6, BH3, incomplete octet. No? सिंपल है ना यार, इतनी तो दिक्कत ही नहीं है, देखो. सी, सो सबसे पहले ही वी स्टार्ट विद एसिड. सो एसिड को इट रिड्यूसेस इनटू 1 डिग्री अल्कोहल. सिंपल, खत्म. देन कीटोन 2 डिग्री अल्कोहल, ऑब्वियसली. एल्डिहाइड 1 डिग्री अल्कोहल. इमीन to amine. Okay, so these are the reactions that it will do. Okay, so acid to 1 degree alcohol, obviously ketone to 2 degree alcohol, then aldehyde to 1 degree alcohol, imine to amine. Simple. ठीक. Rosenmund reduction. चलो, एक नया name reaction is there. Rosenmund reduction. So basically acyl chloride is converted into aldehyde, benzaldehyde, using what? H2PD, carbon CaCO3 BaSO4. Okay, so Lindlar's catalyst was something like this, if you remember. BaSO4, CaCO3, Lindlar's catalyst, H2PD. So this is kind of Lindlar's catalyst only, na? This is Lindlar's catalyst only. So basically acyl chloride, when you react with Lindlar's catalyst, you will convert it into benzaldehyde. Simple. ठीक है? कोई नहीं अनूप यार, कोई नहीं. ऑर्थोसाइक्लाइजेशन, अरे प्रीवियस वन नहीं यार, उसको I think उसमें there should be something other that should have been given for cyclization, for esterification. Okay, because esterification, that is the H3O plus that was given, that was acidic workup. So acidic workup does not do esterification. You have to provide proper acidic environment, like proper acid, right? So basically that happens. So now Stephan aldehyde synthesis. So again we are synthesizing your aldehyde. So what is happening? See, this is very important. See properly. So point is SN is a metal. It has a tendency to give electrons. So it will give 2 electrons to 2Cl. So this will convert into +2 and 2Cl minus. So SnCl2 will be formed and these 2 hydrogens will be evolved. Okay, and these 2 hydrogens are strong reducing agent. Hydrogen is a reducing agent, right? So then if you again add 2 HCl, so this will again give 2 chlorine, 2 electrons to 2 chlorine. So basically this will convert into +4 and bond with 4 chlorine. So basically SnCl4, and it will again give 2 hydrogen. So basically if Sn converts into SnCl2, if Sn and 2HCl is given, it will give 2 hydrogen. Simple. And form this SnCl2 and 2 hydrogen. ठीक. If SnCl2 and HCl is given, if this is given, it will again give 2 hydrogen. Obviously SnCl will again give 2 hydrogen, but if Sn and HCl is given, complete Sn and HCl is given, like not 2 HCl nothing, but Sn and HCl, just like this. See, Sn and HCl, not 2 HCl, not 3 HCl, nothing. So that means HCl is in excess. So basically it will convert into SnCl4 and will give 4 hydrogen. So 4 hydrogen. So it will reduce this alkyne. So these 2 pi bonds will be broken and 2 hydrogen here, 2 hydrogen here. So amine, complete reduction. ठीक. SnCl4 and basically 4 hydrogen. Okay, so this is complete reduction. So after this complete reduction, so if SnCl2 and HCl is formed, like given SnCl2 and HCl, so it will give 2 hydrogen, right? I told you, no, it will give 2 hydrogen. So if 2 hydrogen is given, so obviously only one bond will be broken. So 1 hydrogen and one this nitrogen and hydrogen will be formed. So basically this is imine, right? So this will give only 2 hydrogen, right? So when you will do hydrolysis of imine, what happens? It converts into aldehyde. So this is Stephen's aldehyde synthesis. ठीक. So hydrolysis of cyanide, hydrolysis of imine, they all convert into aldehyde. ठीक. And why does this happen? Why does complete reduction happens? Because here it will give all the hydrogens possible. Here it will only give 2 hydrogen. नहीं है, नहीं, ठीक है. ठीक, बताओ. ठीक है. So which of the following reaction sequences will not give acetophenone as the major product? बताओ भाई. What is the answer? पता नहीं. So I am giving you 1 minute to do this question because such type of questions are lengthy. So I am giving you 2 minutes, 1 minute maybe to do the question. तब तक मैं solution देख लेता हूँ. हाँ, one student has given the answer option D. अरे ठीक है. So what will happen here? So acetophenone, what is acetophenone? This is acetophenone, CH3, CO, CH3. This is acetophenone. So what will happen? बताओ. अरे will not give पूछा है, will not give पूछा है, will not. Okay, so do this. This is Grignard reagent, so it will attack here. So this will convert into alcohol. But then this is 2-degree alcohol. So what will happen? What will be formed here? Let's see. For A, what will form? pH, Me, 2-degree alcohol. So this is chromate, Cr2O7 plus 6. So basically this is strong oxidizing agent. So Cr plus 6 will convert it into acetophenone, ketone. 2-degree alcohol will be converted into acetophenone, ketone, na? So basically this will give, okay. Then pH MgBr, pH will attack. So again this will be formed now, Me, pH, OH. So now PCC is a mild oxidizing agent, but again it will convert 2-degree alcohol into ketone, na? Me, pH. So basically this will also convert into acidophenone. Then 2 MEmGBr. So first it will attack here, it will go up, it will come back, OET minus will leave. So in C, by first Me addition, the product that will be formed is Me. So acidophenone is formed here, but again they are adding one more MEmGBr. So when one more MEmGBr will be added, so this will be 3-degree alcohol. MEOH. So this will not give. We'll see this also. So MEmGBr. So Cl will be removed and nothing. It's okay. CdCl2 is a catalyst, like a catalyst only. So this will again form acidophenone. Okay. 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 So basically C is your answer. Will not give. ठीक है, बताओ. ठीक है, हाँ सबका सही है भाई. ठीक है, देखो. So this substrate is given CnOCH3, PHMGBr is given, dry ether is given, one equivalent, obviously Grignard reagent, dry ether, and H3O plus is given, major product. Find the major product. Cyanide is given, MEmGBr is given. Do this. And there is hydrolysis as well. So अरे देखो this there is a, अच्छा वो हो ही रहा था क्या, धीरे चल रहा है, ठीक है. So what is happening here? C triple bond N OCH3, okay, PHMGBr. So pH will attack here, this will open up, so this will be N minus, so N minus MGBr. Okay, pH double bond N minus MGBr plus, okay, OCH3. So this is happening, one equivalent is provided, after that they are giving hydrolysis, H3O plus. Okay, so you will break these bonds. So first bond will break, so OH will here, H will be here. Okay, then again what will happen? See, OCH3, C, PH, OH, NH, NH minus MGBr plus. Okay, so then again it will take hydrogen from here, this will remove, so this will be COPH OCH3. Okay, बताओ, is this fine? अरे मनीष यार कोई नहीं, ठीक है. पार्थ भैया का थोड़ा गले का प्रॉब्लम है ना, तो वो ही कांट टेक सच अ लॉन्ग क्लास, सो वो दिक्कत है, ऐसा कुछ नहीं है. ठीक, देखो चलो. सो विच ऑफ द फॉलोइंग विल नॉट फॉर्म एसिडल्डिहाइड, करो. सो दिस इज पैलेडियम एंड कॉपर. ओके, कॉपर 573 Kelvin, CrO3 H2SO4 double H and H2O. So acetaldehyde, CH3COH. So this you have to form. Okay, So which will not form? बताओ. Second and third step again. अरे इसमें कुछ नहीं है. This is just hydrolysis ना Olivia. ये तो imine है ना. Kind of this is imine only ना NH. So इसकी hydrolysis करोगे तो aldehyde आएगा ना पहले. This is imine only. This is just N minus, right? So N minus is satisfied by Mg plus. That is the thing. That is the thing. So you can remove the minus. You can add H first. So this will be like this, na? NH. You can assume it to be like this. So if you are doing hydrolysis, this will take OH. This will take H. So basically, this will be OH and NH2. Right? I am assuming. Let's remove minus charge. I am just assuming. So this will take hydrogen from here. This will remove this, and pH is already there. Right? So CO pH just like imine here, just like imine, nothing else. Okay. बताओ. Answer. आंसर भाई आंसर. देखो बताओ जल्दी. देखो, what happens in palladium and copper? What happens in palladium and copper? See, so point is if there is a alkene, CH2 double bond CH2, you add palladium 2 plus and copper. So this palladium interacts with the alkene. How does it interact? How does it makes the bond? You don't have to study that. That is very advanced concept. But this interacts with alkene, and after interacting with alkene, what it does is CH2 CH. So there is a hydrogen attached to this. So between this hydrogen, it attaches what? O. So this will be like OH. So it helps in attaching oxygen between hydrogen and carbon bond. Okay. So this will happen when you will add palladium and copper to our alkene. And if this happens, then tautomerism can happen, na? See? So this will take this hydrogen. So this will be CH3 COH. So acetaldehyde will be formed here. So this will be formed here. Now copper. What does copper do? For alcohols, what does copper do? Do you remember? Copper. बताओ भाई. What does copper do? कहाँ लिखवाया था मैंने? कहीं तो लिखवाया था मैंने. बताओ किसको याद है? What does copper do? बताओ. What will copper do? अरे copper will do the same thing. देखो, copper at high temperature with 1 degree alcohol will do the same thing. It is a mild oxidizing agent, no? It behaves as mild oxidizing agent. So 1 degree alcohol it converts into aldehyde, 2 degree alcohol it converts into ketone. But there I wrote 300 Kelvin temperature. Here it is even higher than that. So obviously it will convert into CH3, C double bond OH. Simple. But here, see, this is CrO3 H2SO4. This is strong oxidizing agent, H2SO4, right? So 1 degree alcohol will first convert into CH3COH, then it will convert into CH3COOH. So acid will be formed. So the answer is C, right? Here dibyl H. So dibyl H, your dibyl H reduces CN to imine, right? But then hydrolysis is also there. So you convert this into amine, CH3, CH, CH double bond NH, okay? Then hydrolysis, H2O. Olivia, just like that, hydrolysis. See, so OH will be here, so NH2 will be removed, so aldehyde will be formed. Okay, aldehyde will be formed, right? Right. So again, CH3COH. So this is also correct, basically. So answer is this, C. Okay, बताओ. Catalytic dehydrogen and dehydrogenation. हाँ जोन्स, अरे ये जोन्स नहीं है, दिस इज नॉट जोन्स, दिस इज नॉट जोन्स. वेयर इज एसीटोन रिटन हियर? दिस इज नॉट जोन्स रिएजेंट. गरीबी मत दिखाओ, करो. So again, rhodium catalyst H2CO, major product of the reaction. What type of reaction is this? What type of reaction is this? बताओ भाई. करो तुम, ये मैं आया, करो थोड़ा सा नेचर्स कॉल. हुआ कि नहीं हुआ? नहीं हुआ? अरे basically this H2CO rhodium catalyst, what does it do? It does add a formyl group. Formyl group means CHO. देखो कैसे? CO is there, you don't need to know the exact mechanism. This alkene will attack at CO. Okay, so if this alkene will attack at CO, positive will be here, so hydrogen will be attacking at there. Okay, so basically what will happen? CH2 CH CH2 CHO. So basically one extra carbon will be added. Okay, so this is known as hydroformylation or addition of formyl group to alkene. So if this reagent is seen H2CO and rhodium catalyst, then make sure that you will add CHO group, formyl group. This is formyl group. Okay? Okay? अरे ब्यूटेनल नहीं भाई, 1 2 3 4 पेंटेनल. Okay, this will be pentanol. चलो. So which of the following reactions will yield benzaldehyde as a product? So benzaldehyde as a product. बताओ. बताओ बताओ. I am giving you some time. So do this. Do this. It's a lengthy question maybe. I will give you 1 minute. Do this. So ऐसे ही organic करने में थोड़ा it's like good ना, that basically you are doing it via quotients, right? देखो फर्स्ट में तो देयर इज SOCl2, फर्स्ट में तो देयर इज SOCl2, राइट. सेकंड में CrO3 इज देयर, थर्ड में NaBH4 इज देयर. सो आइडेंटिफाई द रिएजेंट्स. SOCl2 आई टोल्ड यू ना, SOCl2 विल रिमूव दिस OH. देखो COOH. So SOCl2 will remove this OH. So benzaldehyde you have to give na. So if this will remove this OH, obviously it will be converted into benzaldehyde. Okay, but then again it will be converted first into chlorine. Chlorine will be removing this na. So first it will be converted into acyl chloride. Then you will have to do H2PDBA, H2PDBSO4 Rosenmund reduction, right? Lindlar's catalyst basically. So make this CHO, benzaldehyde. So again then CrO3 H2SO4 strong oxidizing agent. So this is what? This is what? 1 degree alcohol. 1 degree alcohol converts into basically acid, right? It will convert into acid na. 1 degree alcohol is there, CH2OH, right? So it will convert it into first aldehyde, COH, then it will convert it into C double bond OH. Then NaBH4, NaBH4 only reduces 3 agents, 3 substrates. What? Acyl chloride, your ketone, and your aldehyde. So basically no reaction will be here. Simple. Then CrO3, CH3CO2. So this is basically anhydrous conditions and CrO3. So kind of Itard reaction. So convert this into acetaldehyde. बताओ. So which of the following reactions will yield? So first and fourth. Is it fine? बताओ. Done? Chalo. So oxidation of toluene to benzaldehyde can be easily carried out with which of the following reagents? So toluene to benzaldehyde ना, ये तो पढ़ा ही है, बताओ. toluene to benzaldehyde CHO. बताओ which reagent among these? Which reagent among these? अरे देखो ना, basically CrO3, Cr plus 6 plus non-hydrous conditions. So here acetic acid is in plus, like H3O plus is there, na? So basically non-hydrous conditions you have to see, anhydrous conditions. So acidic, anhydrite, right? And then your H3O plus. So H3O plus is after everything. So this is different thing. This is acidic workup. This you will do at last. But before that, CrO3 should not be in acetic acid. Acetic acid means it will contain some water. Acid here, it will contain some water. So this is acidic anhydride. So that is the best condition. Okay, so B is the answer. Okay. Major product of the following. Banao. H3O plus is given, cyanide is given, SOCl2 is given, PDBSO4 is given. So H3O plus means hydrolysis. Hydrolysis. So cyanide hydrolysis, what will happen? First it will form what? Amide. Then amide will form what? Amide will form what? Aldehyde. Or what? Acid. Batao. Batao, cyanide hydrolysis will form what? Acid it will form, aldehyde it will form, what will form? B to you are giving. B to you are obviously giving because it is PDBSO4 in the third. But what will be the hydrolysis? What will be the hydrolysis product of cyanide? What will be the hydrolysis product of cyanide? C. Cr. So अरे कहाँ गया यार, एक तो मिलता भी नहीं है ना भाई ये. Reducing agent. पता नहीं भाई कहाँ गया, छोड़ो भाई. हाँ वो तो मुझे भी पता है भाई, मिलती नहीं है चीज़ें, दिमाग और ख़राब हो रहा है मेरा. ठीक. So basically your hydrolysis, you are going into hydrolysis. So basically this will convert into CH3, CH2, COOH. Okay. Okay. Then basically SOCl2. SOCl2 will remove this and will convert into acid. Then PDBSO4. But then it will convert it into Cl. So after PDBSO4 it will convert it into Rosenman reduction H. So basically B is the answer. Aldehyde is the answer. Obviously aldehyde can be the only answer here. PDBSO4. Right? Chalo. So reaction with thionyl chloride. So that this I have already explained you na. You just have to see SNI and SN2. So what is happening? SOCl2 plus ether. Plus ether. So this will be SNI retention. SOCl2 plus pyridine inversion. Why? See, the point is SOCl2. SOCl2. Pyridine, what does it happens? What does pyridine do? pyridine, so if an alcohol is there, ROH, okay, it attacks on SOCl2, Cl. So this will go up, this will come back, Cl minus will take this H. So minus HCl will happen. HCl will leave, right? So but this pyridine takes this H and Cl minus will then attack at R from behind for SN2. That is what happens in SN2, right? Why? Because pyridine will take this H of HCl. So this in the presence of pyridine will go SN2, but in the absence of pyridine, what will happen? HCl will leave. So if HCl will leave, this will be SOCl, right? HCl will leave. So now again this thing will happen and Cl will attack from where oxygen is leaving. So this is SNI, internal nucleophilic substitution, that is it will take retention and the SN2 obviously will take inversion. Okay. So again with acid, SOCl2 will form acyl chloride and SO2 gas will be formed and HCl gas will be formed. And in alcohol along with SOCl2, if there is some other reagent, for example PCl3 is present, PCl5 is present, so it will form RCl. How? See, the mechanism is like this, something like this. So basically CH2OH plus PCl3. So this oxygen will attack here. So this Cl will go and take hydrogen. So then CH2OPCl2 will be there. This oxygen will again attack at phosphorus. This chlorine will go here and substitute this. So instead of oxygen, RCl will be present now. CH2Cl will be present now. Okay. Okay. So this is SN2, inversion will happen. Batao. So this is the reaction with thionyl chloride and these are the reagents like thionyl chloride, right? They will do SN2. Batao. Good evening, Bhai Mahesh. Good evening. ठीक है, चलो. The product formed in the following reaction. B2H6 is given. B2H6 we know what it does. It is a electrophilic reagent, right? So H2O2 is given. NaOH is given. So B2H6 H2O2 NaOH. So this is what? This is what? Hydroboration. Oxidation. Right? You need to understand the reactions. You need to identify the reagents which are given. So this is hydroboration oxidation, then this is PCC, then CH3MgBr. What will happen? What will happen? Batao. बताओ कितनी बची है भाई स्लाइड. तुम ये क्वेश्चन करो तब तक मैं देखता हूँ कितना बचा भाई. अरे हो जाएगा, तो बड़े आराम से हो जाएगा. ठीक है. बेसिकली ऑलमोस्ट 40 मोर स्लाइड्स. सो अभी क्या टाइम हुआ है? 8 बजे हैं, 2 घंटे में. हाँ ठीक है कोई नहीं, ठीक है चलो. सो बेसिकली हाइड्रोबोरेशन ऑक्सीडेशन, व्हाट हैपन्स? द एल्कीन, in the alkene, this alkene bond will be broken. H will be here, OH will be here. So there will be syn addition, right? Not anti addition, syn addition, and OH will be added to less substituted carbon. We saw that, right? So this will be, after hydroboration oxidation, the product will be CH3, CH, CH2, H, OH. Okay, then PCC. PCC is your mild oxidizing agent. So 1 degree alcohol, it will convert into aldehyde. CH3, CH2, COH. Then CH3MgBr, CH3MgBr, MEMgBr I can write. So Me will attack here. So this will convert into 2 degree alcohol now. CH3, CH2, CH3, OH, right? So is there something like that? 2 degree alcohol. CH3, CH2, CH, H will be there, na? CH, CH3OH. Batao. So did you guys find the answer? A. Vishwa, I will do physical, don't worry. In the next lecture, we will do physical and inorganic. Okay. So I won't do a lot of physical because Parth Bhai already has done physical, right? On the today only he did the physical, right? So basically I won't do a lot of physical. I will focus more on inorganic because physical I took the rescue series as well, right? So you can refer that as well. Okay, I will just do the important chapters for physical. Okay, so now KMNO4 major product, NH2 KOH. So NH2 KOH, this is obviously what Wolf Kishner, nahin? So B major product. So there is a hint in this question that tautomerization will occur in basic medium. So whenever there is a basic medium, tautomerization occurs, and whenever KMNO4 is there, obviously the medium generally is basic. If nothing is given, medium is basic. So that is a hint. Do this question. This is a good question. But are you guys liking organic chemistry? Physical chemistry, though, we'll see. Organic chemistry, are you liking? Are you able to understand what I'm teaching? Or is it just like, going above your head? Batao. So basically KMNO4. So first, do the tautomerization of this. What happens? There is a hydrogen. So KMNO4 is oxidizing agent, no? So ketone can't be oxidized, first of all. So that is a hint that ketone won't be oxidized. So if ketone won't be oxidized, you convert this into tautomer. So tautomerization, after tautomerization, the substrate will be OH R, right? So it is 2 degree alcohol. So then KMNO4. What will KMNO4 do? Batao bhai. What will KMNO4 do? KMNO4, basic medium, KMNO4, oxidative ozonolysis ना. अरे भाई गरीबो, oxidative ozonolysis जैसा product ही तो आएगा. ठीक. So break this. So if you are breaking this, O and R, okay. And this is OH, so basically OH C double bond O. So basically COH and OR. Ketone will be formed, obviously because this is 2 degree. So ketone will be formed here, and there is 1 degree. Basically, so double bond will be added, so ketone won't be further oxidized, but this will be acid only, right? So this is this, and then NH2. Wolf Kishner, bhai. So NH2 KOH. So basically this will remove this. This will convert this into what? R, simple R. So OH, sorry. Okay. Then hydrolysis, this is the same thing. So basically this will be the product, na? Nahin? This will be the product or not? Batao. भैया होमी 2.0 का होके भी पढ़ लेता हूँ. पढ़ ले भाई, तेरी मर्जी रुद्र. ठीक है, सही है. बताओ भाई. चलो next question. Ratio of x to y on completion of the reaction. So do this question. I am giving you 1 minute. देखो क्या होगा. So X moles of MEMGBr Grignard reagent and Y moles of our substrate is taken. So MEMGBr will attack here. So first of all, that is the thing that you will do wrong. That is the thing that you will do wrong. You will just take this and you will attack here. Simple, right? But no. So this is acidic hydrogen. So Me will first take this hydrogen and then it will attack here. So 1 mole of Me will be consumed by acid-base reaction and another mole will be consumed by this. So your final product MEOH H O minus. So basically here also it will be O minus, here also it will be O minus. Okay. So then you will do acidic workup H3O plus. Okay. Then it will be what? OH Me. So basically for 1 mole, if Y is 1, you need 2 moles X. So ratio of X to Y is 2. Okay? Okay? Clear? The correct structure of the product A formed in the following reaction. So this is A. So do this reaction. This is a very famous reaction. Second most famous reaction after aldol. What do you think? What is it? What is it? Do this. कितनी स्लाइड बची हैं भाई? टाइम का भी तो ध्यान रखना है. 1:30 हो गई ना. $162. ठीक है. अरे क्या मैंने क्या कर दिया? ठीक है. कौन से क्वेश्चन पे था भाई? 1:30 पे था ना. ठीक है. चलो जल्दी करते हैं. देखो, अरे मैं मार डालूंगा. ठीक है. चलो देखो क्या है. दिस इज वेरी फेमस रिएक्शन. What reaction? Cannizzaro reaction. Okay. My voice is going down, so don't feel like that I'm not like kind of well that much. Okay, please. Okay. So you guys give me confidence. Okay. Just be full of energy. Okay. Even if my voice is down. Okay. So this is Cannizzaro reaction. So what is Cannizzaro reaction? In Cannizzaro reaction, what happens? Your non-enolizable, like in aldol enolizable carbonyl is taken. In Cannizzaro non-enolizable, basically any carbonyl whose alpha protons are not available. So that is taken and reaction is done. Like, see, this is OD minus. So OD minus will attack on PHCHO. So what will happen? I will give you the mechanism because this is important. OD. So this O minus will open up and there is H. Simple. Then again OD minus will come. Okay. We'll take this D to form D2O. Like it would have been OH, then it would have formed H2O. Right? Simple. Whatever. So here the product will be formed PHC O minus O minus. So this is dianion intermediate. Tetrahedral dianion intermediate is formed. Now this will go back and hydride will be leaving. So hydride will be leaving and it will attack some other molecule. So it might attack the same molecule, the different molecule but same type, or it might attack some other molecule. So the other molecule here is also PHCHO. So if this is PHCHO only, so this H minus will attack where? Here. Okay. So this will be formed as PHCOH H2. Okay, so this will convert into 1 degree alcohol. This on the other hand, will be this on the other hand. But then here OH will not be there, na? Acha, देखो. What will happen? I will expand that as well. So basically, hydrogen will be there, hydrogen, and O minus will be there. Okay, O minus will be there, and this will be converted into PHCO O minus. Okay. So this O minus, it takes hydrogen from water, but here there is no hydrogen, there is D2O. So it will take deuterium from the solvent, PHCOD and H2. Okay, so your final product will be carboxylate ion, C, and A will be PHCH2OD. So I think this A, right? अच्छा साहिल, थैंक यू यार. अरे क्लेजन पर्किन भी हो जाएगी. क्लेजन पर्किन इज नॉट दैट मच इंपॉर्टेंट ब्रो, वो IIT जैम वगैरह में ज़्यादा पूछी जाती है. ठीक. नंबर ऑफ मॉलिक्यूल्स विच गिव हेलोफॉर्म टेस्ट. नाउ दिस इज वेरी इंपॉर्टेंट. हेलोफॉर्म टेस्ट. So number of molecules which will give haloform test. So haloform reaction. Let's see haloform reaction. Okay, what happens? Any carbonyl compound which contains 3 alpha hydrogen. So it will interact with a base. So what will base do? Base will enolize it. So base will convert into enolate, RCO minus, double bond CH2. Okay, then this will interact with base, not X2, base. So X2 is halogen, basically Cl2, I2, Br2. So this will then open up, this will attack X2. So this will form what? RCO CH2X. So similarly base will again come and will take now this hydrogen. Similarly this hydrogen will, so what happened here is one hydrogen base took, and instead of that hydrogen one halogen came. So base will again take one hydrogen, again one halogen will come, again base will take one hydrogen, again one halogen will come. This will go on two times. So the product will be RCO CX3. Now this CX3, Ci3, CCl3, Cbr3 is a good leaving group. Okay, it is a good leaving group. Okay, so then base attacks here. Base will then attack here, and this will leave. CX3 minus will leave. So if this base is OH minus, generally this is OH minus. So the product will be RCO OH plus CX3 minus. But this CX3 minus takes hydrogen from here because acid is carboxylic acid is more acidic, right? So the final product will be RCO O minus plus HC or CHX3. So this is haloform. If X is chlorine, so chloroform, iodine, iodoform, bromine, bromoform, so haloform. Okay, so this is haloform reaction. So then what substrates can undergo haloform reaction? That is the main thing. So any methyl ketone, basically ketone should have methyl. See, it can go because carbonyl should contain 3 alpha hydrogen. Then 2 degree alcohols oxidizable to methyl ketone. 2 degree alcohols, let's suppose this is the alcohol HCH3OH. So this is the alcohol. So this is oxidizable to ketone, na? So this will be oxidized to methyl ketone. This is so basically this will be oxidized to this methyl ketone. Okay, so again it will be giving haloform test. Then 1 degree alcohol, only 1 degree alcohol that can give this test is ethanol. Why? CH3 CH2OH. This will be oxidized to what? CH3 COH, aldehyde. Aldehyde. So this aldehyde also contains these 3 alpha groups, 3 alpha hydrogens. So none of the other aldehydes in this world contains 3 alpha hydrogens. Only acetaldehyde contains 3 alpha hydrogens. Only acetaldehyde. Okay. So see, this contains 2 CH. So if directly acetaldehyde is given, obviously it will also undergo haloform reaction. So you can see here. You can see here. So this carbonyl contains CH3, right? CH3. So it will undergo haloform reaction, right? Again, here no. This carbonyl contains 2 hydrogen. This contains OET, 2 hydrogen. So basically no alpha position has 3 hydrogens. So basically this can't give, this can give, right? There is 2-degree alcohol, but it will convert into ketone, but this ketone will not, this will have 2 hydrogen. So no. Then this is 1-degree alcohol, but this 1-degree alcohol, 2-degree alcohol, sorry. So this will be oxidized. This will be oxidized to ketone. So this is CH3. Theek? So this will undergo. Then this is already ketone, so no. Basically no alpha position contains 3 alpha hydrogens, and this is OH. So 1, 2, 3, 3-degree alcohol is there ना, तो यार ये तो वैसे भी 3-degree alcohol तो वैसे भी कहाँ ही कुछ होगा. So basically 1, 2, 3, 3 compounds can give haloform reaction. बताओ. Carboxylic acid. Carboxylic acid कैसे देगा भाई? Acetic acid can give maybe, but then this acid will interact with base now. First of all this acid will interact with base, so that is the thing. So and if this, see, if there is C double bond O, OH and CX3, so now base OH minus attacks here, so it will take this, so OH, C double bond O, OH, this will be the product formed, and HCX3 minus. Is this stable? I don't think so. I don't think carboxylic acid will go into haloform reaction. Okay, chalo. Haloform is done. Chalo. So products formed in the following reaction. Batao bhai. Ye to we know that this is your tolerance. This is your NaBH4 reducing agent. बताओ भाई क्या होगा? बताओ जल्दी बताओ. What will happen? देखो, तो tolerance reagent and phalanx reagents, they oxidize your CHO group, na, aldehyde group. They oxidize aldehyde to carboxylic acid. They don't oxidize ketones, right? They don't oxidize ketones. So convert this into COH. So if you are this won't be converted to anything, but this will be converted to COH, right? So the product will be A will be H COOH double bond O. After that NaBH4. So NaBH4 does not reduce acid. It reduces only 3 things: acyl chloride, ketone, and aldehyde. So basically it will convert it into 2-degree alcohol. भाई इतनी ऑर्गेनिक आज तक जिंदगी में नहीं करी है मैंने जितनी आज के दिन में कर दी. ठीक. ओके थैंक यू मत बोलो यार, पढ़ो बस. चलो OET minus number of chiral carbons in the product. Find out. find out. So OET minus, and here this is COET. So if this will interact with this, so this will remove this, what will happen? Nothing. Nothing will happen. So this has to interact with this, this has to interact with this, this has to interact with this or something else, but it can't, it won't interact with this carbon, right? It won't interact with this carbon. So this can be a base, this can be a nucleophile, whatever. So basically, and then again here this can be aldol as well, kind of aldol. So this will then interact with this. So 1, 2, 3, 4, 5, 6. So 6-membered ring will be formed. No? No? बताओ भाई. देखो क्या होगा. See. So this is CH2, C double bond O, CH2 minus will be there. Then this will take hydrogen, right? And on this carbon there is CH3, C double bond O, OET, right? So basically this will attack here. So number this. So the carbon from which you are attacking, number that one. 1, 2, 3, 4, 5, and last carbon is 6. So make a 6-membered ring. Okay. So 6-membered ring which is sharing 2 carbons. So basically bicyclic compound will be there. So okay, something like this. So give this as 6. This is 6, obviously. So this is my 5. This is 4. This is 3. This is 2. This is 1. So first carbon is CH2. Second has double bond O. Second has double bond O, right? Third has nothing. Fourth is this. Fifth has CH3, right? And this will have O, double bond O, right? Right? Double bond O ना? अरे ये वापस बन जाएगा ना भाई, खुलेगा, then this will form. So वापस बन जाएगा ना double bond O. So how many chiral carbons are there? I can see this carbon, this one, 5th carbon. Okay, this is chiral, right? I can see there is a hydrogen here. I can see this 4th carbon is chiral. I don't see any other carbon, so obviously 2 chiral carbons are there in this. बताओ, सही है? सही है? क्या टाइम हो गया भाई? 21. Okay. Arrange the following compounds. अभी है 30 slides more. So following compounds in increasing order of rate of aromatic electrophilic substitution reaction. तो electrophilic substitution reaction तो यार electrophilic substitution reaction, so obviously this will behave as nucleophile. This my compound will behave as nucleophile. So rate of reaction will directly proportional to nucleophilicity. बताओ भाई, आंसर बताओ. Give me the answer. Give me the answer, bhai. Olivia, which mechanism? Which mechanism? देखो देखो यार, increasing order of rate. So basically first we have to see lowest nucleophilicity. So see, the point is okay, so this will give some electrons, so this will be ortho and para directing minus, so this will be highly nucleophile, nucleophilicity is more, right? Similar to this it will happen, but this will have a minus I effect as well. But then again, not minus I, this will also have plus M, right? So there are two, here there is only one plus M, here there is 2 plus M, this and this. So obviously this will be more nucleophilic than B. Then what about this? This is your electron withdrawing group. So nucleophilicity is low and this basically again electron withdrawing group, but not as strong as this. So minus I will be there, so nucleophilicity will be less. So least nucleophilicity will be C. So increasing order, right? So C, then A, then B, then D. बताओ, is it fine? सही है? सही है? देखो, so CHCl3 is given, NaOH chloroform is there, NaOH and your phenol, then X will be formed, then NaOH, X, then salicylaldehyde will be formed. So basically intermediate X in the reaction is, so what is this? What is this? What is this? Riemann-Tiemann reaction. Okay, Riemann-Tiemann reaction. So what happens? CHCl3 forms into a singlet carbene. How? This OH minus base will take this hydrogen, this will take hydrogen, this will become C minus, so then Cl minus will be removed. So this will form into singlet carbene. So this singlet carbene contains a vacant orbital as well. So basically what happens? Now this phenol will attack via ortho to this carbon. Okay, okay, and obviously what will happen? So this will be attached to the phenol group. Okay, so C minus Cl Cl. Okay, and hydrogen is there, and obviously if this is attacking via ortho position, then हाँ ठीक है. So what will happen after that? What will happen after that? So this Cl will remove. This Cl will remove, or what can happen? What can happen? There can be a rearrangement. This hydrogen can go here. So if this hydrogen goes here, negative charge will come here. If negative charge comes here, it will again open up the oxygen double bond O, so aromaticity will be restored. So this new product will be formed. So then after that 2 OH minus you will add to replace these both Cl. So if these Cl will be replaced by 2 OH, so 2 OH on one carbon is not stable, so H2O will be removed, so this will form CHO. So basically salicylaldehyde you will form. So this is the complete mechanism. If you don't understand, you don't have to remember the mechanism. Just remember chloroform and basic medium and phenol is given. So basically what will happen? Chloroform, basic medium, phenol is present. So what will happen? Obviously here intermediate is being asked, so intermediate here X is this. This is the intermediate. Okay, so you can see the options. If this is given in the option or this is given in the option, only one will be given. If this will be given, most probably, so this will be the intermediate and the final product will be your salicylaldehyde. ठीक है? ठीक है? Rearrangement of carbon anion. हाँ, ठीक है. अरे साहिल, ठीक है भाई, पेशेंस तो क्या ही. ठीक है, चलो देखो, क्यूमीन. So cumene to phenol you have to form. So this is Hox process, na? This is Hox process of formation of your phenol from benzene. So you will add propylene to your benzene. So this will attack here, and or not here. Basically, it can attack here as well as here. So it attacks there. You don't have to remember things. The point is, this will be cumene. Isopropyl group on benzene. Is added. So that is cumene. So after that, you will react it with air, O2. So this, see, what will happen? This is isopropyl group, na? But there is a hydrogen here. So between this hydrogen and carbon, these two oxygen will be inserted like this. Peroxide bond will be formed. So this is cumene hydroperoxide. Okay. So this cumene hydroperoxide, from this cumene hydroperoxide, this whole CH3CH3O, this ketone, acetone is removed and OH is added to this, so phenol is formed. So this is Hox process. Batao. Understood? So basically in the cumene to phenol preparation in the presence of air, intermediate is. So what will be the intermediate? See, cumene hydroperoxide is the intermediate. Is there anything? Cumene hydroperoxide. देखो देखो ठीक है ठीक है 140 तक करेंगे, फिर थोड़ा सा 5 मिनट का गैप दे दूंगा. मेरे को समझ में आ रहा है तुम्हारी हालत क्या हो रही है. ठीक है, कोई दिक्कत नहीं. तो भाई करो यार, ये करो. H3O प्लस दे रखा है तुम्हें, एंड देन देयर इज OH, देयर इज एल्कीन. सो व्हाट टू डू? आई एम गिविंग यू 1 minute. Try to solve this. What can you do? H3O plus acidic hydrolysis. So I think that OH will take H plus. If OH will take H plus, then there is alkene. Things can happen. I am giving you a hint. Do this. So what are you guys doing? Are you able to understand what is happening? Are you able to understand what is happening? Someone is saying A, someone is asking D. A or D? Okay. Okay. अबे C कहाँ से हो रहा है? ठीक है. देखो what will happen. देखो यार, मैंने क्या बोला? This OH will take H plus, so it will convert into OH2 positive, right? If this will convert into OH2 positive, this will leave, forming a carbocation here. So if carbocation will be formed, do rearrangement na. Do rearrangement. 1, 2, 3, 4. अरे हट. ठीक है. So carbocation is there. So more stable carbocation can be formed. So there will be a CH3 migration. So if there will be a migration, so then positive charge will come here. So that is more stable positive charge. So now alkene will attack. So either this will attack or this will attack. So see, if this will attack 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. If this attacks 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So what will attack? 6-membered ring will be formed or 5-membered ring will be formed? बताओ. 6-membered ring will be formed ना. देखो. From here it can be 1, 2, 3, 4, 5, 6. So this will attack on this to form a 6-membered ring. So obviously then that hydrogen will go. So basically I am just forming the rings directly. So 1, 2, 3, 4, 5, 6. So 1 is this, 2nd is this, 3rd is this, 4th is this, 5th is this, 6th is this. So on 5th there is a methyl. On 5th there is a methyl. On 6th there are 2 methyl. So and obviously this alkene will be formed because hydrogen will then leave and alkene will again be formed. So I can see this compound B. ठीक. ठीक बताओ. ठीक है. So 140 slides are done. How many slides are left? Let's see. So 20:33, no? So I 22 slides are left. So let's give you 10 minutes of break. We'll meet at 28:45 and we'll complete this by 10 or 10:15 max to max. Right? Chalo. आ जाओ. Am I audible? आ जाओ. Let's go back. Last 20 slides are left. आ जाओ. Come on. I know you are tired. I know that you want to leave. I know it's happening. I know you are tired. But the point is, this is the last stage, right? Last stage. IIT is so close, right? So let's just work harder. Let's just work a bit harder, right? So it's okay. This is the last stretch. Give me 1.5 hours more, 1 to 1.5 hours, 1 hour 15 minutes, something like that. Give me more and I will complete this, and your complete organic chemistry except biomolecules will be revised. Okay, so आ जाओ. ठीक है चलें बताओ. चलें. अभी तक we saw what this obviously intramolecular reaction, then Hawk process, and then your Rimmer-Tiemann reaction, right? Rimmer-Tiemann reaction also we saw, right? So then now let's move on to next question. So this question is basically ethylene glycol. This is ester group. This is ester. This is ketone. This is ethylene glycol. H plus, LiBH4, H3O plus. Okay. So do this question. Sachin, focus on studies, okay? Focus on studies, bacha. It's okay. Don't be distracted. Focus here. Chalo. So, this ethylene glycol, if you don't know, this ethylene glycol is this. Ethylene means CH2, and this will be OH. So, this is ethylene glycol. So this acts as a protecting agent. So basically it attacks on the carbonyl group, okay, via its two OH groups. Okay, so this is nucleophilic. Why? Because it will attack via lone pair. So ethylene glycol is nucleophilic. So it will attack on the more electrophilic carbonyl. If only one equivalent is there, and more than one carbonyls are present, so it will attack on more electrophilic carbonyl. Okay, so what is the more electrophilic carbonyl among ester and ketone? Ketone, na? So this will attack here. Both of them will attack here. So when they attack, what happens? This oxygen will leave and these two hydrogens will leave. So H2O will leave, minus H2O. So A will be oxygen. Okay, so this is protected. So this group now is protected. This carbonyl carbon is now protected. No other reagent will be able to react with this. Okay, so this is OC2H5. So this is my A. After that, you are adding LiBH4. So LiBH4 will react with what? So only two reagents, two substrates LiBH4 does not react with is your acid and amide. So there is ester. So it will convert ester into what? 1 degree aldehyde. 1 degree aldehyde? Aldehyde is aldehyde, no? So this will convert into H. Okay, and then what? It will again give H. So it will convert into 1 degree alcohol. Okay. So then H3O plus is given. So H3O plus is acidic workup. H3O plus. So this is for removal of this group and restoring of the carbonyl group. So deprotection. This does deprotection. So basically COOH. Okay, so point is, the only difference that you have to see here, if acidic situations are not given, if only H2O is given, only H2O, no H plus is given. So D protection happens in acidic medium. If only H2O is given, no acidic medium is given, so no D protection. So you have to remember that. Okay, बताओ. Ketone restored. Yes, right. So बताओ भाई, क्या बोल रहे हो तुम? Okay, do this question, do the next question. So reagents X and Y are given. Okay, so this is the substrate. If it reacts with X, it will form this. If it reacts with if it reacts with Y, it will form this. If it reacts with X, it will form this. What can be X and Y? See, tell me, what can be X and Y? What can be X and Y? बताओ. What can be X and Y? See, so here this is acid group. So acid group is converting into COOCH3. COOCH3. And here alcohol group is converting into COOH3. So basically this COCH3. COCH3. So OH, let's suppose this is ROH. Okay, so this will attack at what? RCO, or let's suppose CH3CO Cl. So if this attacks at this, so Cl will remove and this will become OCOCH3, right? So this is obviously your acylation reaction, and then in your COOH, they are converting it into COCH3. So basically ester. So COOH is being converted into ester. So esterification is being done. So obviously you will attack with alcohol, methanol. So this will remove and H will be taken. So this will be COCH3. So basically Y will be your X. So X is written first. So first X will be there. So X will be your what? X will be acyl chloride. Or basically you can also do this anhydride. One and the same thing. Not one and the same thing, but they will do the same thing. Okay. So basically because acyl chloride is not given, so CH3COO, CO2O, so basically that is anhydride. So X is this, then this is not the case, so basically your answer will be A. This is anhydride. This is your alcohol, esterification. Fine. सही है, ए आंसर है. हाँ, बढ़िया. चलो A and B formed in the following. So this is HBr and you are heating, this is HBr, you are heating. Here you have CH2OH, here you have OCH3, basically ether, OH and OH. So what will be the reaction? Do this. What will be the product? Do this. See, so what will happen? So there is HBr, there is alcohol, so and then there is ether, there is HBr, and then heat is happening. So what will happen? What will happen? बताओ भाई, करो जल्दी. देखो ना क्या ही है ये, देखो. This lone pair will take H plus. Okay, this lone pair is involved in conjugation, right? So this lone pair will take H plus. So when it will take H plus, what will happen? CH2 OH2 positive. So this is a good leaving group. If this is a good leaving group, this will form. Obviously, if this is a good leaving group, there cannot be a particular, there is only alpha carbon, there is not a beta carbon. So here hydrogen can't go. So basically elimination can't happen. Even if they are given heat, elimination can't happen. No? So this will leave. So this will form benzylic carbocation, CH2 positive, OH, okay, and then Br minus will come. So this is kind of CH2Br, no? CH2Br, okay. Then there HBr is given. So if HBr is given here, there is a ether. It takes H. So if it takes H, so this will activate ether. OH, OH positive, CH3. So if this is CH3, then Br minus will either attack here, which it can't for SN2, so it will attack here, right? So this will leave. So basically OH will be formed and CH3 Br will be formed. Is it fine? बताओ भाई, किसको दिक्कत है? Is there anyone? Is there anyone who has any problem? So basically this will be B, this will be A. Okay, okay, let's move. ठीक है, चलो. So basically carbylamine test you have to see. So carbylamine test. So basically primary amines were produced through Gabriel thilamide reaction. But carbylamine test is used for identification of those primary amines. So both are different. Okay, don't be confused. Gabriel thilamide produces primary amines. Okay, but carbylamine test is identification for primary amine. Why? So this is amine, aniline, right? So CHCl3 and NaOH is added. So there is one other reaction, such like that, Rimmer-Tiemann reaction. We saw that. लग जाएगा टाइम, हाँ 10 साढ़े 10 बज जाएंगे. ठीक है. So obviously this will be a singlet carbene. So singlet carbene, this NH2 will attack on this singlet carbene. Simple. If this is attacking on the singlet carbene, it will form into NC. You don't have to see the process. So isocyanide will be formed. This isocyanide has a very foul smell. So because of this foul smell, you can identify that this is amine. This amine is primary amine. Okay. So again, so here aliphatic amine, aromatic amine, whatever amine it is, this is primary amine, na? Right? So this can form isocyanide. बताओ. ठीक है. So that is carbylamine test. ठीक है. So now number of compounds giving red coloration with seric ammonium nitrate and positive iodoform test. So here one more concept you need to know. Seric ammonium nitrate. So OH, alcohol group. Any compound containing OH. Compound containing OH will give red color with this seric ammonium nitrate. Okay. So first you have to see the compound containing OH, then you have to see whether that compound will give positive iodoform test. So you have to see two things. First, you have to see if that compound will give red coloration. Then you will see will that compound, it's okay, it is giving red coloration, will that compound give positive iodoform test. So basically mixing two particular identities. This is a very good question. Do the question. Do the question. So are you able to identify? Are you able to identify? See, पहले तो देख लो ना किसमें OH है किसमें नहीं है. So here there is OH, then here there is OH, right? Here there is a OH, and here there is a OH, and here there is a OH. Obviously, so these won't give the steric ammonium nitrate test. So these will fail in the first attempt itself. Okay. Then after that, let's see if these will give iodoform test. So basically, this should be oxidized. This should be oxidized. So basically, it will form this double bond O. So there is CH3 group. So this will form iodoform. Okay. Then this should also be oxidized to this double bond O. So CH3 group is there. So obviously this will also give iodoform test. Okay. Then this is 1 degree amine. So 1 degree amine will convert into this aldehyde. So this will not give your iodoform test. This is 2 degree, not 1 degree amine, 1 degree alcohol. What am I saying? So this will be double bond O. So again CH3 is present. So this will also give, but this is again 3 degree carbon, 3 degree alcohol. So this won't be further oxidized. So this won't give haloform test. So 1, 2, 3. 3 compounds will give this haloform test and this test with steric ammonium nitrate. बताओ भाई सही बात है? सही बात है कि नहीं है? So do this question. So basically major product of the following reaction: concentrated HNO3, H2SO4, and this substrate is given. Do this question. So basically concentrated HNO3 and H2SO4 will give NO2 positive. So this is nitration. Basically nitration will happen. So nitration will happen. So nitration, this is electrophile. So we are doing electrophilic substitution. So for electrophilic substitution, what is more important? What is more important? Our compound should behave as a nucleophile. That carbon through which this is getting attached, this should behave as a nucleophile. So basically this is electron withdrawing group. This is electron donating group but not plus M group. This is plus I group plus H group. So this is not electron, not plus M group. This is minus M group. This is plus M group. So you will see plus M group to see which carbons will have negative charge, because you have to do electrophilic substitution reaction. So this will go here. So minus, minus, minus. So ortho and para will have minus. But if this nitro will come here, so this will be very unstable. See, a lot of bulky or a lot of static hindrance, right? A lot of static hindrance between OH and NO2. Another NO2 won't come, right? So what will happen? Major product will be from para. Major product will be from para. So this will attack here. So major product will be para nitration. OH, NO2, NO2, CH3. Okay. So this is your. नहीं अब खा पड़ा है नहीं खाऊँ ठीक है टकाटक थोड़ी खाऊँ ठीक है चलो. So your major product will be this. चलो, major product of the following reaction. So here Br2 is in excess, here Br2 is in excess, Here there is COOH group. Here there is SO3H group. So what will happen? What will happen? बताओ भाई. बताओ भाई. Do you know this kind of reaction? What happens here? हाँ, steric hindrance at ortho. सही बात है सचिन, सही बात है. So what happens here? अरे OBR, अरे क्या ही. देखो देखो, this BR2 in such cases, make a note of this, make a note of this, make a note of this. In such cases, this BR2 where there is COH group, SO3H group. Okay, what this does, this is in excess and you are heating it. So what this does is it will remove all of this, all of this. So SO3 will release, CO2 will release. Okay, CO2 will release, and what will happen? One BR will be here, and not just here but here as well, ortho and para, ortho and para, because this is BR2 na, excess. So ortho will attack at BR, but this para will also attack at BR, and these will leave because these will leave as gaseous products. Okay, so these will leave. So both the A and B will be your OH, BR, BR, BR. बताओ. ठीक ठीक. हाँ, 2,4,6 bromophenol. That's right, 2,4,6 bromophenol. Okay, so this happens in this case only because these leaving groups leave as gases. Okay, so they will leave. Okay, chalo bhai. So largest chapter is over. Largest chapter is over. Carbonyls is over. Now let's move to last chapter that we will discuss, amines and diazonium compounds. Shall we move? Shall we move? So in the previous chapter there were a lot of important things: oxidizing agent, reducing agent, different name reactions, aldol, your Canizaro, your Remertiman, your Gabriel Thalamide, whatever, jo bhi. ठीक. And there were a lot of leaving groups, oxidizing agents, reducing agents, whatever. So basically you have to see those. Okay, so let's move to last chapter, amines. Amines, biomolecules I won't do, Sachin. You can revise that on your own. Biomolecules is वैसे भी not that much important in terms of IIT and NEST. Hardly one question comes in NEST, so you can revise those things. Amines is also not very much important, but if I was doing all the reaction mechanisms, I will have to contain amines. So biomolecules is all theory and theory, so you can do the theory yourself. Okay, चलो ठीक है, ठीक है. So how is the Josh? How is the Josh, मेरे जवानों? प्रतीक, मुझे क्या पता प्रतीक कौन है भाई. चलो यार, चलो चलो चलो. सो पहले हमें देखनी है डायजोटाइजेशन रिएक्शंस, मतलब डायजोनियम सॉल्ट्स कैसे बनते हैं, राइट? हाउ आर डायजोनियम सॉल्ट्स फॉर्म्ड? सो डायजोनियम सॉल्ट्स आर these N2 plus Cl minus, N2 plus Cl minus on an aromatic compound. These are diazonium salts. Okay, okay. So if these are diazonium salts, NH2, you will have to add NaNO2 and HCl. Okay, so basically in NH2, in aniline, you will add NaNO2, HCl, so it will convert it into N2 plus and Cl minus. You don't have to remember the mechanism, but that is diazotization. Okay, so basically this NaNO2 and HCl is just like HNO2, NH2SO4, and basically just like that. So this will produce NO plus. So this will produce NO plus. And if this is 3-degree amine, 3-degree amine won't go into diazotization. Okay, this is 1-degree amine. 1-degree amine is going into diazotization, not 3-degree amine. Okay, so this won't undergo diazotization. So what will happen? It will donate its electron. So this will be ortho and para donating, right? So this will attack at NO, and NO will be attached to the para position. So para nitroso compound. This group is nitroso. NO is nitroso. So you will form para nitroso compound. Okay, and if normal aliphatic, not aromatic, aliphatic 3-degree amine is there, so obviously it will attack at NO plus again. So here N nitroso compound will be formed. N nitroso, why? Because with N nitroso is attached. There with N nitroso will not be attached because lone pair of nitrogen was going into conjugation. So nitroso will be attached with carbon at para. So para nitroso compound and N nitroso compound. So that is the difference. Okay, okay, बताओ. चलो. Then Gomber coupling. Okay, so basically this is a coupling reaction in which diazonium salts are added to our aliphatic or aromatic compounds. Basically what happens is this diazonium salt here, this N2 plus and Cl minus. So N2 is a very good leaving group. Okay, good leaving group. So it leaves forming a radical here. So this radical will attack here to couple. Okay, okay. So N2 is a good leaving group. Okay. So basically Gomber coupling is coupling of two benzenes or two aromatic compounds where one is from diazonium salts. चलो आगे बढ़ते. Now coupling reactions, different coupling reactions, like we saw Gomber coupling, na? We saw Gomber coupling. Now right now we'll see different coupling reactions. So basically this is what aniline. So at para position of aniline there is hydrogen, right? And this is N2 plus Cl minus, diazonium salt again diazonium salt. अब मेरी आंखें चौंधिया गई हैं भाई. ठीक है, तो भाई what is happening here? See, so this triple bond will break. This N2 plus is there, right? So when this triple bond will break, now there will be no plus charge here. See what is happening. See. So something like this happened. N had plus charge. This lone pair will give to this one. So this will be triple bond, and this N will have this plus charge now. Obviously. But when this bond will again break, so then this N will have plus charge. This terminal N. Okay. So if this N has plus charge now after breaking of bond, okay. So electrophilic. This is electrophile. Electrophilic substitution can happen because my aniline is nucleophile. So from the para, this will be attached. See. So this is coupling reaction, kind of. So this is yellow colored dye. Okay. Aniline when reacts with diazonium salt produces a yellow colored dye, and that dye is this. ठीक है कि नहीं ठीक है बताओ भाई. I am giving logic as well. I am not saying you to cram things. I am giving logic as well. Okay. अरे सुबह का लेक्चर तो मैं क्या ही बोलूँ. मेरा भी सुबह ही स्टार्ट हुआ था भाई, 12 बजे मेरा भी स्टार्ट हुआ था. मेरा कौन सा रात को स्टार्ट हुआ है. ठीक है. So now if instead of aniline this is phenol, so again this thing will happen, but instead of aniline this will be phenol. So phenol when reacting with diazonium salt will produce a orange dye. Okay. One thing you have to remember. See, So this NH2 is basic. Aniline is basic, na? Aniline is basic. So we keep the pH acidic to control the reaction. Okay, to maintain the equilibrium as well, right? But this OH, phenol is acidic, na? Phenolic hydrogen is acidic. So you keep the pH basic to control the reaction. Simple. बस इतनी सी बात जाननी थी कपलिंग रिएक्शन में. देखो देखो. So now beta naphthol. What is beta naphthol? What is beta naphthol? See, this is naphthalene, na? This is naphthalene. On naphthalene, on this carbon, not at this carbon, at this carbon, if OH is added, so this is alpha, this is beta. So this is beta naphthol. So beta naphthol plus diazonium chloride. This is diazonium chloride only, yaar. वही है. This is this only. This only. And 2 plus Cl minus. ठीक. This is this only. Same, right? So OH minus is there. So what will OH minus do? What will OH minus do? OH minus can take this hydrogen. If this is taking this hydrogen, this will go here and this will attack here. Okay, why? Because these and these will be negative charged, this will be para. So this won't be that much effective in, making a bond with N double bond O, because there will be a steric repulsion, na, here. So basically this carbon makes a bond with your nitrogen pH. Again coupling reaction. देखो, ठीक है, coupling reaction. Beta naphthol with diazonium chloride. चलो भाई, ठीक है. तो फाइनल पूरा तुम्हारा, this is a map of amines. So these are the reactions of diazonium chloride, benzene diazonium chloride, right? This is benzene diazonium chloride and 2 plus Cl minus. So these are different reactions. Okay, so each and every reaction is simple. If you will go logically, you will remember everything. Okay, you will remember everything. So what is happening here? See, so first reaction, if you see, CuCl and HCl, copper chloride and HCl. So copper chloride, what does it do? It removes N2 plus. Okay, and add Cl. This is Sandmeyer reaction. Same type of reaction, CuHCl. Instead of CuCl, it is CuHCl. Same type of reaction, Cl N2. Now, how to remember this? Is Gutterman. See, here CuCl was present. Here Cl is not present. So here Cl went into gutter. So this will be Gutterman reaction. Simple. Cl is not present here, na? Cl is not present here. Only Cu is present. So Cl went to gutter. So basically Cu plus HCl, N2 will be released and Cl minus will be there. Because see, N2 is a very good leaving group, na? I told you. N2 is a good leaving group. So this will leave. When this will leave, what will happen? A positive charge type of thing will happen here. So Cl minus will then attack here. So this will be the reaction. Kind of. Okay. So Sandmeyer reaction, Gutterman reaction. Okay. ठीक. उसके बाद Ki. Now copper is finished. Let's move to potassium. So potassium iodide and heat. So again N2 will leave and iodine will come. Simple yaar. है ना? N2 is a good leaving group. Simple. And then again iodine is there. So if Cn will be there, Cn will come. See, KCN and CuCN. So Cn will come instead of N2, right? If H2O is there, so OH will come instead of N2. अरे बहुत simple है now. इससे ज़्यादा तो what can we do? We'll see this. Now this H3PO2 structure is this. Okay, so electronegativity. वैसे तो phosphorus is more electronegative, but the point is here hydride leaves. This is H minus leaves, and H minus will replace N2. So H will come here. So normal benzene, H3PO2. Okay, then HbF4. HbF4 is like BF3 and HF. BF3 and HF, right? So this will give F. HF will give F, na? Right? 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 Now C2H5OH, ethanol. Ethanol with diazonium chloride, what happens? What happens? This ethanol is oxidized to aldehyde, acetaldehyde. Acetaldehyde? अरे जो भी, हाँ ठीक है, जो भी है, ठीक है. So basically ethanol, right? So basically this oxidizes to ethanol. So if this oxidizes to ethanol, it will give H. See what happens. See C2, अरे चल जा भाई, वैसे ही हिम्मत नहीं हो रही अब. OH, ठीक है, C2H5OH, right? So for oxidizing this is CH3, CH2, OH. So this oxygen will form a bond here, and basically what will happen? CH3, C double bond OH, and this hydrogen will be leaving, right? That is what is happening, na? This oxygen will form a double bond here, this oxygen will be forming a double bond here. So basically 2 hydrogens will be leaving, so hydrogens will come here. Simple. So either you can also remember it like that, oxidation means removal of hydrogen or gain of oxygen. So this will remove hydrogen. So if this will remove hydrogen, so hydrogen will come here. Simple है ना, बस. ठीक है, बताओ हो गई तुम्हारी डायजोनियम सॉल्ट्स की रिएक्शन. वेयर टू गेट PDF? घर आ जाइयो भाई, अब तो घर ही मिलेगी तेरे को. ठीक है, चलो भाई, मैच द फॉलोइंग यार, ये तो कर लो अब. डू दिस, मैच द फॉलोइंग. So basically different reactions are given: Woods, Sandmeyer, Fittig, Gutterman. Match the following. देखो. So this is diazonium salt plus copper chloride and HCl. So copper chloride, this has chloride, CuCl2. अच्छा वहाँ पे Cl2 होगा क्या? मैंने वहाँ पे Cl लिखा हुआ है. This is Cl2. ठीक हो जाती है. बड़े बड़े शहरों में छोटी छोटी बातें होती रहती हैं, छोटे छोटे शहरों में बड़ी बड़ी बातें भी होती रहती हैं. जहाँ मर्जी बातें होती रहे, मेरे को तो अभी नशा चढ़ रहा है बस. ठीक, तो पॉइंट ये है कि बेसिकली यहाँ पे क्लोरीन है ना, सो दिस विल बी सैंडमेयर ना, देखो. बट जहाँ पे क्लोरीन नहीं है, वेयर क्लोरीन इज नॉट प्रेजेंट, सो दिस विल बी योर गटरमैन. क्लोरीन गया गटर में. सिंपल. नाउ this will be 2Na, so Na and Cl will be gone, so coupling of C2H5, this will be Woods. And then if this coupling is of aromatic C6H5, this will be Fittig. ठीक बताओ. ठीक है. टोटल नंबर ऑफ amines among the following which can be synthesized via Gabriel synthesis. So I told you, I also showed you the mechanism. So do this question. I showed you the mechanism as well. भगवान उठा ले भाई, ये सचिन और दिशु को उठा ले भाई, पागल कर दिया भाई. सो भाई बताओ, टोटल नंबर ऑफ amines among the following which can be synthesized via Gabriel synthesis. देखो क्या बोल रहे हो तुम. देखो यार, so Gabriel thalamide synthesis will give 1 degree amine, primary amine only, nothing else. So this is primary amine, this is primary amine, this is primary amine. Number of amines among the following which can be synthesized ना. अरे वो तो ठीक है, ये नहीं हो सकता ना. प्राइमरी अमीन तो ठीक है, प्राइमरी primary aliphatic amine. Right? So this can't be done. This can be done, right? And this can be done. So this is aliphatic na, CH2, right? So 3, I think. 3 or 4. What will be the answer? Arey 1 degree amine but aliphatic, not aromatic. Okay? So let me check the answer. भाई कुछ भी हो सकता है यहाँ पे, केमिस्ट्री है तो वैसे तो मेरे हिसाब से तो यही है. चलो तब तक यू डू द नेक्स्ट क्वेश्चन. अरे ये तो गैब्रियल थैलेमाइड ही आ गया. वही है देखो देखो ये तो बता ही दिया है. प्रिपरेशन ऑफ प्योर प्राइमरी एलिफेटिक अमीन्स. देखो मैंने बता ही दिया. Pure primary aliphatic amines. Aliphatic amines will be prepared. So basically I told you na, this OH will take this H. So then this will attack at R. If this will attack at R, then you will hydrolyze this. So basically this R should be, the R should be such that where SN2 reaction can happen. So if this R is, let's suppose this. So nitrogen can't do SN2 reaction here. So if it can do SN2 reaction, then only aniline will be formed na, and will be attached to this benzene then only na. But point is that is not going to happen because sp2 carbon does not allow your SN2 reaction. So both are 2, sp2 and SN2, but both don't match together. So likes repel each other. Okay, so pure aliphatic amines. So basically 1, 2, here it can happen. See, if this is my CH2X. Okay, so here it can happen. SN2 can happen. Okay. Or SN1, if not SN2, SN1. Okay, whatever. SN reaction can happen, but SN reaction here will be happening by SNAR. That is very difficult. Okay, here. That is very difficult. That is why primary aliphatic amines will be there. Chalo bhai. Okay, products A and B in the given reaction. Batao bhai. This is amide, this is also amide, this is bromine, KOBr. So this will give OBr minus. I will give a hint, you have to do. This will give OBr minus. So then this is LiAlH4, this will give H minus. Dekh lo bhai, batao. What will happen? Give me the answer. Fast, bete. So OBr minus will do what? देखो. First of all, see, OBr minus, how will it form? So you will add Br to your KOH. Okay, so this OH will take Br. So this is how, not OH, basically, or you will say KOH also you can add what? See, Br2 and then, okay, so Br. So KOH will be there. So OH minus will attack at this. So it will be HOBr. So HOBr and Br minus will be there. So Br minus will take this H. So this will be OBr minus. Okay. This is how OBr minus is formed. So if they are giving Br2 plus KOH, you need to understand that is OBr minus only. Okay. First of all. So this OBr minus, what it will do? It will remove this whole CO minus CO. Decarbonylation. Looking like a Bengali word. So A will be NH2 Br. Okay, A will be this. Then this is LiAlH4, na, strongest reducing agent we have. So obviously this will convert into aldehyde, and then after aldehyde it will convert into alcohol, primary alcohol. So basically B will be Br CH2 NH2, not primary alcohol. Basically amine. It converts this into amide into amines ना, LiLH4. प्राइमरी अल्कोहल पे हाँ भी भर रहे हो, बताओ गरीब. सो दिस इज बी. ठीक 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 है. हाँ, CO रिमूव्स. अनिमेश भाई कहाँ खाया खाना, सुबह से फल फ्रूट पे जिंदा हूँ, और तो क्या ही है. इनकरेक्ट स्टेटमेंट रिगार्डिंग द रिएक्शन गिवन बिलो. भाई देख लो, दिस रिएक्शन इज गिवन, द स्टेटमेंट्स आर गिवन, द रिएक्शन इज व्हाट, 3 degree amine. Which amine? 3 degree aromatic amine. Okay, with NaNO2 and HX. So basically, which compound will it form? See, give me the incorrect statement. क्या टाइम हो गया? So 9:30 it is. बताओ भाई, which will be incorrect statement? बताओ. So basically electrophile involved in the reaction is NO plus. So I told you na, this will form NO plus. So this is correct, this is not incorrect. Okay, so N-nitroso ammonium compound will be formed. No, N-nitroso compound नहीं बनेगा. Here para-nitroso compound will be formed. So this is incorrect. Okay, so reaction occurs at low temperature. Even if you don't know that, see, this is saying about low temperature, and the product B formed is para-nitroso compound at low temperature. This is also saying about low temperature. So you know that it is para-nitroso compound will be formed. That is right. So this reaction should be right. And if this is wrong, if this is at high temperature, let's suppose this is at high temperature, then this should be also wrong. But the point is, this question was MCQ, not MSQ. So only one can be wrong. So obviously both can't be wrong. So obviously this won't be high temperature. So you need to apply your common sense in the exam. Okay, you need to apply your common sense in the exam. Half of the times the examiner will give you a lot of hints. Examiner is your friend. I always say, most of the teachers say that examiner is your enemy. No, nah. He is your best friend. In the question only he will give you 1 or 2 hints. It's your garibi that you are not able to identify those hints. He is not done anything wrong. Okay, he is giving you hints. But it's like कि लड़कियों के हिंट भी हम वैसे नहीं पहचान पाते हैं, तो एग्जामिनर तो ठीक है. सो बेंजाइल आइसोसाइनाइड कैन बी ऑब्टेन्ड बाय. करो भाई, करो. बेंजाइल आइसोसाइनाइड, पानी पीता हूँ मैं तब तक तुम करो भाई. बेंजाइल आइसोसाइनाइड विल बी दिस CH2 NC isocyanide. देखो देखो ना यार, ये तो मैंने बोला ही था ना, दिस इज AgCN ना, सो दिस इज कोवेलेंट बॉन्ड, सो नाइट्रोजन will attack here and will remove this Br, so this will be this only NC, so this will form definitely. Now what about this, what about this, what about this, will anything happen here? This is NH2 CH2, so obviously this is CHCl3, so this is basically aqueous KOH, so then what will happen, what will happen, बताओ भाई. बताओ भाई. So basically this CH2NH CH3 is there or what? नहीं नहीं ठीक है ठीक है. So अरे यार ये तो your carbene will be formed ना, CCl3, CCl3 will be there, so CCl3 will then be converted into CCl2, carbene, carbene, right? Aqueous C, aqueous KOH will convert this into carbene, then your NH2 will be added to this. So if your NH2 will be added to this, then basically how will it form NC? I don't know. So basically this won't be NC. Will this be NC or this will be NC? बताओ भाई, हो जाएगा ना गरीबों. देखो भाई यार, नींद आ रही है भाई. So basically what will happen, देखो देखो, CH2 and this N H2 will be there, so this will attack on CCl2, 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 so this will be positive, so this Cl will take this H, this one Cl will also take this H, so basically there will be NC, so basically this will be forming NC ना, और क्या ही करेगा ये, क्या ही कर लेगा ये. Okay, okay, then again CHCl3 aqueous KOH, again singlet carbene, singlet carbene, but here there is not two hydrogen, there is only one hydrogen, so though ये जो 2Cl हैं, they won't be able to take two hydrogen here obviously, so this won't form the reaction or the benzyl isocyanide because of inavailability of two hydrogen, and then this is OTS, good reducing agent, good leaving agent, क्या हो गया मुझे. Then there is CaN minus and K plus, so this Cn minus will remove this, so this will be benzyl cyanide, benzyl CH2 Cn. Okay, so this will also not be formed, so A and B is the answer. Is it fine? Is it fine? D नहीं होगा भाई, D नहीं होगा, D नहीं होगा भाई. चलो, मेजर प्रोडक्ट ऑफ द फॉलोइंग बताओ भाई. So C double bond O NH2 CH2 CH3 is there, so this is amide, this is CH2 CH3, Br2 H nu and KOH dilute KOH, बताओ. हाँ भाई थक तो गया हूँ, लेकिन देखो कितनी स्लाइड बची है, 160 पे हमें 162, सो लास्ट 3 स्लाइड्स आर देयर, तो ठीक है कोई दिक्कत नहीं. चलो टाइम भी कितना हो गया, मैंने बोला था 10 बजे तक कर दूंगा, देखो 42 हो गए, हो जाएगा 10 बजे तक हो जाएगा, करो. यू डू दिस क्वेश्चन. ओके, हमारा क्या है भाई, हम तो थकते ही रहते हैं. देखो व्हाट विल हैपन, बताओ. Br2 H nu फोटो हेलोजन से दे लगता है. अबे सचिन क्या बोल रहा है, हिंदी तो बोल. इंग्लिश वाले चैनल पे इंग्लिश नहीं बोल रहा, हिंदी तो बोल ले, वो भी नहीं बोली जा रही. वैसे ही मैं थके हुए मैं ज़्यादा रोस्ट कर देता हूँ. ठीक, देखो व्हाट विल हैपन यार, व्हाट विल हैपन, अरे कुछ भी हो, भाड़ में जाए, जो मर्जी हो, दिमाग खराब कर दिया। ठीक है भाई, तो देखो व्हाट विल हैपन, this H nu and Br will form your bromine radical, Br radical. So this Br radical will form CH radical on this carbon, See why? Because this will be more stable due to resonance. If this will be formed, CO NH2 CH radical CH3. Okay, so Br again will attack here, again. So this will be now what? CO NH2 CH Br and CH3. Okay, so Br is a good leaving group. So KOH dilute KOH. What will KOH do? What will dilute KOH do? अरे भाई कुछ नहीं करेगा भाई, ये छोड़ दो तुम. So this will happen here. This will attack. This lone pair will attack on this and bromine will leave. So 1, 2, 3, 4, 5. 1, 2, देखो, do the numbering. 1, 2, 3, 4, 5. Okay, so form the ring. C double bond O, N. So 1, 2, 3, 4 carbon this. Okay, and on this carbon there is a methyl group. Okay, so this is what? NH2 positive. So OH minus, dilute OH minus is basic workup. So OH minus, we take this. So this will be normally NH, simple na? Simple. So thalamide, type of thalamide. In thalamide there will be CO, C double bond O, but obviously type of thalamide. Okay, बताओ भाई, बताओ सही है? सही है, चलो. So those who have stayed from the starting in the class, you guys are really serious. So I hope तुम लोगों का हो जाए भाई. This is the second last question of this class. So Br2 AlBr3 H2PD NaNO3 HCl H3PO2. Do this. So there is NO2 and there is CH3 and Br2 AlBr3. So AlBr3 obviously is there for increasing the electrophilicity, right? So do this. I've given a hint. भाई बूढ़ा हो गया मैं, टांगे दर्द कर रही है मेरी. भाई बैठ के कैसे पढ़ाएंगे, बायोलॉजी थोड़ी है कि बैठ के पढ़ा देंगे कुछ भी. मतलब ठीक है, कुछ भी ठीक है. देखो भाई, सो Br2 AlBr3, तो यहाँ पे तो तुम्हारी इलेक्ट्रोफिलिसिटी बढ़ेगी ना, इलेक्ट्रोफिलिसिटी विल इंक्रीज. बताओ भाई. सो बेसिकली व्हाट विल हैपन, देखो, Br Al Br3. So this will be electrophilic, more electrophilic, right? This Br will be more electrophilic, right? So here R carbon should be nucleophilic. This is electrophilic addition, electrophilic substitution. Okay, so R carbon should be more nucleophilic. So basically this is electron withdrawing group. So basically this will withdraw electron from here, and from here. So basically meta positions have more meta positions have comparatively more electron density. So from meta position, any meta position you can do. So you can attack here and this will leave. So basically you can do the electrophilic substitution reaction NO2 CH3 Br. Okay, so then H2PD, what will H2PD do? H2PD, so then NaNO3, and so H2PD basically it will convert this into your NH2 ना, it will convert this into NH2 ना यार. NO2 को मैंने बोला था ना FeHCl, H2PD, SnCl, basically this will convert this into NH2 ना, reduce. So CH3 Br NH2. So after that NaNO3 and HCl, NaNO3. So there will be diazotization, HCl, 0 degrees Celsius. So this is diazotization. So benzene diazonium chloride will be formed, not benzene, but yeah, just like that. CH3 Br N2 plus Cl minus. So then H3PO2. So H3PO2 is what? H3PO2 will remove this and produce hydride. So this will be H3PO2. So CH3 Br. ठीक, बताओ बताओ, is this fine? Is this fine? ठीक, यही बन रहा आंसर, देख लूँ मैं एक बार, यही बन रहा भाई, ये बन रहा. So this is the last question of this class. Major product formed in this reaction. So NaNO2 aqueous HCl is given. So do this. NaNO2 aqueous HCl 0 to 5 degrees Celsius. What will it be? Do this. सचिन, तो तू भी तो डेडिकेटेड है, लाइब्रेरी में सब गए, तू तो है, तो तेरा भी आईआईटी होगा ना भाई, क्यों टेंशन ले रहा है? मैंने तो खुद नहीं निकाला कभी आईआईटी. किया हुआ? हुआ क्या? बताओ. N2Cl after ring expansion. देखो देखो देखो. So this will convert into this NaNO2 and aqueous HCl will convert this into N2 plus and Cl minus. See, N2 plus Cl minus again. So N2 plus is a good leaving agent, leaving group, right? So this will leave, and what will be formed? What will be formed? This carbocation is formed. So ring expansion can happen here. So when ring expansion will happen, so this will form 6-membered ring, right? 6-membered ring. So basically 1, 2 and 3. So 1, 2 and 3. 1, 2 and 3. So here positive will come. But then there is aqueous HCl and 0 to 5 degrees Celsius. So there is water na, obviously there is water. So this H2 will attack here. It will convert it into OH. ठीक है भाई. अच्छा भाई, बढ़िया है भाई. मेरी वाली कहाँ गई? मेरे से क्यों पूछ रहा है भाई? मेरे घर नहीं है वो. ठीक, देखो. सो डन. एक बार आंसर चेक कर लेता हूँ भाई. Okay, so with this, your IUPAC, structural isomer, stereoisomers, basically optical activity, hydrocarbon, aldehyde, ketone, basically carbonyls, alkenes, alkynes, amines, all of this is completed. Whole organic is completed today. Okay, ठीक है. तो कैसा लगा लेक्चर? How was the lecture? Good. भाई इतनी मेहनत करी है, कुछ फीडबैक तो दे दो कि तुम भी थक गए हो. थक तो गए होगे यार, गरीब लोग हैं बेचारे. अरे ये किया नहीं क्या हमने? ये वाला कर लेना भाई, ये पता नहीं कैसे रह गया. ठीक है, डू दिस, होमवर्क कर लेना. ठीक है, तो भाई इसके साथ हमारा महा रिवीजन for organic chemistry is finished. ठीक है, I hope समझ में आया हो. See, the point is not that you will just see this lecture and you will sit at home and you will be like okay अब तो हो जाएगा. नहीं, this lecture you have taken, revision is done. Do revision once again from these notes if you will find them. If you won't find them, you can also make your own notes of these notes and you can do the revision from them and do extra question practice. Only then your organic will go from 60-70% to 90% and that will help you a lot. Okay, so I'll see you next time on Monday, and on Monday I am telling you we'll do physical plus inorganic, but I am only going to do important chapters because physical already part B has covered, right? So I am only going to do important chapters because physical I have covered in rescue series as well, right? So inorganic I will do your coordination and your chemical bonding. That's it, because these are the most important chapters for your IIT. Okay, that's it. S&P block has been added, but it has been added for NEST. So I don't think that S&P block, because you guys must not have studied that also. So I don't think, because they are large chapters, so I can't take them in Maha revision because most of the time will be then consumed in S&P block only. Okay, so I will do coordination and chemical bonding. These are the most important chapters. In physical, what we will do? We'll start with SBC and solution. Okay, we'll revise. Then we'll do structure of atom. Okay, then we'll do thermo. I will leave chemical equilibrium and ionic equilibrium. These are not that much important for IIT. You can see from part B as well. Okay, and chemical ionic equilibrium I have done in rescue also, so you can see from there. So I will do thermo, this is important. Then I will do electro, which is one of the most important chapter of IAT. So I will give maximum time in electro and kinetics because these are the two most important chapters for IIT, and then we'll end our physical. So 1, 2, 3, 4, 5, 6, 7. So basically 7 to 8 chapters we will cover in your Monday lecture. Okay. ओके, ठीक है. हाँ, पार्ट भी करा दिए ना आयनिक इक्विलिब्रियम, उनसे कर लेना आयनिक और केमिकल. ठीक है, आपकी शादी जल्दी हो जाए. अबे श्राप क्यों दे रहा है? ठीक है यार, चलो यार, ध्यान रखना अपना. ऑल द बेस्ट, टेक केयर एंड कीप स्टडिंग. दिस इज द लास्ट टाइम. सो